Let me check if there are any other people, and then we get started. Okay, so let's get started. Good morning, everyone. Thank you for coming. I'm Surud More. I'm the manager of the OAE Center India. So let me explain what each of these terms mean, complicated acronyms. So first of all, IU is the International Astronomical Union. This is a union of professional astronomers who are from all over the world. So we get together and we have decided that there should be an Office of Astronomy for Education that should be set up. So that's why it's OAE. And you will notice that it's not astronomy education, but astronomy for education. And there's a very specific reason for this, is that we want to use the charm of astronomy in order to get students into science education. So if you look at what is going on in the country, usually there is a lot of children who are asked to go either to medical sciences or to engineering and so on, while the basic sciences are kind of being neglected, and that's the reason why we want to do this. Okay, so that's the reason for the name. The head office of this office, of the Office of Astronomy for Education, is in Heidelberg in Germany. And there are multiple centers and nodes all over the world, and we are the nodal center for India. Okay? We are in this place called IUCAA, which is the Inter-University Center for Astronomy and Astrophysics. It was founded in 1990s. We try to nucleate astronomy in universities in India, but part of our mandate is also to get students interested in astronomy. And so doing science popularization was one of the things that IUCAA has been doing and continues to do. But we are also now trying to get into school education so that we can help you out, wherever things, in whichever ways we can. So that's the genesis of this OAE Center India. The OAE Center India is a joint collaboration between IUCAA and this other institute called TFR HBCSE. TFR stands for Tata Institute of Fundamental Research, and HBCSE is the Homi Bhabha Center for Science Education. Okay? So it's a joint endeavor between these two institutes. TFR HBCSE is in Mumbai, so if you are ever traveling to Mumbai, reach near Anushakti Nagar, then you can visit HBCSE too. The center was established in February of 2022. These are some of the people associated with it. Myself and Aniket Sure. We are the manager and deputy manager of the center, but then we are assisted with a whole bunch of postdoctoral fellows as well as staff who work with us in order to get this possible. So what are the main activities of the OAE Center India? We would like to professionalize astronomy education. I'll come to what each and everything, all of these things mean. We would like to provide access to good resources. The third thing is promote astronomy in curricula, in school curricula. And then finally, we want to create and nurture a network of astronomy associates. Okay? So teachers like you would be interested in astronomy, would like to teach astronomy, and get students interested in astronomy, would like to create a network. So what do we do in order to professionalize astronomy education? We organize teacher training programs for school teachers. Here it says upcoming, but of course this is the one that you are attending. The one at IUCAA, the dates are February 16th and 17th instead of 17th, 18th. There's going to be another parallel program which is going to be held in Calicut in the coming week. So these dates had a slight change, so 20th to 22nd of February. So in order to professionalize astronomy education, we try to conduct these kind of teacher training programs all over the country. There's one which was organized in Modern High School in Calcutta. And that was a joint collaboration again between Presidency University and St. Xavier's College and the school. So when we get together, we talk about astronomy. It's not like we pretend that we know how best to teach astronomy. Of course, you have been in the field, you interact with school children often, and you know what works best for them. What our aim is to get you to understand the concepts from astronomy really well, and then you can help us tell us like how we can get together and get these concepts to the students. Okay? So we have done, for example, Mopia Maji, who is here, she's a postdoctoral scholar. She has done research in astronomy education, and one of the things that she has found out is that students in general do like astronomy. They would like to learn about the topics in astronomy, but some things are lacking, which means if you ask them about some simple astronomy concepts, sometimes they get it not correct. Okay? And students are in formative years, which means if they build some mental models of what is going on and how to explain a particular concept, then it stays with them for many, many years. Okay? Until that concept gets shattered for some reason, right? And so ideally what we want is the concept that is there to be built in the appropriate manner. And I think you guys can play a big role in that. And that's the reason why we try to conduct this kind of workshops. In addition, we provide access to good resources. So there are multiple different things that we have created. You will get copies of some of these, not everything. So this is a book about Savai Jensen's Jantar Mantar observatories that we have gotten translated into 15 different Indian languages. All the PDFs are available online and for free. So you can take a look. We will try to give you one of these copies. Then there's this book about big ideas in astronomy. So the OAE main office, they came up with this idea of what is literacy in astronomy. So we know literacy about reading and writing, but astronomy is such a nice subject that it actually tells us where we came from. That there are few concepts about astronomy that everyone should know. Okay? So what are these concepts? That is given in this particular book called Big Ideas. That book, again, we are trying to translate. In fact, if you can help us out in some of the regional languages, that would be really good. So we will also give you a copy of this. In between, there was a book about different articles on positional astronomy, which was also run by a magazine at HPCSE called Ananti. We have collected all the astronomy-related articles in it and put together a booklet. That is still under review, but as soon as it comes out, it will be made available publicly on our website. Then there is also a deck of cards about astronomy terms. So we would like to know or to tell you if there is an astronomy term that you encounter, you can go here and look at the definition. What does it mean? And you can get a few ideas. So that's why this astronomy glossary was prepared. And we at the OAE Center India are trying to create this kind of cards so that you can distribute it to them and you can use it like a pack of cards when you play. You learn about this concept.
Is it available online also?
So these things will be soon available online. So these are still under review. Those two things are available online, but we'll also give you copies. So then comes the next thing, which is to promote astronomy in curricula. What we would like to do is to take astronomy concepts, and because they are all interesting in terms of attracting students, then to explain complicated concepts in science with by using examples from astronomy. Astronomy is also a good subject because it allows you to learn how to do science. And that's the reason why I would like to promote astronomy in curricula. So we have conducted multiple different surveys in order to understand how astronomy is perceived by students. We are trying to understand whether the the basics of astronomy topics, are they clear for the students or not? We would like to know whether they have a desire for learning different things in astronomy. And finally, we would also like to know if they would like to take up a career in astronomy. Do they know what is the path? So these are the kind of things that we decided that we need to check. Before we try to promote astronomy in curriculum, what is the baseline for what is going on in the country? So in order to do this, we have conducted like multiple different surveys in multiple different states. And we have also carried out interviews for teachers who teach astronomy related topics in order to understand this a little bit more. And finally, we also would like to develop tools like this in order to assess what is the content that is there in textbooks already. So astronomy is not taught as a subject separately, but you have multiple different things from astronomy put in either geography textbooks or science textbooks, right? And so what we are trying to do is go through different sets of textbooks and try to understand what are the list of concepts that are introduced in these textbooks. Are they enough to understand these astronomy topics or not? And then we get astronomers as well as education researchers and teachers like you to grade that content in the textbook. And we are hoping that with this, we can find out if there are any deficiencies, if there are good things, there are bad things, things that need to be removed, things that need to be put in. So in order to do this, Asmita Reddy here, she has developed a tool for assessing this astronomy content in textbooks. So this is also publicly available now. And we are using this to carry out astronomy. And then finally, when it comes to networking and outreach, we try to show our presence everywhere in the world as well as in the country. So there was the Astronomical Society of India meeting that happened, and we had a workshop related to these kind of topics where astronomy educators and outreach activists, they came together in order to learn from each other how well can we do things together. We have done presentations at the IAU General Assembly in Busan, South Korea. There's the Shaw Prize workshop for which we helped out. There was a G20 exhibition here in Pune University where we had a booth. So these kind of things are things that we do for it. So if you would like to get in touch with us, of course, there are all these websites and Facebook and Twitter handles. Whatever you are familiar with, you can use and get in touch with us. You also have an email address where you can send us emails. And as I said, this material will be available online. So it's not like you need to write down the notes immediately. Okay. Okay, good. So I can take questions right now, and then after this, we will go on to the next aspect. So are there questions right now related to any of what I said?
Just curious, can teachers also collaborate with the researchers? And suppose you people are researching on a concept or a concept, basically right now something you're researching upon, maybe a galaxy or a supernova, you're researching on it, and maybe we teachers could collaborate with you and also learn the research skills.
Yes, yes. So
is there a possibility? Because the thing is, once we get into school, we become very narrow-minded with a limited amount of content, and our skills also need to be polished. So is there like a bridging gap or like some workshop that you can do for us so that we can bridge the gap of our skills and then we can help?
Very good.
Because we need that.
I completely understand. So IUCAA regularly organizes these things for refresher courses. So in principle, you could apply for some of these refresher courses where you can learn, first of all, the basics of astronomy and what is going on at the cutting edge research. And in case you are interested in order to carry out astronomy research, not just astronomy education, of course, here we do both. But if you are interested also in astronomy research, then you can approach some of us and we can talk. Yeah. Okay, so yes.
Are there any spaces where to generate the curiosity among students? See, since I'm dealing with kids since long time, so they love astronomy.
Yeah.
but the visualization and things are a bit at the back end. And according to the curriculum and things we have to do, this is staying behind. Yes. So are there any spaces or any places where, if suppose my kids want to go and visit or field visit or something, if I get some of the sources as such, this will definitely generate a good curiosity and motivation.
Yeah, I completely agree. Yeah, I completely agree with this. And there are places like museums and planetarium which are useful for these kind of purposes. IUCAA hosts an open day on 28th of February. We welcome all students here and we set up lots of exhibits. But in this particular program, what we would like to do, you are absolutely right that visualizing things in astronomy is quite complicated, especially for young kids, because we can still think us and try to look at the solar system from outside and so on and so forth. It is very hard for kids to try to do that. But during this workshop, what you will hear is activities that you can do and role-playing things that you can do conduct within the class, which will try to bridge this gap. So that is our motivation. So many of the topics that you will hear about, you will also hear about activities that you can do within the confines of the class, which will try to solve this problem. Okay. Yes.
Sir, as you said that promote astronomy in curriculum.
Yes.
So is there any process for teachers, that which teachers you're going to select for that grading and?
No, so we have been trying to be a little bit more random about these things, because if you do a selection, then you need to understand the selection bias, right? And because we want to publish these things as research articles, then we need to be careful about it. So there's not a specific thing that we look at. Typically, we go to schools, select teachers who have been teaching these topics, and then try to conduct either the interviews or the grading of these textbook tools, etc. Okay? Yeah. Okay, good. So the next task is going to be Mafia will take over, and she will tell you about this. Sorry, right? Wanted to make sure that I'm not getting. And yeah, you don't need to call me sir, of course. I mean, I'm either of similar age or maybe even younger than you. So just feel free to call me Surul, no problem whatsoever. The same with any of our colleagues. Let me introduce the colleagues which are here. So Mafia Maji, she is a postdoctoral scholar at IUCAA. Then we also have Pritesh Rantire. He is from HBCSC, he's a scientist at HBCSC. Then there's Sai Shetty, also works at HBCSC. And then Asmita Reddy, she's a postdoctoral scholar at HBCSC. So it's the 5 of us right now. Tomorrow, yeah, and Kshitij, of course, yes. Kshitij Sawan. So you will see him often. He is the project staff here at IUCAA. A lot of the emails and things and these things that you will get, a lot of it owes to the work that he has put. Okay, good. So let's get to more. Yes, sir.
Hi everyone. So before we begin our program, we want to know what you already know. It is not a test. This is completely anonymous. This is only for our research purposes, because we want to see how our workshops are faring. Are we doing well in our workshops, or do we need to redesign some things? What sessions are being designed well? What other sessions we need to work on a bit more, and in which capacity? So we want to see first, if you could go to this link Oh,
So how many of you have
Wi-Fi?
smartphones?
yes. And we have WLAN, which I didn't put. Do all of you have smartphones to take this? We have some printed copies. Okay. Okay. Who needs printed copies? And then how many copies do we need? One.
Okay, so you will be able to join workshop_WLAN or workshop-WLAN, and then the password is this workshop of 2023, all in capitals, please. So in case you have smartphones, that will be easy.
So this scanner is asking for your code.
Yes.
She will
So,
get to it.
so we want this server to be totally anonymous. You do not need to write your name or your school name. But we also want, so this survey we will do before the workshop and tomorrow after everything is over. So we also want to track how people fared before and after. So we want you to put a unique code. The instructions to generate the code is there. So it's basically first two letters of your mother's name, first two letters of your father's name, and the day of your birth.
Okay. So is basically we want to anonymize. We don't want your names to be associated, etc.
Yeah.
So we have said that your father's name, your mother's name, just put the first two letters of these names. Okay. So suppose father's name
yeah.
was okay. Probably you. Okay, so if the mother's name was Arunima, dad's name was Shashank, and the birthday is like 5th of January, 5th of June, then you put the code will be AR, then SH, and then 05. Okay. So mother's name,
Like that.
first two letters, father's name, first two letters, and then your birthday, two letters. So if it is below 10, then you put a 0, so 05, 03, something. And then if it is 10 or more, then of course you can put as it is. Okay. Yeah. So if there are questions, please let me know. I'm happy to answer. And whatever that code is, just remember, because after the workshop, we will again ask you to do it. And of course, no collaboration. Okay, please just try to answer it by yourself, because we want to just know. I mean, there will be plenty of time for collaboration and talking, but we would like you to know just by yourself what is it that you are aware of, and where are the things that we need to focus on. Okay. Not working? I can help you. Too far. Yes.
Yeah, or you can type that web link also. Oh, how?
Should not. Move closer. Closer to the door.
Doesn't work. I used
I
direct
guess
link.
you have to type it.
Okay, no problem. If it doesn't like me.
Same.
We use the link.
Link is fine.
I use the link.
Yeah. Link is fine also. You can put them. Yeah. Actually, here you can go to the link. Yeah, you can type that beat.me. I'll type.
Bit.ly is you. No.
So questions are there. And will the same questions will be there after the
Try this. Yeah.
Mama, I have.
Oh, you have? Okay.
Yes. It's not working. Mobile, can you put that link?
Oh. Oh. Is it asking for signing to everyone? Yes. Oh.
No, not
No,
Ma'am, scan the code, you don't have to sign. Then it
No,
goes
even if that link is entered, no, I am able to go in without
No,
signing.
Exactly. With the code,
Just,
not.
it has to be
It's not
verified.
asking for sign.
Instead of that, I wrote PPO and I wait for that signing thing.
Okay.
So just check the spelling.
Yeah. Yeah. Yeah, then you just write yes. Yeah, that's all. Okay, anyone else needing help? So, yeah, just don't discuss among yourselves, just do whatever you think is okay and fill it out. As I said, like it is not about correct or wrong, and it is not about testing you at all. It is about testing us. So don't feel embarrassed or anything about getting right or getting wrong. Just do it. Yeah. Yes.
I will call,
Oh, I can try. Okay. So some of the questions you may have to move things around a little bit. Huh? It's on the screen, it is always difficult. Like especially that moon phases questions.
Yes.
There are more options, and so we just move it around. Yeah. So once you are done, just click on submit and it should reach us. Okay. That's a process. Is there someone new? You. Yeah, we need, yes, of course. We are going to. No, you just take a sign and then take a leave a pen and pad. That would be useful.
Teaching the following topics.
Yeah, I'm sorry.
You need to go below and
Yeah, so they're written below. Okay, so how many of you are done?
no, sir.
The paper people must be done. Technology is always a challenge.
Yeah, so we are doing a survey. You can do online or accept as a
Yeah, very good. Yes.
Thanks.
Yeah. And so some of the, sorry. Yeah, that's what I was saying, that there's a scrolling thing. In the phases of more question, you have to scroll a little bit. There are other options, of course.
Six months done. What is next?
No, that's okay, then just wait. we'll start once almost everyone is done.
Do we have anyone in the online?
I don't know. I mean,
Yeah,
you
if
can
they
check.
want to go and do.
Not told. I mean, they can hear us.
People are joining online as well.
No, so
I mean, we have the option. We are streaming in the YouTube, not in a like a Zoom.
Not any.
okay. In responses. So 13 of you have responded online, so that's what we know. Yes, yes, yes. That's okay. Whatever you have written, if you type the same thing next time, then you can correlate. So that is okay. So whatever code you wrote last time, just use the same code after the next time. That's all. So you don't have to do it again. Okay. What happens? Yeah. Yes. Again, not everyone is having a problem. So, but you may have to read out, but then you can do No, this is not a problem. Don't worry. You will correct it. You will take your code and then.
So shall I submit?
Yeah, that's fine. You just remember the code, okay? Okay.
Yes.
The code.
And just, yeah, you can write here and give it to me later.
Always Google bug. Yeah, almost. So whoever has the paper copies and done, then they can give it.
No, I mean, we can give it tomorrow after.
Okay. Yeah, we can discuss. Yeah, there is a big group here. Discuss we'll get to it.
Yeah, so this is your code and then you can write your answer and then give it to me.
Yeah, of course. We did come once. So. For the baseline survey, etc.
So we also did a baseline survey with students all over India, with about 2,000 students, and we asked some of these questions to them. We will show you what we found.
Yeah. Okay, so I mean, we need to complete in the next 5 minutes or so because there's like the next talk that we want to introduce you to.
Running a bit late. How do we do this? P is from 11. We have.
Yeah. No, that's okay. You go. Try to see if you can this. I don't know.
Yeah, I will. It's not going
Then the rest we can take to tea and then discuss that so that we can catch up. Okay, almost done. Everyone? Where are the paper sheets? Okay, who is not done? Then it will be easier to ask that question now. Paper sheets are ready? Almost ready. So this is empty, okay, but you filled it out. You can give it. Yeah. It's yours or oh. Yeah. Yes. So that's why we kept this paper things ready, you know, because there's always technical issues like this. How much ever you plan, there's always some problems which come up. rather. Okay, so while most of you are done, I guess we can start the next thing. So Mopia is going to tell you about scales in the universe. Of course, some of the questions were related to this, and many of you should, I guess, may know about many of these things. But still, it is good to see the grandeur of astronomy by beginning with this, and then we'll go on to topics that are there in the school curriculum. Okay.
Good morning, everyone. So we begin with this first talk of the workshop, the scale of the universe. How big is our universe? This is a question that we have all asked. When we look up at the sky, especially if you are in a clear sky region or in a rural region, you'll be able to see the Milky Way over there. Do we have it? The Milky Way here.
Do we see with naked eyes?
Yes.
Get to see.
Milky
Not
Way.
from Pune.
Not from Pune. But if you are in a very rural place, Milky Way is extremely apparent. You cannot miss it.
So, I mean, I come from a very rural place in Maharashtra. And when I was a kid, outside my house, I could see this. That's not a problem.
I am also from a rural region and I have seen this in
Exactly.
my childhood, like every midnight. Every
But
night.
it is getting more and more difficult these days.
Yes.
Because of light pollution. Exactly.
Yeah. So, how big is our universe? We see by naked eye from a dark place hundreds of stars or maybe thousands of stars if the conditions are very good. So, is that the extent of our universe? So, here we will take a small journey. The journey is starting from IUCAA and we will go and see how far we can go. So this is the IUCAA campus. You guys all entered through this today. So that's the IUCAA logo. This is what you will see outside. If you haven't noticed, there are 4 statues over here, and this is the statue of Aryabhatta. So this region we call it Kund. So you can sit here during lunch or tea. And this is what the campus looks like from above. So this is our Kund area, and we are about here. This is probably the lecture hall. This one. So going a bit far above, this is what it looks like. And then if we look at the Google Earth and try to zoom out, what would we see? So this is the Pune University campus, this whole kind of green region. And then it is Savitribai Phule University. And then you have the Pune city here. Zooming even further out, you will be able to see the coastlines here very clearly. You can see the different colors in sea here. That's because of the different depth of the sea levels. So near the coast, it's pretty shallow and then it gets deeper. Now we have zoomed out so far that you can see our entire country. And even going further up, you can now see our whole globe. So from Pune, now we have reached about 6,000 kilometers up above. So this is our entire Earth, the blue marble. our Earth is the only habitable planet where humans live. We have been searching for aliens and other planets where people can live. And this is a very interesting ongoing research area. But so far, we have not found any other planet. So it's a very unique planet in that sense, although we live in a very typical star system. Now, if we zoom out a little bit, we have our Earth here, and then we have our only satellite, the Moon. So here above, we will see some kilometers here, that is the distance. Oh, sorry. So the distance from Moon to Earth is about 300,000 kilometers, right? And from Earth to Sun, it is about 150 million kilometers. So here we are seeing all the inner planets, the three inner planets of our solar system: Mercury, Venus, and Earth. This takes 8.3 light minutes. So we have only reached till Sun, and by now the numbers in kilometers are very, very huge. So we start to measure in light speeds. Light is very, very fast, as you all know. So we measure distances here in light second, light minutes, and eventually in light years. Maybe the teachers. The solar system itself is also very, very large. If you see that any picture of the solar system, you will see all these 8 planets and the sun, but they are not to scale because it is almost impossible to draw things to scale because the distances are so huge. If you want to keep the distances to scale, then you cannot see any of the planets or even the sun. The sun will be less than 1 pixel in an image. So in this image, the sizes of these planets are not to scale, but the distances are. So here you can see that the Earth is so close to the sun. That is why we call these inner planets. And these ones are so far. The sense of how big even just the solar system is astounding. And there will be some activities later today which will talk about this idea a bit more. Now, outside of this, can we switch off from this? Now, when we have reached the last planet of our solar system, which is Neptune, after this, there is a vast amount of space, which is kind of empty. By empty, we mean that there is no big planets here. This space is between stars. We call this interstellar space. The space is not totally empty though. It has a lot of dust. It has a lot of like small rocks, which we call planetesimals, like infinitely small planet type materials. And there are lots of other small things there. But you have to realize that the interstellar space is a very, very large space. You can travel there, even light can travel there for years and years, but it can never reach, it cannot reach another star for many, many years. In the interstellar space, our farthest man-made object lies. The farthest man-made object is the Voyager satellite. The Voyager was sent to space around 50 years ago now. It is still going strong. So by now, about 47 years have passed, and now Voyager has went past our Jupiter, then Saturn, then Neptune, and finally it is in the interstellar space. We can still get some signals from Voyager, and it is still giving us some information about the area that is outside of our solar system. Leaving the solar system. Now we leave the solar system. So we started from here, Earth. So this one is 1 AU, which is astronomical unit, which means the distance from Sun to Earth, we call this, if we call this 1, then to Saturn, it is 10 times more. The Voyager is about here. So it has journeyed about 100 AU distance. And after that, there is something called Oort cloud. The Oort cloud is basically a vast collection of icy small things which are which are distributed in the space. It looks like it's very dense, but it's not like that. It's not like that if you send a rocket through it, it will hit all of these particles here. It's still sparse, but there is still a lot of particles and a lot of objects here. And after all of that, here you see some stars. If you see the distances from here to the Voyager, where the Voyager is, this is about 1 light day. So we started with 8 light minutes and now we have reached 1 light day. Now after this, all of the measurements will be in light years. We use this unit a lot. But how big is a light year? It's very hard to comprehend these things. So if you just do the math, 1 light year comes out to be this huge number, 9.5 trillion kilometers. Trillion is a huge number. We don't really understand what that means. So I will try to give you a couple of examples to give you an idea and sense of how big this number is. So if you started a journey of 1 light year in a plane, normal plane, which goes about 900 kilometers per hour. So just to go this distance, this plane will take 1.35 million years, which means 1.35 million years ago, about this time ago, on Earth, there were no Homo sapiens. There were only early hominids just walking upright. We haven't started using fire or anything. So if the plane started back then, only now it has crossed 1 light year. Or in other words, what if we used a very fast rocket? The fastest rocket right now is a Parker Solar Probe. It is going towards the sun to measure a lot of solar properties. The speed of this rocket is about 160 kilometers per second, the fastest man-made object right now. So if this object travels for 1800 years, only then it will cover the distance of 1 light year. 1800 years is also a very, very long time. 1800 years ago, this was a map of India. And there was mostly Kushan Empire. And Kanishka, we don't have any picture of it, which is the only fact that I remember from history class. That we have found a statue, but without a head. Right? If that is right. So that's how far 1 light year is. So we showed a picture which showed the beginning of the other stars distances. So now we have gone a few light years and went into the solar neighborhood. So the solar neighborhood, this distance is about 10 light years. So this whole thing is say about 20 light years across. Our very nearest star is the Proxima Centauri, which is about 4 light years away. And then you have some other stars in the region. But you can imagine that even going to the nearest star takes like 4 years. So for us or for any man-made object, it's a far cry to reach any other stars. Forget about other galaxies or other things. So after the solar neighborhood, we have lots and lots and lots of stars to get through, but we will jump right ahead and zoom a lot more and reach our galaxy. The galaxy is called the Milky Way. That's the Milky Way that we showed when we started this presentation. The Milky Way presents itself as a band here. This is because the Milky Way is like a pancake or a disk. So we are in the disk. So when we look through the disk, it looks like a ribbon. It's very thin ribbon. And this is a upside down picture. If it was possible to go like on top of the disk, quite far above, then you will see this. So this is of course a artist representation because you will have to go so far to take this picture.
That is why we see a band.
Yeah, that's what we see as the band. So this is the center of the Milky Way, and this is where the sun is. So the sun is quite far from the center. We are in the outskirts of our galaxy. Across the galaxy, it is about 100,000 light years. So that's a very, very large distance. So in this very, very large distance, there lies billions of stars. There is about 100 billion stars in the Milky Way. And billion is again a very, very large number. We can kind of think of what 1 lakh looks like, 1 lakh rupees. We heard of a lot. But 1 billion rupees is how much is hard to comprehend. So let me give you an example. 1 million is 10 lakhs, right? So 10 lakh second, 1 million second, that's about 11 days. If you are counting like each galaxy in 1 second, so you have say a catalog of galaxy and you just, okay, so I count like this is 1, this is 2nd, this is 3rd. And by then, to go through million galaxies, it will take me about 11 days. To go through 1 billion galaxies, it will take me 32 years. So that's the difference of a factor of 1,000. So that's our galaxy. Now we go back to the original question, how big is our universe? If you look at the sky, people have been seeing this Milky Way thing for a very, very long time, always actually, because the sky was much more dark before. So people knew that there is something like our galaxy. But it was not known even to astronomers how big the universe really is. And there was a big debate. Only 100 years ago, we did not know the true extent of the universe. So in 1920, this debate was arranged because there were a lot of back and forth between two groups of people. So what happened is, these two gentlemen, these two were famous astronomers of their day, Shapley and Curtis. So the problem was like this. So from early 1900s, some people took nice photographs of objects in the sky. So people took a photograph which looks like this or this. They didn't know what this is. People call this nebula. Now nebula means something fuzzy that you see. So these fuzzy things, we now know that there is something called nebula, and these are very big clouds inside which stars can form. Now the question was, these fuzzy little things that you see, are they inside our galaxy or are they really, really far away objects, maybe even other galaxies? This was not known at the time. So Shapley, this astronomer, he argued that these are all things that are inside our galaxy. And our galaxy is what? Like 300,000 light years across. That's what he thought he measured. And this gentleman, astronomer Curtis, he proposed that no, these things that we are seeing this as very faint things because they are very far away. Not that they are faint and local, but they are bright but very far. Now, this debate was very famous at that time. A lot of people attended this debate, but the resolution did not happen at this time. The resolution had to come from observations. So Edwin Hubble is another very famous astronomer. You may have heard of Hubble's law, Hubble telescope. So this is his name. So he was an observational astronomer, and he observed these objects. Oh, I can do better. So he observed these objects, and he found that if you really measure the distances to these objects, the distances are far, far greater than 100,000 light years. So this has to be very far objects. And that means that this also has to be very bright objects, because otherwise you wouldn't be able to see it, right? So the only things that can fulfill these two criteria both are if there are other galaxies. This was a totally revolutionary idea at the time. Because in one step, you are going from that only one galaxy is there, 100,000 light years across, and now you are going like this. There can be what? Millions, thousands or millions of galaxies. And then the size of the universe then just grows exponentially, right? So all of this happens only less than 100 years ago. So we don't know how much things can change, say, in next 100 years. So now we think whatever we think we know now is correct, but we may be proved wrong soon. So we have now galaxies. Galaxies are a collection of stars and gas.
The last sentence, do you mean that the galaxies were expanding, or like what was happening? I did not get that.
No, we just didn't know that there are other galaxies. Nobody, they didn't even found about expansion or anything there.
Okay.
We just didn't know that there exists other galaxies. We thought those some things you can see even by your own naked eye. In a dark sky, you can see Andromeda. But to know that this is really far away or this is something close by, you need some actual observational measurements to know that. So there are a lot of galaxies. There are many types of galaxies. Here, I will not go to the names and all, but you can see that this looks like this has some kind of arms, like a spiral kind of thing. So this is what we call a spiral galaxy. Our Milky Way is also a spiral galaxy. This is where you can see maybe it doesn't have like arm, it kind of looks like a blob. It doesn't have much structure, so this is an elliptical galaxy. There are some where very interesting things are happening. This is where two galaxies can come and actually collide. So those things are also happening, interacting galaxies. So lots of different varieties are there. And people have been observing galaxies for many years now. So we have a lot of information about them. Then the question comes, there are other galaxies and how many there would be. It's quite impossible to actually count by hand. But we need to have some idea, right? So the idea came to astronomers that yes, when we look at somewhere where even by naked eye you can see a lot of things, there if you point the telescope, yes, we see a lot of galaxies. So at one point after the Hubble telescope was deployed in early 90s, scientists figured out that we can do one experiment and just look at one patch of the universe where there is basically nothing. If we stare at them really hard, that is for really long, if there is anything, like if some little photons are coming, we may be able to capture it. Okay. So what did they find? So they were looking, so this is a composite video of their like 14 years of data here. So they are looking at one patch of the very little patch of the sky. This one, here. Here now it looks pretty empty, right? Even inside that, in a very little space, we are looking. So in the first run, Hubble looked at this for about 11 days, 11 nights, that is. What looks pretty empty if you just see it in one glance. Now it looks like there are a lot of galaxies here. So each point here, there are one galaxies. So in a region which seems pretty much empty, you still have countless galaxies there. And this is the image from there. So each of these things here, there are some stars here, some stars in the foreground, but all of these things here, like these are galaxies. Then now there is JWST telescope. So the JWST has also done a study like this. So this is the JWST ultra deep field. So this is called ultra deep field because they have been looking at this for a very long time. And here you can see that the image is much sharper than before. So in total, there are about there are billions and billions of galaxies in the universe.
What is this JWST?
That is, that is James Webb Space Telescope. That is a new big telescope that has been sent to space, and it is observing all kinds of objects. It is giving us a wealth of data. It's like the next Hubble telescope.
Excuse me.
Yes.
I just missed one name from you. You mentioned about just to apprehend the distance of 1 light year. You mentioned about man-made rocket, which is the fastest one.
Parker Solar Probe.
What is it?
Parker.
Parker.
Parker, yeah, Parker.
Parker Solar Probe.
The very famous astronomer in the University of Chicago.
Yes. So, okay, so we have reached galaxies, and now we have looked at a lot of galaxies. Now let's go back to our original problem here, and let's zoom out a little bit more. So we were here, right? This is our Milky Way galaxy, and we were here somewhere. So galaxies like to stay in groups if they are not uniformly distributed across the space. So if we look at our local area, local neighborhood, we find the local group, which consists of this Milky Way galaxy, our Andromeda galaxy, which some of you might have seen, and this little thing called triangular galaxy. There are these little dots here. They are called all satellite galaxies, very, very small galaxies that are nearby. So this is our neighborhood. This is our local group.
My
Just a
ancestor.
question. You said they're small galaxies. Are they appearing small and they're far away?
No,
No, these are small.
we have confirmed that they are
Okay, so
small
the distance
galaxies.
is small
Yeah.
and they're small.
Yes. Even going a little bit more further, the local group here sits in something which looks like a cluster. Again, galaxies don't like to stay alone. So even groups form clusters if you go far out. So this is what we call the IUCAA cluster. This is our cluster where we are. So all of these points here, we'll see that there are names of many, many groups. So each of these groups contain multiple galaxies inside them. So this is our IUCAA. So from there on, we will go outwards, and we will see where the cosmic wave lies. So this is our IUCAA supercluster. We're just zooming in here. So if we zoom out, then we will see that this is from simulations. So we will see that this is looking like a wave of structures.
This is not real.
No.
This is real, but this is not a real picture. So these are from simulations, because you have to go really, really far out to get this picture in real. But we have gotten this picture also from other observations, other kinds of observations. So we are fairly sure that this is the right picture. So this here is 1 billion light years across. 1 light year itself is a very big number. So this is almost incomprehensible again. So each of these light points here you see, they are all galaxies, each of them.
Let's test.
So this is our observable universe. In the next and the last step, what we do is we start from this 1 billion light year that was just part of our cosmic web. This is what the observations have actually seen. This is done by something called the Planck satellite. Planck satellite looked at how hot different parts of our universe is, and from there they painted this picture. So these orange parts are a little bit hotter than the blue parts. So from there we can kind of see that this is a large scale structure of our universe. So if we zoom out even further, now we see that this number increases and then it stops at about 93 billion light years. This is the age of our observable universe. By observable, we mean that Big Bang happened at some point, and so far, light has had time to travel from only this far. So even with the most best telescopes, you can only see this much. 93 billion light years is the size of our observable universe. Now, you may think, what is outside of our observable universe? And this is where all kinds of theories come in. Is our universe infinite? Is there something, is the same thing beyond 93 and we will just keep seeing more and more galaxies as time goes on? Maybe. Or if there is other universes, parallel universe is what people call them. So they may be looking something like this. Same kind of structure, but different initial conditions. So maybe there are also different kinds of galaxies. And how, if there are parallel universes, how many could there be? There could be billions or infinite, we don't know. So that's kind of the end of our journey. So I'll just play this and take questions from you.
So this was just to introduce you to the grandeur of the universe. I mean, all the numbers that are involved here are quite big. And if you want to convey these things to students, it becomes extremely difficult. So you saw, especially some of the tricks that they use in order to get them to understand, you know, that you can try to convert it into things that they can comprehend, yeah? And then help them understand in this kind of a manner. So these are the things that we would also like to talk with you and try to get your feedback about how we can do things better and how you will be able to also convey these things to students. Okay? So let's take some questions and then we'll go out for tea. In fact, yeah, okay, maybe a couple of questions and then immediately we'll go out for tea because we are running a late.
This is not a question, just
Yes.
a feedback. I just love the idea of the thing that you said. If 1 million stars are being counted 1 per second, then this much time, that was very
Yeah, exactly. So
Yeah, 10 million seconds is equals to 11 days. That was also like
superb idea to just apprehend that number.
Yeah, that the difference is so huge. The number, the words are very similar.
okay, more?
Ma'am, I just want to ask, so if the children ask that the galaxy is expanding and it is unlimited, is it the right thing to say?
So, galaxies itself is not expanding. So, what is expanding is the universe. Yeah. So, the space between the galaxies, you can think of that they are expanding. But like we think of it as a balloon thing you may have seen. So, it's like if you have a balloon and if you paint some dots on the balloon, and then if we put more air in the balloon becomes big. So the distances between the points becomes larger and larger. But the points itself is not getting big.
That means the universal objects, are they actually going far away from
Farther
each other?
from each
They are
other.
farther.
So they are just, they'll continue doing this?
They continue doing this, and at some point it will happen that they get so far that it will be even difficult to see the light coming from them. It depends upon how the universe actually expands. It is expanding at an accelerated rate. And so eventually, yes, not in our lifetimes, but eventually.
So like
That
now
will
we can
eventually
see
matter the
Andromeda.
gravity also? That will eventually matter to the gravity also between them.
No, so the gravitational forces still hold the galaxies together. But there are theories in which they say that whatever is causing this expansion of the universe, it can be, in principle, can be so extreme that it pulls out all the stars away from the galaxies. In fact, it also could rip away all the stars, and even small atoms that we see, they also can be ripped out. The nuclei can be ripped out and so on. So this thing is called a big rip. We don't know whether that's going to happen or not, but we are trying to make observations in order to understand whether our universe has that fate.
And this
So,
expanding universe,
maybe.
yeah. This force, this unknown force is what we call dark energy, which is pushing things outwards. We don't really know.
So that's what we are trying to study. Yes, yes.
Okay, so basically, I would like to ask a few of the images we had seen previously, I mean, from JWST or maybe Hubble, were those actual pictures taken, or I mean, we only depend upon the images taken by camera, or are there any other data which we, I mean, get in and then figure out what it could be?
So these are real pictures, but some of the colors we paint later. Depends on the information that is coming from the objects themselves. But the pictures of the galaxies, like if it looks like a spiral, it does look like a spiral.
So what happens is, just like when you pass sunlight through a prism, it separates out into different colors. So what you can do is you can take pictures in each of these individual colors and then try to compose it on a computer in order to see how it will appear. So that's typically what is done with telescopes like JWST and HST or any other ground-based telescopes that are here. Okay? But it's not just in the visible light that you can take these pictures. You can take these pictures in radio waves. You can take these pictures in gamma rays. So there are many different types of light. So it depends upon the wavelength of this light. And you can take these different pictures and try to compose them together. And so some of the pictures that were shown were from the optical region, some were from radios. And then I don't think you showed X-rays, right? No, I don't think she showed X-rays. But there are people who also take pictures in videos. But then you have to, like, you cannot see X-rays with your eye. And so you need to color them with something saying that, okay, these are X-rays of this kind of energy, and these are X-rays of this energy. And so on. So you try to make color composites.
So raw pictures taken by these telescopes are not to be comprehended by general person. I mean, layman.
I mean, you can see it. It's not a problem, and we often see it ourselves also.
It's just not as colorful.
It's just not as colorful because they will take it in a particular band, so it will just look gray color. No? It will just tell in this particular wavelength region.
Like we
How many photons you
get?
get?
Yeah, like they're saying this blue light, so light blue, dark blue, light blue, dark blue. That's all there's.
Just the contrast.
Yeah.
And then you can compose. So this is blue, this is red, this is green, then you put it together. Okay, good. So let's stop here for this thing because the tea is waiting outside. I don't want it to get cold. And then we will come back in like 15 minutes if possible, so that we can start and catch up on that. Okay?
Yes, and some people have joined.
Some people joined just now, so
then,
please come and sign this.
Sign this sheet, and we will also give away.
So tea is just outside, okay? So please, quickly.
Yes.
No.
Yeah, of course. I'm
If you want to
yeah. Oh, one welcome to all of you. You guys have studied a long year. Long distance. Now we are here to chat with all of you. So these were only the very yeah. So these are not even in the syllabus. So we just wanted to give a flavor of what astronomy is. Right now we will after we will start the actual. Yeah, so all of these names should be Center for Science Education, right? Oh, अच्छा. So these are the survey we did in what way we can do it in the actual branch. Yes. And then we will yeah. So maybe you can talk to students. He gave a brief overview of what the institution is about. Then we can Oh, he was who was answering the question.
Yeah,
So
yeah.
yeah. So he is a professor here. Oh, great. Yes. And I am a researcher here. Yes. Actually, hold on. This is your laptop. You can just, I'm not connected to anything, I'm just doing. Oh, exactly that. Yeah, so you will get it. Yes.
So is it immediate or then again same thing on the picture then there is a delay?
There is always so it is only because the light has a finite speed. So it takes light about 8 minutes to come from the sun. So all the time while looking at sun, it is 8 minutes previous. So like sun is destroyed right now, we will not know for 8 minutes.
Same goes for all the
Same goes for
objects.
all, yeah. That is why some people call that telescopes are like time machines. So some of the galaxies you are seeing them like how it was like billions of years. They're so far.
That is what I always confused like the ranges are so vast. I mean, even the light takes so far. So whatever we are looking at right now, it not be or
True. It's not the correct picture. Yeah.
It is the past.
It is the past picture. And that is how this is also interesting to us because then we know how the universe looked at that point.
Well, some of these things were new, about but it was not like a factor of 10
No,
but at least
yeah.
the explanations and so on, I think that is very important.
Yeah, I was wondering if I should do that or this, and then I did a factor of 10 to
Okay, you want to create.
So a galaxy is so scientifically we say that it's a large collections of stars. Like billions of stars are held with gravitational force, and there is also some gas inside it.
For each and every galaxy, there is some center.
Yes, that's right. And these are gravitationally bound together, and so they stay together. And they somehow circle around the particular center of the galaxy.
Also in orbit.
Sun is also in orbit. Yes. You came a little bit late, so she had shown like how far away it is from the center. It takes light about 30,000 years to come from the center. So it is really far.
So yeah, so things and other
Yeah.
So yeah, so they want to know a little bit more about IUCAA, OAE.
So we can talk around because see there will also be this target, so we will be around.
And she wasn't here today.
Okay.
There will be free time on the From here I can see almost because these are almost over. Yeah, my phone started ringing. I always put it on silent, but today only this was
Yeah. Yeah. No. Sorry, Shivani. Shivani was asking, where is the?
Oh, right.
So, you are ready, right? That's it. Senbhavati, you can join Zoom.
No. So these are because children.
Oh,
So what
screen
about all the
share.
time? Yeah. So tomorrow there will be a talk about
Okay, so let's get started. The next topic is going to be eclipses. Sai Shetty, she's here from HBCSE. She will talk about this particular phenomena, which is again covered in textbooks. So, yeah. Lights, yes. Just don't want you to sleep. You can start.
Okay, so hello everyone.
Hello.
I am Saeed and I work in the astronomy cell at HBCSE. So welcome to this camp. So as you know, we are going to talk about eclipses in this session. But before we begin, just to have an idea, how many of us have already seen an eclipse? Was it a solar eclipse? Both. Okay, fine. And few of us have it. So have we gone through some pictures or heard about the eclipse? Right. Students को सिखाते हो. Okay. So before we begin, I want you to tell me some, like you will already have some idea about eclipses. So I want you to tell me few observations that you have about eclipses. And what we will do is we will write them down and let's see how it proceeds. So yeah, anyone.
What is that?
What is an eclipse or what happens in a solar or a lunar eclipse?
Shadow. Lunar eclipse.
Yes.
It's basically a
So one by one.
Yeah, sorry. So we can go one by one because
it's basically a game of shadow.
okay.
Shadows playing there in the solar system.
Yeah, so as I was saying, it's a game of shadows in the solar system. So if moon comes in the center of sun and the earth, then the shadow of moon falls on the earth and we can't see the sun. And then when earth comes in the center of moon and the earth and the sun, then the shadow of the earth falling on the moon, we are not able to see the moon. And that is how both the eclipses happen.
So the first one is
Solar.
The second one is
Lunar.
Can somebody else again explain me what is it? You are right. Just
Every 6 months it happens.
just to break ice.
I can add with ma'am's explanation. There are two types of shadows, umbra and penumbra.
Solar eclipse.
So can you see sun during the solar eclipse?
This part is more
But can you see the sun?
Sun, no, because the distance of sun is farther or farthest from, like, moon is closer to the earth. So that's why when it comes and it actually covers the sun. Otherwise, distance of sun is farther than your moon, where it is. That's why we cannot see that sun, the whole, and it covers that sun.
Okay, sometimes we can see, sometimes we cannot. So that is just a type of it. Right? What happens in a lunar eclipse? Can we see the moon?
some part of, depending on what type of. Depending on what type of.
I know.
In lunar eclipse, Earth's shadow is passing over the moon, so it depends on what angle it is passing. So if it is a whole lunar eclipse, then the whole moon will get undershadowed, it won't be visible for a while until the shadow passes off. Otherwise,
Can
if
we see
it,
the moon? Also,
yes,
For a time being.
yes, we can see a faint.
everybody agrees with this?
Easily we can see.
Yes.
This we
You
can
have
see.
seen the lunar eclipse and what does it look like? When a total lunar eclipse happens,
Then you're
how
not
does
able
it
to
look?
see that new moon.
You're not able to see it.
For that while, yeah.
For that
In the
while,
moment, yes.
But I feel little bit grayish
Yeah, great. Yeah.
image must be visible.
grayish image, okay?
A bit must be there.
So you don't remember.
I don't remember. I haven't been able
that's
to
fine.
actual observe. Yeah.
So we can see the moon during lunar eclipse, but maybe it might be a bit grayish. Okay.
Because of shadow, right?
Okay. And in solar eclipse we can.
The total solar eclipse.
And that is quite rare. Solar eclipse.
That is quite rare, yes.
It depends on the.
Not everyone in the earth can see the lunar eclipse or the solar eclipse.
Only some part of the earth.
Some parts of the earth, people only can see the.
Sorry. Can you repeat?
Part of
We cannot see the solar eclipse from everywhere in the earth. Some peoples in some part, they can see the lunar eclipse or solar eclipse.
the certain part of the earth.
Yes, which area the
Certain part.
Yes. In India, we cannot see mirrors. Yes.
I have seen annular solar eclipse. That time only that ring could be seen, and solar eclipse is for a short duration, and lunar eclipse for long duration.
Angular.
Solar. And then the duration. Solar eclipses are short, lunar.
Solars are short and long.
Anything else?
More.
solar eclipse on new moon. Okay.
Lunar eclipse on full moon day.
Solar eclipse on?
New moon day. Full moon day.
Do we have any other observation?
There are types of eclipses as well, like partial or annular eclipse.
Okay. This is for
Solar.
Both.
yeah, I think that was
Well, annular.
types of solar. Okay, we can take one more and then कुछ मेरे लिए भी छोड़ दो. Yes.
Who's going to do 10?
Not correct, but maybe when moon is at a perigee situation, maybe.
Closest to the when moon is at perigee, it will be closest to Earth.
Yes.
Then
We have Christmas. Then only it is hiding the sun and all.
okay. Why do you think so?
Because it has to cover, it has to come directly in front of the sun. But when it is closest, and then only we cannot see sun.
Good point.
Not all new moon days show us eclipses.
Somebody said something.
Yeah, so I just wanted to add that eclipses cannot happen on every new moon and full moon day because they have to, all of them have to come in a similar plane. Then only the eclipse can happen.
Correct.
Orbits are not in this. Orbits are not in the same.
So can we start with this?
Sir, I just want to ask.
Yes.
We say that solar eclipse. I mean, usually when we have seen the solar eclipses, it is not that it goes complete dark. But when we see Mahabharata and all, when they show the judges, I've seen that it has become completely dark, and then the sun rises kind of a thing. So has it ever happened? I mean, I'm still waiting to see that kind of eclipse.
We see.
We cannot see this.
But do you think it will
with
happen?
naked eyes?
Just a minute. Do you think it will
I'm
happen?
wondering. I feel it should happen, and we should be able to see that kind of a thing. That it's completely covered, but we can't just see the sunlight, and it's an eclipse.
Birds respond to
And then slowly it will show the shine kind of.
Running out of space.
Just can I just wanted
We take one last.
I just wanted to share a very interesting, exciting experience in my childhood. So I'm a huge fan of Albert Einstein. So there was a great collaboration between two. General theory of relativity was proved actually after experimentally during the solar eclipse happening in parts of England. So the scientist was from England and he was from Germany. So there was a great collaboration when there was World War happening. So it does happen, ma'am. I just want to say it's a beautiful story. You should watch Eddington. Eddington, it's in YouTube, 1 hour documentary. So there is solar eclipse, and which led to the making Einstein the person he is a celebrity. A celebrity, great celebrity.
Thank you.
Eddington. Einstein and Eddington. So Eddington, yeah, it's there in YouTube.
Double D.
So they both were collaborating.
It did not happen though in England. It happened.
Sorry, which
Principally,
place? Actually, he was from England.
Yeah.
Which
There's
place?
Brazil, and then
Brazil.
there is a island near Africa. Principally.
Sorry, I watched the
No,
movie
that's fine.
a long time back.
Details. But,
Okay. So now we have a few observations, which we assume all of them are correct. Okay. And before we begin with the presentation, we'll do one small activity. So I need 2 teachers of similar height. Not very tall, not very short. Any 2.
it just quickly, yes.
Yeah.
You need to check.
Almost.
Okay, there is almost same.
So one of you will be sun. So we'll do a small activity, a role play. One of you will be the sun. One of you will be Earth. Decide. Okay. Great. Everyone can see them, right? So this is sun, giving out light, heat, energy. This is Earth. So just face the sun. So I want everyone to tell me which part of Earth will be in light and which part of Earth will be dark. Okay, light, in light. Face side. In dark?
Back
The back side. Everybody agrees?
Yes.
Earth agrees? Okay. So now I want you to show, so there are majorly 2 motions of Earth. 3, but for this activity we'll take 2. The first one is rotation. And then okay, sorry. Rotation. Yeah. Eight करके बता.
This is rotating on its own.
This is correct. Everybody agree?
with little.
Yes, sorry.
It's right in little details. Sir.
Tent मत करो. 23.5. Okay. Once more. Rotation.
Actually,
You're talking about east side.
it is
Very
So far, sun, earth, light, dark, and the direction of rotation.
No, the other one.
Okay, so all we have to remember is if I look from the top, I will see the earth rotating counterclockwise.
Yes.
Okay. So the second motion is around. So can you just demonstrate? Now, what do I need? I need somebody of again of similar height. And almost similar, not exact. 5'4", 5'5".
Be like it.
Man will be very okay. So we have sorted out sun, earth, earth's day part, night part, rotation, revolution. Same thing we'll repeat for moon. Okay. So for the time being, you come here. So your moon, which will be the day part? Day part of moon. Day part of moon.
Facing the sun again. Facing the sun.
The lighted part of it. Which is the lighted part?
The one which is facing the sun.
Facing the sun. Everyone agrees?
Facing
the earth.
The dark part?
Facing the earth.
There's another facing the earth.
Facing the earth.
Okay. Facing the earth is the
Light part.
light part.
Which we see.
It's from the
No,
earth.
no,
You
no.
can see
I'm
that.
asking not what you see. From space. You are not on Earth right now. You are looking at solar system as a third person. You are outside the solar system. You are looking at. So which is the light part? This is
The one which is facing the sun because it reflects the light.
perfect. The dark part and the dark part. Okay. So now the next thing will be rotation. Please show that. Okay, first only show the rotation. That was a good question. just rotation, okay. And revolution with rotation.
Rotation. Moon is also rotating, no?
Yeah, moon
Okay.
rotates correctly. 24 hours.
But you always see one side of
The side that I'm facing towards Earth, I'm showing to Earth, that side will be like the same.
Correct. Correct. Once more.
All time.
So right now, okay, whatever you're comfortable.
Correct. When we start all our
Everyone agrees?
Yes.
Yes.
Moon takes same time to rotate around itself and revolve around itself.
Yes, so she's
So we only see one side of the moon and it will cover one rotation and one revolution at the same side.
Correct. Okay, any doubts so far? Anyone who disagrees? Can you please show once more? So this is rotation with revolution of moon around the earth.
29 days for one rotation.
Sorry. Sorry.
Self rotations of the moon. 28 or 29 days. Is correct.
You tell me.
24 hours it's a day. Self rotation day after.
At the same time, moon is self rotation is 28 or 29 days.
Per rotation.
Is it correct?
Yes, it is correct.
So, but
You are asking about the numbers, right?
Yes.
No, she's not displaying displaying that self-rotation.
Okay. I'm displaying the self-rotation, but while I'm revolving, I'm maintaining that one position and one rotation at the same
time.
When I'm going like this, from upside, if you see, I'm rotating.
Yes.
Just one question.
Yes.
So she started like this from. So while she's rotating, the end should be happen like this or like this only. I have this question.
Like this always will
In at the same time.
I'm going forward.
So
Then the moon doesn't change.
okay, just one question. All of you all might be knowing this. When do we say we have completed one rotation? Or bata?
When we
So you start here. Start facing sun. We are looking at sun. Complete one rotation. Yes.
So when Earth is facing the sun and it completes one rotation, that means it comes back and faces the sun again. This is completion of one rotation.
So you are facing the same direction you started off with.
Okay, start and end point.
Right? Now moon. Okay. So moon, when you start, where are you looking? Okay, yeah, that is a little bit advanced, but let's just first go slow. Where are you looking? Towards Earth. Okay. So now start rotating. Right? Where are you looking? This way. Okay, so yeah, okay. Now we are looking towards the Earth, but also towards the audience. Go that way. You are looking towards Earth, but towards me. You are back at where you started. You are obviously looking towards Earth, but you are also looking towards the blackboard, and that is where you started. Right? You are looking in the same direction. So this was our definition of rotation. And is this correct?
Yes.
Does everyone agree?
So one thing to remember is the direction that you define is not with respect to the sun or with respect to the earth, but it is with respect to something in the background. Right? So is the blackboard or the audience or these things is what she was saying. Right? So when you are completing a rotation, you are actually changing the direction with respect to something which is very far away. If you take something like Earth, then you will say that she has not completed a rotation. But indeed she has, because the actual direction is with respect to some background in the back.
There is some other reference.
Exactly. So in this case, it will be stars which are very far away, so that they don't change that much. Okay? I mean, stars also move around, of course, but in this case, given the time scale, that is good. Okay.
Thank you. Yeah. Okay, so this is done, right? Yeah. Moon is retarded with respect. I don't know. There is some angle. The orbit of moon is tilted, but with respect to the orbit, also moon is tilted by some degrees. I don't remember which.
Orbit of the rotation of the moon is tilted by degrees.
Yes. 5 degrees. Do you want to try doing that? Okay. So yeah, so this is done. So now back to eclipses. How do we start? No, wait. Okay. So let's start with solar eclipse. We have sun, we have earth. So moon, please show me where you will be. This is
Solar.
Solar eclipse. Okay.
The sun in between moon and the
Sorry.
If the air come between moon and earth, it is lunar eclipse, I say.
Yeah. I was asking about solar eclipse.
Continue.
So we have moon in between sun and earth. This is solar eclipse. Okay. So now I want to ask you, Earth, please look at moon. Do you see the dark part or the light part of the moon? Okay, wait. This is moon. Forget about Earth. Which is the light part of moon?
Back side.
This side. Dark part? This side. Earth is looking at which part?
Dark.
The dark side. Right? So, in solar eclipse, Earth, which part of the moon is towards the Earth?
Darker side.
The dark part. Okay, so which phase it is?
New moon. New moon.
Dark.
Yes. Complete dark.
New moon. New moon, no?
Yes.
Okay. Lunar eclipse.
You can show phases of the moon also right now.
Yes, we can. But we don't have that much time.
Tomorrow we'll get this.
Yes. This is sun, earth, moon,
Lunar eclipse.
lunar eclipse. Now, just look towards the moon for the time being. Yeah. Which part of moon are you seeing? The light part or the dark part?
The light.
Light part. So which phase is it?
Full moon.
Full moon. Everyone agrees? So one of our observations is correct. Somewhere. Solar, 8th one. Solar eclipse. New moon day. Lunar eclipse. Full moon day. Okay. Yeah. That's it. Thank you. Sorry. You go. I want a new moon. Someone who is taller than both these teachers. Some tall person. Okay, sorry. Can you also come for some time?
For comparison.
Maybe comparison ये तो है. Just something I wanted to ask. Our new moon will stand here for some time. Thank you. Yes. Okay, so this will be the position for just starting where we left at. This is lunar eclipse. Phase full moon. And Earth is between
Sun and the moon.
Okay. Light of sun is getting blocked by Earth. Okay. Now, sorry. Okay. But right now the moon will be completely obscured, right? Sorry, the sun will be completely obscured. But does solar eclipse occur? Sorry, moon will be obscured. Okay, sorry. We are doing lunar eclipse. We have sun, we have earth, we have moon. Right now the moon is in shadow, in Earth's shadow, right? Now, is every full moon day a lunar eclipse?
No.
Right? But every full moon day, is it a lunar eclipse? No, right? But here, if you go around once, you come back here. This will be a full moon day phase. And if this is the height of the three people, you will see a lunar eclipse again. But that doesn't occur every time. Right? Why is that so?
Earth is also tilted and
Yes. Sorry, moon was speaking. Reference to moon, yes.
All the three bodies are not in the same.
Right.
Can you take the mic because you may not be able.
The moon's revolution orbit and the Earth's revolution orbit. They are not in the same. They are a bit tilted. So not at every full moon we get Earth's shadow lying on over the moon. Only in certain situations when this tilting moves and changing sometimes.
Okay. So everyone agrees with this?
yes.
It would be nice if we can see some simulation or
Yeah, sure. That I have presented. Just starting with the activity. So this is something we can do in the school, right? Because this will give a better perspective. Okay. Thank you. You come. So again, lunar eclipse. We have Earth in between Sun and Moon. Light of Sun is getting completely blocked by the Earth. Correct?
Not completely.
Partially.
Okay, partially. What if you were of a bigger height? Just raise your hand. Raise your hand. This is Moon now. Is the sunlight getting blocked? This is the full moon day. A perfect situation for a lunar eclipse, right? Because Earth is in between Sun and Moon. But will there be a lunar eclipse now? No, right? Because even though Earth is between the Sun and Moon, it is not in the same plane, right? Now, what will happen when you go for solar eclipse? Solar eclipse. So solar eclipse, Moon is between the Sun and Earth. But now, you will have to bend a bit, right? So this is actually the orbit of Moon, right? Now the Moon is between Earth and Sun. Which phase is this?
New
Moon day.
New Moon day, because the dark part of Moon is facing Earth. This is a new Moon day, a perfect situation for a solar eclipse, but still a solar eclipse won't occur. Why? Because the Moon is not in this plane, right? Little bit lower. That's it. Thank you. So yeah, thank you. Okay, so with this, we will start with our presentation. So, as we have said again and again, an eclipse is something when an object passes through the shadow of some other body, or when some other body passes in between the object and the viewer. So in solar eclipse, what do we have? We have Sun, we have Moon, we have Earth. Moon's shadow is falling on Earth. The darker region here, this cone, the darker part of the shadow is umbra. The lighter part is penumbra. So now, how do we see a solar eclipse as viewed from Earth? So you have Sun shining, and then you have Moon which starts covering the Sun. You have a period when you cannot see the Sun at all, which is called as the totality. And then,
is this real image or
yes. And the Moon then again starts going to the other side, and you see the Sun again. So somebody had a question about whether the sky will be dark, right? What do you think?
I've never seen it. I wish to see
it is very rare, but in a total solar eclipse, it will occur. So a total solar eclipse is when the Moon will completely cover the Sun, and something is completely covering the Sun. You won't see light. It will be dark, and you can also see stars surrounding. Even I have not seen this, but that's
2032
is it? Okay.
34. 34.
Okay,
something in 2030s, I think, in the northern part of something else.
So just a collage again of.
Yeah, 1990s, I think there was one. Yeah, I was born and
95 eclipse.
Yeah, 95, I think. Yes.
It was pretty dark, not totally night, but parts were going home.
I mean, from her region, there were regions where it was completely.
Which region?
Oh, I'm from Bengal, so it passed through our area.
Central India, basically. 95 eclipse was through central India, Bengal, Uttar Pradesh, some parts of Bihar, Uttar Pradesh. That's one.
It got
like dark center, not midnight dark.
So it depends upon, maybe you will get.
Yeah.
Okay, so just a collage of images where you have of solar image or solar eclipse. So you have sun from left to right. The moon has started covering the sun. Here you can see that it has completely covered the sun, started going ahead in its orbit, and then you can see sun again. So there are few images here which might interest you. So this image here is when the moon has almost covered the sun. But since we know that the surface of the moon is not a perfect sphere, it has mountains, it has valleys, hills. So it happens that some light still escapes from these valleys, and this structure is what we call Bailey's beads. So this was first discovered by Bailey's, and the name has been given from that. When it goes ahead a little bit more part of the sun gets obscured, and you have 1 or 2 Bailey's beads left. And this structure which you get after that is the diamond ring structure. So this is the ring and here is the diamond. Here is the totality where the moon has completely obscured the sun. And now what you see here is the sun's atmosphere or corona. So this is a space view of how, if you go into the space and you look at Earth and there is a solar eclipse, this is how the you will look. This is how the Earth will look like. So you have, if you see here, you have something dark going across. That is nothing but the moon's shadow, which is going across the surface of the Earth. So another good observation here is that it doesn't always pass through the sun, through the Earth's center. Right? The path can be different. And here, if you see, again, you have this shadow going on the surface of Earth. You have a darker part, which is the umbra. The fainter part is the penumbra. So solar eclipse, the darker part umbra. If you are in the umbra region of Earth, this is what you will see. That is, the moon is completely covering the sun. If you are in the penumbral part of the Earth, you will see a partial solar eclipse. So this brings us to the types of solar eclipse. You have total, again, where the moon disk completely covers the solar disk, and you can see the atmosphere. That is the total solar eclipse. Then you have something where the moon's disk is partially covering the sun. So you have partial solar eclipse. And another third type, which is interesting, which is called as the annular solar eclipse, where the moon's disk is not completely covering the solar disk. Now, when will this occur?
I have a question. So can you go back to the umbra and penumbra?
Yes.
So can somebody explain why in the penumbra, like there is some, like why is the umbra dark and the penumbra not dark? Can you please tell me? Do you fully understand?
Yes, the ray path.
Ray path. So why does
completely blocked and partially blocked?
So how do I know that it is partially blocked in the penumbra? So what do you mean by slanting rays?
Those other, the sun is a bigger object.
Yeah,
So
sun is a bigger object, yes.
So light rays starting from some part are being.
No, so from where, which part? That's what I'm asking.
Okay.
So from which part of the sun will you see? So let's suppose you are in penumbra region.
This image is seen from which part? That you want to ask?
Yeah. There is some light coming, right? See, we want to understand, like get to the understanding part, right? We always see these ray diagrams.
The lower
But I want to understand from where is light coming here, right? Why is it only semi-dark?
Lower penumbra.
Lower what?
This particular image will be seen from lower penumbra.
This will be seen
from lower side.
Okay, so do you think that this will be seen from the lower side?
If the telescope image vertical and all that thing is.
We will talk about telescope orientation later. Okay. But if you are standing here,
yes,
will you see the upper part of the sun or the lower part of the sun? See, this is why I wanted to ask this question. Okay. Okay, how many say upper part?
No. We'll see lower part. Sorry, I take back my word.
Okay. So be careful about these things because we are always used to these diagrams, but we are still not completely thinking about what is exactly going on. So here, in this particular part, the light is from down here and still reach.
Yes.
Yeah? Because from here, so they never show you the ray diagram of what is happening to this ray and why is it not reaching. I mean, it is reaching here.
Correct.
So shall we show it to the children with a diagram that these lines
So
are still
you have to be careful is what I'm saying. I don't know how you will explain it to children. So I know that you should know that this penumbra is happening because there are some regions of this sun which can still, like the light rays can still reach.
Correct.
So
and then there is certain region of the sun which will not be able to shine in that particular region, right? And that's why there is less light. Okay? And that less light is because this moon is blocking like completely the light coming from this particular upper part first.
Okay.
We will see lower part.
While if you are in the umbra, no part of the sun you will be able to see. So this is the difference between this umbra and penumbra. It's easy to show just with ray diagrams, but I think it is important to viscerally understand what is happening.
Sir, आपने जो बोला कि upper में जो diagram दिख रहा है अभी upper part of the sun, that must be because वो northern hemisphere of Earth में कुछ खड़ा होगा. That is the reason why, right?
Right.
Yes. So in this case, this particular thing,
It
you
is taken
need to
from
have something up here so that they can see the upper part.
Correct.
Okay. So that's why just keep these things in mind because they come in back and forth sometimes in terms of the understanding.
One question, I think, I just want to know the inclination of the Earth will also be one reason maybe or will be affected more during solar or lunar eclipse. Just a question.
Will the inclination
Inclination
cause
of the Earth also
tilting
is one factor, or maybe if Earth is inclined, so maybe the solar eclipse, if it is, then it will be there in the northern parts, not in the southern side. So maybe the angles will also change with that side. Just a question.
Okay. What do others think?
It's just the Earth's surface, wherever the light is
What do you
reaching.
think? Yes.
What I feel is whether Earth is tilted or straight, light is reaching to that region, light is not reaching to the region. So that fact remains the same.
Can you repeat with the mic?
What I mean to say is if Earth is tilted or not, what this diagram tells us is the shadow region is reaching at one particular point on the Earth, the penumbra region is reaching the other point of the Earth. So that remains the fact, whether that Earth is like this or like this. So the fact remains the same. It does not make any difference to solar eclipse. Whatever
The shadow
makes
will always be there, but if in this image the Earth is tilted, the region on Earth where the shadow falls, that will change. The country will change. But the diagram still remains the same.
The tilting will not change the fact.
And the whole change.
Yeah. So what she was saying is the hemispheres can change depending upon where the angles are.
But I think in this diagram also those hemispheres are shown like that only properly.
Yeah.
The
So
tilting is properly shown.
in fact,
Tilting is properly shown.
But depending upon this orientation, sometimes you will get in northern hemisphere, sometimes crossing the hemisphere, sometimes only in southern hemisphere. These kind of things can happen.
Good question. Okay. So can we go ahead? Yeah, so we saw what was total, we saw what was partial. Coming to annular. So can somebody give me some idea about why do we still see the ring here? In this diagram, if you are in umbra, the sun will be completely blocked, right? If you are in the penumbra, you can see some part of the sun, depending where you are in the penumbral region. What will be an annular solar eclipse?
Moon is little farther.
Correct.
Moon is little
from Earth, from the
farther from
Earth.
From Earth, okay. So moon is somewhere.
The
here.
shadow region.
So what happens?
Cone ends. Umbra cone ends.
No, so just let her complete.
So that time distance increases.
and the moon will be a little smaller.
Can you repeat again?
So as moon is farther, the distance will increase, and then moon will appear smaller, little smaller, so that will.
Okay. So what she says is, for annular, the moon will be a little bit farther away. So the angular size of moon as seen from Earth will be less than usual, and hence it will not completely block the sun, and we will see an annular solar eclipse. Correct? Any other answer? Yes.
I think the opposite of this. If it is closest, then
If it is closest,
I mean, what is closest?
Moon is closest
Moon is
to the
closest.
perigee condition, and it is smaller than sun. So still we can see a ring either side.
Okay, so if this is the average position of moon, suppose, and this is somewhere around half a degree.
Yes.
Okay. Now you are saying if moon is closer to Earth,
Yeah.
what will happen?
Then I think we should.
Will it look bigger or smaller than its average size?
When I come close to you, does my face look bigger or smaller?
Bigger.
That's
Yes.
all.
Bigger. So moon will be bigger
Yeah.
than usual.
Yes.
So
But it is smaller than the sun. Yeah.
okay, so now we are saying if moon comes closer to Earth, moon will be bigger in size, but it will still be smaller than sun.
Yes.
Moon is smaller than sun.
Yes.
But then do you say at this position then the total lunar eclipse won't occur, because here now the moon is total solar eclipse won't occur because the moon is not completely covering the sun.
Why? Because when it is closest, then only it can cover.
Okay. So you are saying if moon was here, then it can totally cover the sun. But then what is happening here? So this is not total solar eclipse.
Maybe in a smaller area, maybe the angle will be smaller.
Okay, so we'll go to next slide. Okay, so as we saw, we all know that sun is very big as compared to moon. Average lunar diameter is about 3.5 into 10 to the power 3 kilometers, and you have lunar solar diameter 1.4 million kilometers. So, but then how is it that during a total solar eclipse, the moon still manages to block all the solar light, completely cover the solar disk? This is because the angular size that we see in the sky. So the ratio of the size of moon to the distance comes out to be this is the figure, but the ratio, the size to distance ratio of sun is also the same. Okay, so the size to distance ratio of moon and sun, they are the same. So when we see from Earth, both these objects look similar in size, which is why even though moon is closer to Earth and small, very smaller than sun, it can still cover sun. So
it's the same like with my single finger, I can cover many of you, right? Even though my finger is so small, right? If I take it far away, then I cover only a few of you. Right? But you take your finger, move it in front of your nose, further and closer to your nose, then you will see that you can cover bigger things or smaller. Okay?
And this is a coincidence.
Yes.
Yeah, but this is a coincidence. That moon is roughly the same angle.
Yeah. If the moon was much further, much nearer, much smaller, much bigger, situation will be very different.
Yeah. Right. Yes. Coincidences. So, but what happens in an annular solar eclipse? So, we all know that the orbit of moon around Earth and Earth around sun is not a perfect circle. It is an ellipse. So, these distances keep on changing. So, what will happen? So, if Earth is at perihelion distance, that is closest to the sun will appear a little bigger than usual, right? Because Earth is closer to the sun now. And if at that very point, moon is farther away in its orbit, then the moon will look smaller than its average size. And now the size to distance ratios are not the same. The size to distance ratio of sun is slightly bigger than that of the moon. So moon will not completely obscure the sun, and that is when you will see a annular solar eclipse. So here you see that the umbra part of moon, the cone, the apex of the cone is very far away from the surface of the earth. In total solar eclipse, what was happening? The earth's surface was right here. But now the moon is farther away in the orbit. So this cone ends before it reaches the surface of earth. And now this part of the shadow is antumbra, and this part of the region on earth you will be able to see a annular solar eclipse.
Again, look at the ray diagrams and tell me which light is reaching that region. Okay, so it's very important to understand again these things. So just take a look at which light is still reaching this region. Okay? Here, for example,
the lower edge.
The lower edge. Is it only the lower edge?
Upper edge.
It's the upper edge here, right? That's the reason why you see a ring. Okay, because even when you are here, you can still see this particular region and also the other particular.
Only the central disk is not.
Okay, so only the central disk which gets covered because light rays directly are not able to reach. Okay? So that's why these ray diagrams are useful, but you need to think a little bit more about what these antumbras and umbras and penumbras are. Okay.
But now what will happen in the penumbral region?
Partially.
Partial?
Partially.
We can see the light.
Yes, we can see some of the light or all of the light or
partially.
like full sun or not.
Partially.
Yeah. Partial?
Faint.
Faint.
So what is the answer?
Yeah, I have a question. For everyone. Why is this penumbra different from the earlier penumbra?
Yes.
Because of the distance of the
Distance
moon,
difference,
we don't have penumbra. Now we are having penumbra.
Question is about penumbra.
Yes, question is about penumbra. Do you think that once you have antumbra, you don't have a penumbra?
Would you see any change in the penumbra region? Would the person in the penumbra region see anything different?
Oh, the whole earth will be in that, so it won't be making any difference.
It will see increase.
It is big.
Yeah, right. The size of the penumbra increases, but do you see the sun or not from the penumbra?
Yes, we can see it partially.
Partial. So it will still, so in the penumbral region, it will still be a partial solar eclipse.
And it will be covering more part of Earth.
Earth.
So partial means, is it like half of the sun, 3/4 of the sun, or like
No,
you can see the sun but it is reddish? Like what is
No,
it?
no, no.
Like how does it look?
Just like
Partial
that,
or not?
partial.
Just how it looked before. Partial.
It's just a partial.
That thing.
As the name says.
Like this.
Sorry.
Okay, now another question. Okay, just like we said that we can see an annular eclipse when the moon is really far. What happens when the moon is closer than normal?
Total eclipse in a broader region.
Yes, eclipse in a broader region, yes. But now what will happen? Say, if I ask you time for the total solar eclipse.
It would be more.
Will it be more? More time when it will remain total or not?
Yeah.
Because now the moon will continue to go and the sun will remain behind the moon for quite some time. And then it will come out. Right? So all these things can also go the other way around. Right?
I feel because of close opposite periodic condition, this antumbra and penumbra, I think the angles will also change because it is closer and then the angle.
Yes, the angles will also change. Exactly. So the area in which you can see the total solar eclipse, that changes. Area in which you see the partial solar eclipse, that changes. And as our friend reminds me, if the moon is closer to you, it also goes faster. Okay? So there are like all sorts of effects that one has to take into account to check exactly what is the duration of it.
So there is something also called as a hybrid solar eclipse. So this happens because of the circumference of the Earth, the curvature of the Earth. So it may also happen very rarely that from some part of the Earth you see a total solar eclipse, and then as moon goes ahead and as Earth goes ahead in orbit, from the other parts you see an annular solar eclipse. Because the umbra, the apex of the umbra, if you see here, it is reaching the Earth's surface, but as the moon goes ahead, I might have changed the direction. We can start from here. If you see here, the apex of the umbra is not yet reaching the Earth's surface. So this is an annular solar eclipse. But as moon goes ahead, because of the curvature of Earth's surface, now the umbra can reach the surface. And this is a total solar eclipse. So this is a very rare phenomena. This is the same thing. Okay. So it looks like an annular solar eclipse or a total solar eclipse, and depends on the observer's location. The region is the Earth's curvature. Okay. So few things you should keep into mind while looking at solar eclipse or sun in general. You should never look at sun or at solar eclipse with naked eyes. You can use some goggles. These are special goggles which have some material pasted here. Or even by looking through the telescope, we have special filters which are attached here so that the light won't harm your eyes. So this is something we should always remember.
Which material is used to make that goggle? Can you make that material?
No, these are some specialized goggles which are made out of something called as a mylar film. It looks very much like aluminium foil, but it is not an aluminium foil. So don't use aluminium foil to look at eclipses. Sometimes it may also look like an X-ray film. There are different types of goggles, but it is not an X-ray film. Okay, so don't ever use an X-ray film. The thing is, these kind of specialized goggles are made in such a way that the harmful ultraviolet rays that they are blocked. There are certain things into this. Let's not go into the depth of that. But if you just use a blackened glass, X-ray film, or regular goggles, you are going to harm your eyes.
Which material?
And you can't make it at home. You can get this. So what happens is during eclipses, there are certain laboratories and some astronomical institute which tells you that these are standard goggles standardized by that particular institute, and they say, okay, you can buy these. There are many goggles available in the market, but there are certain specific things which you should buy, which have certification. Like these can be.
So one question: you use solar goggles during the solar eclipse. What about if I want to go today and see the sun?
No.
Should I use a solar goggle or not? Yes or no?
You can. Cannot look at the sun. You can. Solar eclipse.
Sorry. Solar eclipse, but for a longer time you cannot watch the sun. Okay, let's see more. Let's hear more.
So what happens specifically during solar eclipses is that when there is a solar eclipse happening and if we are directly looking at the sun, our eyes are designed in such a way that they change their shape and they allow light to enter, and whatever we are able to see is depending on that.
Yes.
But when solar eclipses happen, what actually does is the light that is entering in our sun suddenly gets cut off, so our retinas become smaller. Like they don't allow a lot of light. So when they're looking at something in dark, they become larger. So they are allowing a lot of light because we want to see clearly in less light. So, but when our retinas are larger and they're allowing a lot of light to enter, and suddenly when the change happens and a lot of light is entering,
it can burn the retina, it can cause harm to the retina.
Indeed. But
during
in reality,
but during normal times, if we are looking at something, our eyes are able to adjust a little more easier. So yeah, but you should still not look at the sun.
You should never look at the sun with
never.
your naked eyes.
Yeah.
That is the end of the story, okay? Because even if your pupils are able to adjust their diameter, it is still extremely harmful to look at the sun directly. There was Galileo who used to try to observe sunspots and he almost nearly blinded himself.
Same way how long we are sitting in front of the laptop.
Yes, so I mean, laptop is a different thing, but sun is like extremely difficult object. And so never look at the sun directly. You always try to use some kind of a special material like these goggles. And the reason why people always complain about these solar eclipses or tell you when during solar eclipses is because you are likely to observe the sun longer during a solar eclipse. That's the only reason why people say that, okay, or they hype it a lot that during the solar eclipse buy solar goggles. But in general, these goggles you should wear anytime you are looking at it. Or never try to look at the sun directly.
We can see directly during sunrise and sunset.
Yes, so during sunrise and sunset, there is the atmosphere which is protecting you, and we'll get there. But when it is high up in the sky, don't do
Okay. So about the next solar eclipse, total solar eclipse will be on 8th of April 2024, but you won't be able to see it from India. From India, on 2nd August 2027, we have a partial solar eclipse. Okay, lunar eclipse.
No need of filters.
Yes?
No need of filters.
No need of filters.
Oh. Agreed?
Yes.
Everyone agrees?
But why do you not need filters for the
Very less percent light is
Intensity of light is very less.
No, one by one. I have only 2 years, but I can only hear 1%. Unfortunately. So, yes.
The reflected light intensity is very less.
So probably because already reflected light is coming, so it's not the intensity. It's not so harmful for us.
So moon does not have its own light. It is reflecting the light, and when you reflect, only part of the light gets reflected. It's not like a perfect mirror or something. So intensity is there.
Okay. So lunar eclipse, the moon is passing through the Earth's shadow here. So Earth is in between sun and moon.
No.
Okay. Yeah. So again, this part, the darker part is the umbra, the fainter part is the penumbra. So this is how a lunar eclipse looks like. You have moon passing through the Earth's shadow. More and more part of the moon goes into darkness, and then you have a part where all of the moon is inside the Earth's shadow, inside the umbra part of the Earth's shadow, where it will look something like this.
Is it grayish?
reddish.
Reddish. Why is it getting red?
Okay. And then as it slowly goes out the shadow of the Earth, you can see full moon again. Okay, types. You have total, where it is looking reddish. You have partial, where a part of the lunar disk is inside the Earth's shadow. And you have a penumbral, where you have total, where the moon completely passes through the umbra part of the Earth's shadow. You have penumbral, where the moon is passing completely through the penumbral part of the shadow. And you have partial, where the moon partially passes through the umbra.
So remaining
It is passing. It's very hard to see here because she is not showing the full moon.
Actual full moon.
The full moon is even brighter than that. When it passes through penumbra, it gets a little bit dimmer. It's hard to notice sometimes if you are directly looking at the penumbra. Then partial is when you start to.
So partial में doubt समझे कि partial में हम लोग को umbra is partially covering the moon.
Okay, so which part is umbra here?
The darker one.
This part.
And the penumbra nahi cover करता है partial में.
What do others think?
Penumbra is there on the other side. Part.
So this part will be umbra and the remaining part will be on the
Penumbra. Yes. It has to be.
Is it every time a day?
It has to be.
Look at the Venn diagrams, right? Where is the umbra? Where is the penumbra? Is it always close? It is, right?
It is intended.
So you have penumbral eclipse. So here you have your full moon which is passing through the penumbra. You can see the drop in intensity. It is not very noticeable. But here, penumbral eclipse, moon is completely passing through the penumbral part of the Earth shadow. You have total eclipse where it completely passes through the umbra. And you have partial where it is partially passing through the umbra, which also means it is partially passing through the penumbra.
So where is the Earth here and where is the sun?
Earth is on our side.
Earth is on our side. That's why the shadow is what is shown. Okay. So the regions that are shown, those are shadows, and then the sun is even further out. See, whenever we see these pictures, now you try to visualize where exactly what things are. Okay? Because they will be given in textbooks as figures. There is not much space, and it is harder to visualize in 3D. So you always think about the 3D picture, where is what, okay? And then that helps you to understand these things.
So this is just again a collage of images for the total lunar eclipse. Next lunar eclipse, you will be able to see there is one on 24th and 25th of March.
Oh, next one.
Yeah, but this is not from India.
So.
Yeah. From India, you have on 18th September 2024, which is a penumbral lunar eclipse, and a total one in 2025. Okay, so some interesting facts about the eclipses. The color of the moon. So if you have noticed, the color of moon during a total lunar eclipse was red. Right? So actually now I have displayed the figure already, but can someone tell me why is it red? Looking at the figure.
Yes. The atmosphere is from the atmosphere.
It is passing through umbra, so it must be darker than usual. Right? It will, the intensity won't be higher.
Probably the same reason why we see the sun or sky reddish during the sunsets and sunrises, because sun rays they have to travel a lot and less scattering is done for red light, so probably for that.
The scattering phenomenon is the same. Yes, right. But can you explain me here how is it looking red? What is happening exactly? We have sun, we have earth, we have moon. The sun is the moon, the earth shadow is on this side. The moon is completely passing through the umbra, so it is a total lunar eclipse, and the moon is looking red. Is the light from sun reaching the moon?
Little bit at the edges, the red color is.
Okay. Is the light from sun reaching the moon during total?
This is very interesting phenomena. So yes,
your question is the light from the sun reaching the moon? So actually, because of this scattering of light on the atmosphere of the earth, a longer wavelength, which is the red, is able to pass and reach the moon. And that is why the red appearance.
Show me in this diagram, where is it?
The red arrow, which is scattered.
The red arrow is not reaching the moon, no? It is going
up, okay.
Dust particles.
No, dust particles are there. That is why all the blue and yellow light is getting scattered. So red light is going. But you look at the diagram, that light is not reaching the moon.
It's because of the reflection of the light that is from the Earth's surface itself.
Reflection of light from the
Earth's surface
to the Earth's surface.
Where is the light from the Earth's surface getting reflected? Just see the figure. Where is it going?
Entrance, no?
Which side is light? Which side is day?
It is going to the pole.
No. Which side is day?
Day side of moon, which is the day side. Yeah, this side is the day side, that's right.
So any light which will be reflected from here will go this side, right? This direction, not this direction. So it's not
She
reflection.
is talking about the North Pole and South Pole of Earth.
Yes, the North Pole and South Pole, there is some light that is getting, like entering this shadow.
No, it will just go there, right? I mean, the reflection will not do it.
Refraction?
Reflection, the word is.
Blue, gray, and other colors are reflected from outside. Red only falls through the.
No, so actually you cannot just do this by scattering. Okay, what you have to do is in addition to this, because there is a atmosphere here, these rays actually also get bent. That's the reason why you actually see the red.
So the refraction.
Okay, so if there was no refraction happening within the atmosphere, you would not have seen the red.
The red color. Correct.
So the way this is shown, in principle, this should not be red, right? It is only because there is some bending that is happening that allows this red light to actually reach them.
So the dotted red lines should have been little bit tilted.
The dotted red lines should have been even more tilted. They are in fact more tilted, and that is the reason why you see that.
So, what will happen if there was no atmosphere here?
Yeah.
Completely
First
black.
of all, we are not there.
Black.
Okay. But still. Right now we are outside the earth anyway.
So they will see it red only.
Then it would have been grayish.
And because then there is refraction taking place, there is scattering.
Refraction taking place?
Refraction is anyway going to take place from the poles. But
why is it getting refraction?
Okay, why do you get refraction? Okay, let's start with that.
okay, no atmosphere, then we won't get
So it is a matter of having a medium, right? Medium which is different from vacuum, so that you can get the.
Yeah,
There is no atmosphere, we can see the.
That means it will be great.
If there is no atmosphere, means we won't get any refractions, we won't get any color, red color.
Exactly. Then there won't be any color.
Yeah.
So will it be grayish or dark?
Dark.
Yeah. What do you
Is everybody following this?
Yes, sir.
maybe we need to explain it.
Is there a problem? Okay, who does not understand whatever we said right now? You should tell.
One
And
more
then we can go.
explain this.
Yes. Yes. Yeah, yes. So you can see there are some light rays, right? So we always used to draw like straight line diagrams. What we forgot about is that the Earth has an atmosphere. The size of this atmosphere is quite small. Okay, only tens of kilometers compared to the radius of the Earth. What is the radius of the Earth?
6,400 kilometers.
6,400 kilometers. And this atmosphere is like maybe 30-40 kilometers where it is most dense. You can go out even further if you want to be like little less is also considered atmosphere. Right? So this atmosphere, it's a very thin layer. What it's doing is it's taking the rays here. If they pass through the atmosphere, then some of these rays they get reflected. Scattered. And that scattering is happening due to dust particles within this atmosphere. Okay? And most of the scattering happens for blue light, which has small wavelength. While the red light, it kind of escapes because if the particle is this small and if your wavelength is big, you can actually just pass over. Okay? And that's the reason why red light is able to escape. It's the same reason why you see a red sun during sunset or sunrise, or when there is a lot of pollution, for example. Right? And so now that's the first thing. Okay, so what is escaping is only the red light and not the other light. That's the first thing. But that is not enough. Okay? Because even if it is like this, then it will still miss the moon. Okay? The only way red light falls on the moon is if this gets bent. The reason why it gets bent is because light is traveling from vacuum to the atmosphere, which has some refractive index, some density, and then it is again going back to the vacuum. Right? So that's the reason why when it goes, it doesn't travel really in a straight line, it actually bends.
It's like a tree.
When it bends, that's the reason why you see the red light covering the moon. Okay? Otherwise, without diffraction, you won't have seen the red moon during the lunar. So it's not gray, that's the first thing that we had said, and it is red because of this interesting thing.
basic question about optics again, because wavelengths are नहीं हुआ था clear. So again, the particles, because of scattering, why only the longer wavelength is escaping and why the short? Like, can you just explain wavelength?
So, I mean, in short, if you want to understand, it is like if the wavelength is larger, then these small particles you are not even able to see. Like the light is not even able to like realize that there are these particles. Okay, because
even light is sometimes particle and wave, right? Even light is both particle and wave,
The
right?
size of the molecules is compared to that light wavelength.
This phenomena is basically wave kind of phenomena.
Diffraction is a wave phenomenon, not a particle.
You want to?
Maybe after the
No, we compare the wavelength of red light to the size of the molecule. Size of the molecule is less than wavelength of the red light. So the red light will pass easily. It's not scattered by the molecules.
Does it require a molecule?
But anyway, I think we will get to this at some point because it's almost 1 o'clock.
So there's one.
I want to.
So apart from this eclipse,
Yes.
moon looks red. Apart from this, throughout the year, whenever full moon is there, that time we hear or we see that orange moon, pink moon, blue moon, all this. Isn't the part of the thing same? Or
No.
again?
No.
There are some different concepts of
Yeah,
it.
yeah. So those are just nomenclatures which are given. The moon does not turn pink or red unless it is an
It
eclipse.
does appear little, yellowish.
It will appear a little bit bigger or smaller, of course, depending upon the distance that it has from the Earth. But the amount of light that you get and the color that you get, that won't change. It can change if there are like small clouds around it, right? Or there is a lot of pollution, then you can see like more reddish kind of. So those kind of differences can do it, but not others.
And just last question, moon does not have any atmosphere. So no scattering, no refraction is there, right?
So, okay, so that's a tricky question, okay? Because, so indeed, the moon does not have an atmosphere, but what happens is the light from the sun, it irradiates things onto the lunar surface. And then there are some molecules which like leave the moon. So it's called the moon's exosphere, I think. So it's not an atmosphere, but it's not like it's completely devoid of anything. It's not vacuum. Okay? And there were interesting experiments even at the Astronomical Society of India meeting where they were trying to detect like what kind of molecules do you see just outside the lunar surface.
So it's the word which you use to say it again.
Exosphere.
Exosphere. Moon exosphere.
Yeah, the exosphere of the moon.
Sun's light is basically reacting with the part.
Yeah, it's irradiating.
Irradiating
The lunar soil. And then, yeah, you want to say something?
No, I mean that reacting, that irradiating that he's saying, it is not like a chemical reaction. That is something different.
Yeah.
Not reacting as in the chemical reaction, but
yeah, it's the radiation which is changing the composition, and it releases some electrons and so on. So that kind of a plasma that is there.
excited electrons, then the excites.
They are electrons that are released basically to the outer space.
Charged particles.
This is what the Chandrayaan
Chandrayaan
3 also observed. This was one of the experiments that it went through.
It's a very complicated small phenomena, but that's why I'm just telling you, no atmosphere, yes, but there are. It doesn't mean it's completely.
जब बच्चे बहुत curious होते हैं, fourth state of matter को plasma बोलते हैं, plasma है, तो मैं बोल सकती हूँ थोड़ा.
Yes.
So that's plasma.
So plasma is basically charged particles, right, which are moving around, and so in this particular case, it is this plasma. Okay.
So, no, we have a question.
Just 2 minutes. I mean,
So though some of the time when we don't have eclipses, we still see sometimes moon as pink moon or red moon.
No, we don't see. That's the point. They just nomenclature. They say that this is pink moon, but it's not. It's not really pink. If you see a pink moon, please send us a photograph.
How the world it is celebrated? Pink moon.
No, they celebrate, but you go outside and you check. Do you see a pink moon on that day? You will not. Okay.
Okay.
We need to
So,
move on. Because
yeah,
the food
we'll
is-
just quickly wrap up. So the speed of moon shadow during the solar eclipse. So this is again an interesting fact to notice that this speed is about 2600 kilometers per hour. The speed of the dark part, the lunar shadow on the Earth's surface. Okay. So again, we had a small discussion about this. The duration of totality, that also changes, and it ranges from a few seconds to a maximum of 7 minutes and 32 seconds. Also, we also had this discussion that not every full moon day is a solar eclipse, and not every new moon day is a lunar eclipse, because the orbits are different. The orbit of the moon is not in the same plane as that of the Earth around the sun. So, which is why, so now in these two positions, the first and the third one, here it so happens that when the moon comes in between the sun and Earth, it is exactly along the line joining the centers of sun and Earth. So at these two positions, you will have a solar eclipse. But in these two positions, the second and the fourth ones, that is not possible.
Can you repeat these two concepts?
This is very important. Yes.
The orbit of the lunar orbit is not in the same plane as the solar orbit. So if you see here, the second position, this is the first, this is the second. If you see here, the moon is slightly above the plane of the Earth and sun. So it will be, but still there will be a new moon day because you are looking at the darker side, but it will not be a solar eclipse because moon is not along the center, the line joining the center of the sun and Earth. But if you look here, now the orbit of the moon, and when you see the position of the moon when it is between the sun and Earth, it lies exactly along this line. It is not below, it is not above, it is in the same plane. So you will have an eclipse. And the last part, I think, eclipses always come in pairs. So if you have one eclipse, you have solar eclipse. After 15 days, you will have a lunar eclipse. Vice versa. Okay, thank you.
Also, can you go back one?
Yes.
This is another important thing that I want to mention. So just look at this plane. So this plane always remains the same. Okay, it's not like moving around and precessing around. At least not at very high speeds. Okay? It does precess around, but not at very high speeds, right? And so you see this angle is always this 5 degrees. Okay, and that's the reason. Like, how much time does it take for Earth to go from here to here? About 3 months, right? 3 months, another 3 months, another 3 months, another 3 months, right? So typically, these solar and lunar eclipses, they will be separated by how many months? 6 months. Okay, you try to check this. Like there is list of list of eclipses that will be given. You should try to see whether you see this kind of a 6 month difference or. Okay, that's the first thing. Second thing is these things coming in pairs. Okay, that is also something which often happens, and so that is another thing that you should check. There is a solar eclipse and then there is a lunar eclipse. Of course, many times you won't observe it from the same place. So that can be another tricky part, right? Okay, so those are the two things, and then yeah, this thing you covered, right? Okay, good.
Okay. So because of this 5 degree period of orbital plane, only we get different rise and set also. In general, rise and set timings also.
Moon rises 50 minutes later every day.
No, that's not because of
That's for the Earth.
Moon's rise time is not necessarily, I mean, there is always some relation, but not, I mean, most of the effect is just because the moon has moved in its orbit. Okay? And that's the reason why it appears to rise earlier,
later every day.
Rise later every day.
It's because Earth has moved ahead.
Sorry, rise early.
No,
First the later. Yeah, of course, right. Set up. Right. Yes. This is the other. Yes, that's right. Rise early. Yeah.
So sometimes we can see moon even during the daytime.
Yes.
So,
very good. Yeah. So this is a very interesting misconception that people always have and students will always have. And this is a result of all these cartoons which show that when the sun comes up, then it's daytime. And then the sun goes down, the moon comes up, then it's nighttime. That's not true. Right? So you can see the moon during daytime, and it's not at all related to anything to do with day or night. The appearance.
I understand why this happens because my children ask this question and I'm like,
oh, you don't know why it happens?
Yeah, can you explain me the picture?
You don't need a 3D picture.
It delays 15 minutes every time.
Oh, you were talking.
We have 2 hours to discuss.
Then we will discuss it now. So this is not waiting for us.
This is the most data right and almost internet. So many people implement yeah, it doesn't tell you that.
We'll try to be back at 2. Let's see. Yeah.
The distance between the Earth and Sun means red moon and blue moon, right? If the distance between Earth and Sun is smaller one, you will have a red moon.
No.
The distance between Earth and Sun is bigger, we will have blue moon, right?
No, there is no blue moon. You don't see a blue moon. If you see it, this picture, you would like to see.
So basically, these are terms given by like farming communities of Europe, etc. They say there is a shepherd moon, there is a hunter's moon, there is a worm moon. You don't see worms on the moon or hunters there or anything like that. These are specific names to say that this moon happened in this time of the year.
Yes.
Okay, so they have certain things.
This is going to be fun. Okay, so just a quick announcement. I've been getting some requests about trying to get some more members for the stargazing session. Since we are almost like 40-50 of us, it will be harder to accommodate any more people right now for today. But if you are from if you are from Pune, then stargazing sessions happen almost every Friday. So not this month because we are preparing for National Science Day and so on. But these stargazing sessions happen quite often. So you can come during any of those other sessions with your more family if you want. Okay? So just to inform, because otherwise it will become a difficult thing to manage. Sure. Okay, so the next thing that we are going to talk about is tides. Okay, this is another concept which is interesting but also somehow difficult to understand. The figures that are given typically, it's not easy. Even for us, at some point we are thinking, are we really understanding this concept or not? So that's what we would like to talk about now. Pritesh Randive from HBCSC.
Thank you so much. I think I'm audible, right?
Yes.
Perfect. So my name is Pritesh. You can call me Pritesh. Unfortunately, I will be leaving very soon after the talk because we have another workshop in Mysore next week for teachers. Slightly different from this. So we'll have to leave very soon and we'll get very less time to discuss. With that, let's start talking about tides. To be honest, this is a very difficult topic, except the fact that we have all seen tides. And I would like to make this a discussion rather than a lecture. Okay, so I will try to give you some hints through the slides, etc. But we all here, like me, Surut sir, Mopia, Sai, Asmita, all of us will try to answer your doubts. What we will need from you at the end, when you go back, we would like you to think how to teach this topic to kids. We can tell you the concepts, we can try to explain you the concepts, but I feel that we lack how to communicate it very thoroughly to the students. And that is where you come into picture. And that is why we are actually having this kind of programs. So let's make it a discussion kind of session. So the topic is tides. Alright. So let's start like what I did. We'll have some basic idea of tides. So what do you think are tides? Let me write it on the board. What are tides?
Rise and fall of sea level.
Rise and fall of water. Okay. Rise and fall
Of sea water.
Of sea water near the coast.
of sea water. Second. What else? Anybody wants to add more to it?
There are high tides and low tides.
Lunar exactly.
High and low tides. Very good. I mean, this very good has nothing to do with correct answer or wrong answer. It is just an expression to, okay, go ahead.
It is
I want more answer.
caused due to gravitational force.
It is caused due to gravitational force, so we are right at the causes. Okay, anything else?
Happens twice a day also.
Okay, one at a time. So man says happens twice a day. Or somebody,
Each tide is delayed by 26 minutes.
each tide is delayed by 26 minutes.
Low tide, high tide can be forecasted. Can be forecasted.
You can forecast tides. You can tell in advance when the tides will.
Water circulation of sea water.
Sea water circulation.
Monsoon air.
Huh? Sorry?
Monsoon air circulation.
Monsoon air circulation. Okay, it has to do with tides.
How often does it happen?
So rotation of Earth is one of the reasons.
Rotation of Earth is a reason.
Yes.
Anything else?
Spring and new tide, they have more tides.
Who said spring and neap tide? Okay.
And these are things you hear in the textbooks.
Very good.
And new moon day, we have more tides.
Full moon, new moon connection to tides, something like that. Yes, sir. Sorry? Harness electricity.
Connection of topic.
Okay. Any myths about tides?
Sir, I just want to ask, is it anyhow related to the blood pressure or endocrine system? That is what they say. I don't know.
I just write this down. I'm not saying if it is right or wrong.
Let's write it down.
Blood pressure.
Yes, sir.
Yes, I have high blood pressure. I am always at high tide. Anybody else?
It is good for fishermen.
Good for fishermen. Okay. Okay. Economy. Okay, fisherman is the economy.
That's another question. Has it anyhow related with the migration of the aquatic animals?
Sorry?
Has it anyhow related to the migration of the aquatic animals?
Migration of aquatic animals. Okay, I'm not an expert in that, but I will just put it. Tsunami, somebody said. Migration. Is it? Should we stop at this point?
Yes.
Yes.
बहुत हो गया। अब नहीं करना है। हम शायद रुक जाते हैं थोड़ी देर। So, first question. What are tides? So the sea water rises up, sea water settles down, and we say there was tide. When it rises up, we say it was a high tide. When it goes down, we say it was a low tide. Alright, so this is what we know. There are various questions related to this statement, or rather on this statement. Why only sea water? Wow. No, I mean, I'm just posing the questions right now. Let's not try to answer them. We'll go through the presentation and see what we can. Why only sea water? Why not other waters? Why high and then low? When high, when low?
High during the day and low during the evening. That's not answered.
So there are various questions, right, that come to our mind. That comes to our mind when we talk about tides. So let's see what is happening here. I have an experiment. Like when we were discussing tides, sir said that let's give a practical question to everybody. In the inside here, do you recognize what it is?
Yes, in the report, sir. It's written there.
It is into the report. It is written here, but I just wanted to show you that this is into the report. And then what is this? This is basically the Google Map image of Sindhu. If you see it, there is some way to get inside the fort. The fort closes when there is high tide. You can't go in. You need, I mean, of course, you can go in by boats, but not by the way, the road or something like that. The question is, I want to get into Sindhu fort, and by the end of the talk, I should have some way of estimating when I should leave so that I can get into Sindhu fort. So, for people, for our friends from Tamil Nadu, Sindhu fort is a fort which is built in the sea, and it has a way connecting the mainland to the fort. And when the water rises, this road goes underwater during high tide. So you have to basically go by boat or wait for the tide to recede. Okay, for low tide, and then you can do it. Alright. Moving ahead. So this is one of the definitions of tides. So tides arise. Rather, explanation for tides. Tides arise because of variations in the gravitational field of the sun and the moon at points on the Earth's surface. So there are some bodies in space which we call as sun and moon, and they might be causing tides, is what this thing is saying. So as somebody rightly said, tides happen because of gravitational force. So the sun has its gravitational pull on Earth. Just one. The moon has its gravitational pull on Earth. They are at varied distances, and because of them we have tides. Yes.
Varied distances because of the elliptical apogee and perigee, and the second elliptical orbit ke wajah se there is difference in the distance that is causing variation in the gravitational field. And the other could be there is difference in the point in the geography of the Earth, because gravitational field is felt strongest at the poles.
Yes. Okay.
Is that the reason why it is written?
So we'll come to the reason. Okay. We'll come to the reason.
Just asking a question.
So this will get clear as we go ahead. Huh? So first let us consider that Earth is going around the sun. Okay, I am talking about sun right now. I am not talking about anything else, just sun. And I just want to explain you one simple thing, that Earth is going around sun, and here is sun, here is Earth, here is the orbit of Earth. Because of mass of Earth and sun, there is a force between them. This force is called as the gravitational force. This acts along the lines joining the center of the two bodies. That is what we learn in our textbook. This is radially inward. It is pulling Earth towards the sun. The Earth is falling towards the sun. But then there is also something that the Earth goes in an orbit. So it has some instantaneous velocity and it goes in a circular orbit around the sun. So there is a countering force which we call as the centripetal force or centrifugal force. Right? We all have learned about this. Which acts exactly in the opposite direction and balances. So everybody knows what balancing of forces is. And the Earth goes around the sun and it doesn't fall on the sun directly. Clear? We are assuming that the orbit is circular for now. I mean, this is a perfect circle because I have drawn it using paint or something. Google Slides. But the orbit of Earth around sun is elliptical with a very small eccentricity. Very small eccentricity. So if you try to draw it to the scale, maybe you will just see like a circle. But it is an elliptical orbit. And when at that scale, you will see that the nearest and farthest point are varied distances at different distances, and those are significant values for us. Alright, so what is the centrifugal force or whatever that is? We all have sat in cars or merry-go-rounds or things which go, in circular fashion. And when the car is turning or when the merry-go-round is moving, what happens? If the car is moving like this, you are pushed away. Is there anybody pushing you? There's nobody pushing you, right? But still you feel a push outward. That is a centrifugal force. So this is the centrifugal force, and this was the velocity. Let's say this is Earth, this was sun, and it is going like this. Now this happens in a circular orbit. This is a pseudo force, as we call it. Pseudo force. Anyway, this is some kind of force. I don't see who is pushing me. I feel it. Have you experienced this when the car is moving straight? No. How many people say yes? How many people say no? No, right? Car is moving straight. You have to speak. I mean, this is not a lecture we are discussing.
If there is brake,
That is in
When there is brake. What is happening when we brake? Inertia. What happens if I suddenly start accelerating the car? Will I feel this?
Yes.
Backwards.
I just
Go behind.
go back, right? When I do that. When I push the accelerator, I go back. When I apply the brake, by inertia I come forward. So whenever we have acceleration, we have this kind of pseudo forces. This centrifugal force is when we have this circular motion going on, we feel an outward force. So is this part clear? Okay, perfect. Now, I mean, we are sure that you know all these things. We just want to put things in a simplified way because a horrendous picture is coming in front of you in a few slides. Okay. I mean, that scared us for a minute. And maybe not for a minute, maybe more. But yeah, we'll see that. So now, these forces, when we say are being balanced, I just wanted to show you, or rather ask you, there are 3 people here, 3 people here. Okay? And they are pulling this with pulling this rope with equal force from both sides. What will happen?
It will not move.
Resultant force zero. No movement.
They won't move. Equal force, opposite directions, nothing will happen. They will be there. Resultant force is 0. Is one answer. Right? I never said that they are moving like this. They are just pulling like this. That's it. Now I just tell this girl to bhag ja. What will happen?
We'll go that way.
Unbalanced, and these guys will fall this side.
Yes.
So kya hua? The force which was equal and it was opposite, suddenly this side decreased and the resultant force was in that direction. Okay? So we had to understand 2 things here. One is the magnitude of force, the numbers, which let's say 3 is the magnitude here, 3 is the magnitude here, correct? And then there is direction. These guys are pulling it this way, towards me. These guys are pulling it away. So there is a direction. And the resultant will be, whichever the magnitude is higher here, because my friend left. So everybody fell on that side. Magnitude was higher in this direction, so they fell this way. Now you might be saying, "Kya ho raha hai? Tides padne aaye the, kya pada hai wo? Rassi khinch." But now we will go to the actual picture. So this is a cross section of Earth through its center. Okay. Now, okay, do baar. So this is our Earth.
That is not good. That is.
So this is the center. So there are 2 cursors. So this is the center of Earth, and this is my Earth. I have cut it along the equator. So I'm looking from the pole right now. Okay, along the cross section. This is the white Earth for some reason, because I'm lazy. I could not color it. Now let's say there is sun or moon in this direction. Okay, let's say sun or moon is in this direction. So there is a pull at the center of magnitude Hg towards the sun. Clear? Okay. This is the orbit. Now the Earth is extremely large here. The orbit is still seen curved, which won't be the case. So this is disproportionate, not to scale image. Just a representative orbit of Earth to show that Earth is revolving around sun. So for now, just forget moon, we have sun in one direction. So because of this revolution, we have this centrifugal force, which is in opposite direction, represented by a thinner arrow. Clear? Okay, now starts the difficult part. Till the forces are balanced, the net force at the center is first. Everything is fine, nice. Earth is going around sun. Earth is still going around sun. Now, what we do is, I try to calculate the force at this point, which is towards the sun, nearer to the sun. What is this distance from here to here? Value?
6,400 kilometers.
6,400 kilometers?
Exact value.
Okay, exact value, 6,380 kilometers. So this is around 6,300 kilometers or 400 kilometers away from the center. And we all know gravitational force is distance dependent. There is the R square factor sitting there, G M1, M2 upon R square. So if the R decreases, the force decreases by the square of it. right? Increases by the square of it. So this force increases. So now you see the gravitational force, which was represented by a thick arrow, has increased its size. The magnitude is more. On the other hand, this point is 6,300 kilometers on the other side. So the gravitational force is smaller, and you can see it by the shape of the arrow, size of the arrow. The thick arrow represents gravitation. But the centripetal force, that remains same. That is going to remain same. There is a complicated argument behind that, and if you want, we can discuss that later. But for now, let's say the centripetal force, or you accept it, I mean, I am telling you, accept it for now, that the centripetal force remains the same. Centrifugal, sorry. Centrifugal. Okay?
Centrifugal force formula.
mv square by r.
M omega square by r. R, M omega square r or M square by r. Okay, but remember, whenever you are writing this M omega square r, etc., you need to know what M is that, what r is that. Okay. All right. So this part is clear. Okay. Now this was what we were talking about.
So messy.
So messy. Extremely messy. Now I will try to explain this to you step by step. First, concentrate at the inner circle. This was our earlier Earth. Written here Earth. The inner circle, dark circle. Center of Earth. Fg, the gravitational pull towards Sun. Fc, gravitational pull, centripetal force, centrifugal force.
Away from.
Away. Here the gravitational force.
More.
Centrifugal force same. Gravitational force less. Centrifugal force same. The resultant here was Ft, which is 0. The resultant here will be in this direction. Correct? And the resultant here will be in this direction. Because the centripetal force, centrifugal force is directed in this direction.
And greater magnetic.
Remember my friend who left the rope and everybody fell on the other side? On this direction. Now what this outer circle or outer ellipse or the inner ellipse represents is, it basically tries to show you how the tidal bulge will occur. Now what is tidal bulge? So if I keep some mass or water body here or water body on the earth, how much it will be pulled in this direction? So this is fine, right? Like I know that the water will be pulled towards sun. But the physics that we just saw, it also shows me that the water on the other side is also being pulled outward and not in this direction, but radially outward. What does this tell you? That there is a bulge and the bulge is on both the sides. Okay, we'll see this more clearly in coming images. This is how the explanation is given in the textbooks, and this is how we try to explain, derive forces, etc., etc. But it is not that simple. Okay, I mean, when we started discussing, we also realized this, that it is very difficult to explain, difficult to understand. So let's try to see what happens. Let's say, I will give you an example. Okay, before that, I have a question. So, okay, so there will be a bulge on this side, there will be a bulge on this side. This is clear, right? Now we have the picture clear that because of some body, here the sun, there will be a bulge, and the bulge will be away in this direction or radially outward in this direction. That was very clear, but it will also be radially outward in this direction. That is also clear. So the first misconception that it should always be in this direction is gone. Is that clear? Okay. We have successfully entered a new regime. जहाँ पे हमें पता है अभी दूसरे तरफ भी on the other side, diametrically opposite side, there will be a bulge. Now what is happening? The water on our planet is being pulled like this. Okay, in a way to say it is being pulled like this. So water from this region,
there is a contraction.
It is or being pulled in this direction. Water from this region is being pulled in this direction. यहाँ से यहाँ आ रहा है, यहाँ से यहाँ आ रहा है, और ये मिल रहा है. ठीक है? For a fact, everything looks fine. Now enters Earth, and Earth says gravitational force is distance dependent. The moon or the sun is lakhs or crores of times away from you. Why are you not considering me when you are talking about tides? There is Earth sitting here, right? Isn't the Earth going to pull this thing towards it with a much more force than the sun and the moon, which are very far away from Earth? You get my point?
Yes. Yes. Earth's magnitude.
So there is a problem here. I want you to appreciate that problem first.
There are already some questions.
I know. This is the point where after this there is nothing, like practically there's nothing left in the dog. So you understood the question. There is Earth. Earth पर का पानी जो है वो बाहर की तरफ खींचा जा रहा है because there is water on Earth that is being pulled outward in both the directions because of some body which is outside Earth, too far. But boss, we have not considered Earth.
And Earth has its own magnet.
Earth has its own gravitational field.
So same GMM upon R square applies to Earth and the particles also.
Yes, I mean you consider that all the mass is concentrated at the center and say that okay, the Earth is also going to pull the water inside, right?
Yes.
Why will it leave the water outside? The force that these planets or satellites or star apply, it is very less as compared to what the Earth applies.
Correct.
Rather, it is million times lesser. 10 million times lesser. Why do we have that?
Exactly. Tides नहीं होता.
Then tides rotation. Okay, we have not even introduced rotation. Rotation has nothing to do practically. It has nothing to do with tides. So now what you assume is there is some point here at this place. Where will the point be pulled?
Outside.
This direction, this direction, this direction, this direction. If I
Vector resultant.
How many people know vectors?
There is tangential vector and resultant direction.
Tangential vector, yes.
I mean, just to add, is it because of the formation of a couple, equal and opposite forces?
Formation of couple and equal and opposite forces, there will be tides.
Yeah, I think so.
Okay, I mean, it's good. So you can see this circle, right? So if there is this point, it will also pull towards the moon, right? Or whatever body. Now this is a vector. Okay, this force. And I can say that there are some components to this vector. One is along this direction, one is along this direction.
Horizontal component.
Horizontal component, vertical component. Okay. The thing is, this is a very small force as compared to the Earth's force. Right? So this vector, which is radially outward, it is not going to matter. Earth is going to pull it with such a significant force that the vector is not going to even, that force will be negligible. But what remains is this vector. Okay? So just to give you a recap, if I have a line like this, and this is my coordinate system, let's say, I can say these are the two components. One is along x-axis, one is along y-axis.
Does everybody know vectors and components?
Yes.
Who does?
How many people don't know?
Maybe that is a better question. Who does not? Yeah, I mean, please feel free always to say these things, okay? Because we don't want you to go by not knowing this. So if you don't know, just say. Okay? Yes.
So it's okay to not know. I mean, why everybody should know it? That's it. Like, but yeah, it is good to know.
Can you erase?
Erase some part of the board.
No, we need that. We need that.
That projector is motorized, so.
Oh, the whole thing is.
Yeah, whole thing is.
We have 2 points, sir. First 2 points we have.
We will erase some points.
First 2 points.
The first 2 points we can rise and fall, hydrate, rotate, with first 2 points.
Even third also, gravitation.
Not yet.
That's it.
Okay, so I will try to quickly tell you the idea behind this. This x-axis, y-axis, everybody knows. Right? If I draw this line, I can say that there is this, and there is this, and together with this and this, I can make such a line.
Maybe another way to understand it, if I want to go from here to here, what I can do is I can first go from here to here by this amount, and then go straight. So,
in technical terms, since this is x-axis, I will say this is the x component and this is the y component. So somehow the x and y components will tell me what this exact vector is. It will tell me its magnitude, it will tell me its direction, etc. So coming back to our Earth again.
Is that okay for people who did not know vectors? It's like you are decomposing it into 2 different directions. So I want to go there, then I move here and I move there. So similarly, you can do things with forces. If there is a force here, you can say somebody can pull from this direction and from that direction. Resultant, you will go in that.
Okay, so now if this is the direction of force, somewhere is the sun. A point here, let's say this is the vector now. I can say there is one component like this and one component along this. The angle between them is 90. But you remember, the Earth's gravitational pull is going to cancel this component. I mean, uske liye wo bahut kam. It's very small. So what remains?
The horizontal component.
The horizontal component. This is tangential thing, right? But the tangential thing is also very small. The tangential thing is also very small. What happens is, at every point except this point which is directly below the sun, you have this small tangential component, and all these are pushing the water towards this line. And then you get a bulge. Now you may ask, what is happening on the other side? So on the other side, again I can have a component like this. Again I can decompose it. And I will get the same thing. Okay? So I have tried to explain you in so many words and with this figure what is happening and why tides are occurring. This is what typically textbooks tells us. But from where we have taken this, you should definitely visit this page and try to read it, discuss with your colleagues, friends, or us, and you will get a better insight on tides.
So there's one more, I mean, right? Why is it in that direction? The moon is still there, right?
This is a question for you guys.
Yeah, exactly. So what did he forget right now? He did not show you something.
Sun is on one side and other side the moon.
See, there is the moon is here, right?
Sun is
there. Doesn't matter.
Doesn't
Some massive body is there. So why is this point getting attracted here, right? That should not have been.
Centrifugal is greater magnitude.
What he did not show is that you have to actually subtract the centrifugal force, right?
Yes.
So there is a gravitational force, but there is also a centrifugal force.
The direction of force where the greater magnitude is.
Yeah. So you will get them.
Okay. Alright, so this is just explaining the diagram. So there is a nice paper, you can read the paper, it explains more about tides and it shows you how much is this force or how much is this pull on different points of Earth. So you're looking from top, okay, and you're seeing the water is being pulled on both the directions. This is just a way of representing it. So this is how the tides flow. Now I have quietly moved sun out, moon has come in, and you might say, kya hua? Till now it was sun. This guy was talking about sun all the time. Suddenly he added moon sometimes. Now again there is moon. Then he said moon sun doesn't matter. You might be thinking what is happening. So we'll come to it because we have an exercise for you. So this is what is going to happen. Looking from top, this is North Pole or South Pole, doesn't matter. There is moon. There is a bulge here. There is a bulge here. On top and bottom, there are low tides. Okay. There is one thing which is shown here, which we did not mention, but when you solve the components and resolve the components, calculate the forces, etc., 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 you would realize that the high tide, the height of the tide of this direction is not same as in this direction. We will not get into that, but for a fact you can remember this. So this is a real picture of that. Now there is gravity and there is this bulge. So I wanted to show you that NASA has developed some very beautiful animations. You can freely download them. So this is how I get. And you see what is happening? It is, okay, there was a point. It is clearly shown here that the water is being pulled in this direction in a way. Okay, because of that tangential component subtracted from the centrifugal force, to get all this water being pulled and the bulges occur on the two sides. Now, the moon is going around, the earth is rotating, so you will have tides every now and then. How much should be the time? So the tides will occur every
quarter.
one high tide and second high tide should occur after
12
hours. And in between there will be a low tide. Okay, so in 24 hours, I will have high tide, low tide, low tide, and day is complete.
But Veda, I'm getting some sounds which say that this has to do with the daytime and nighttime. So just be careful about it. Right? This is moon, we are showing. There is no sun around here. So there is, so that one has to be careful.
Okay, now we have to wake up and we have to solve something. So we are not going to derive. I have just written one equation here. Very simple looking thing. F tidal is the tidal force. This is the formula for tidal force. That is equal to G, which is the gravitational constant. This value. Some M 2 into R by dQ. So remember, this tidal force is not 1 by R square, it is dq. There is a d cube factor. And now something interesting happens, and all your notions like why this guy was talking about suddenly of moon, suddenly of sun, somebody said moon is better, somebody said sun is better. So all these things will now fall in place. For that you have to do this. You take this value, लिखा है यहाँ पे m, r दिया है, d दिया है. Okay? It is written gravitational body causing tidal force, body subjected to tidal force. That is, tide is happening on this body, caused by this body. So what I would like you to do, I will give you 5 minutes. Just calculate the tidal force on Earth because of sun. So you will use the first row and calculate.
Sorry, one quick thing. So can you define this radius r and distance? What exactly? Because there are two distances. One is r, and sometimes you use GMM by r square.
Okay. So this r. Okay, let's talk about this d first. This d is the distance between the two bodies. And this r is the radius of that body on which we are trying to calculate it.
Geometrical radius. Geometrical radius of the body.
Spherical radius. So this is that r. Small r is the radius and d is the distance. Okay. So can you quickly calculate what will be the tidal force on Earth because of sun, and then calculate what will be the tidal force on Earth because of moon? It's just punching some numbers in your phone.
Do you know Google can do it? Like you type G times mass of the sun times 2 times radius of Earth divided by this dq, it will be able to do it. Okay? I don't know if you know this thing, so I will write it down.
You have phone?
Yes.
Yeah.
You have notepads? Just quickly do it. I mean,
like capital.
There's a power is
And something like this you can write and it will understand.
third row about?
Huh?
What is the third row about? Tidal force on moon because of sun.
Yes. We'll come
to that. Okay, so how many people could calculate? Okay, maybe what you can do is, some of you can calculate this. Maybe this group here, this group here can calculate the first row.
I'm doing it, sir. I'm doing it.
Some of you can calculate the second row and quickly tell us the answers. And we'll write it on the board somewhere.
So this thing you have to do. So in principle, you can write exactly this thing in Google and it will actually do it. Okay. So instead of this, you just type this sign. But just don't forget these brackets. Then it might do it for you.
The first one is 16.9. 10 raised to 25.
Okay, I assume that the units etc. are in place, so I will write it. Okay, next. So I hope you have done the cube.
She didn't perform the cube, I think. Denominator cube is there. 50.104. 104 into 10 power.
What is saying? Which one?
5.010 is the answer.
Into?
That's all, that's the answer. 5 times.
Second one? Okay, 1 more minute and if we could manage. Okay, slightly, and you had no power to answer?
Yeah, I have that meter. I didn't start that. Because I'm just saying, all powers. Many of us would have forgot the cube, but
okay. So what I will do is I will
give the answer.
Should I reveal the answer?
Yeah, please.
3 PM,
yeah,
nice food, slightly sleepy. After setting business courses, and knowing the fact that अब तक जो पता था टाइल्स के बारे में वो तो सब गलत है. Okay, so let's see what exactly happens. So if I take this first row and calculate, what I get is F tidal because of moon on Earth comes out to be this value, and F tidal because of sun on Earth comes out to be this value. Which number is higher?
Moon is greater.
Right? How much it is, like by what factor it is high? Around
2 times.
So the tidal force on Earth because of moon is around 2 times the tidal force on Earth because of Sun. Remember, Sun is 10 to the power 30 kilograms. Moon is 10 to the power around 22, 23. Moon is 10 to the power 22. Very small, right? I mean, it's a huge difference between the masses. But remember that the tidal force is distance dependent, but it is dependent on the Q of the distance. And hence you see that the moon is causing much more impact than Sun. Clear?
Much more is exaggerated, not just twice.
Just twice is quite a bit, right? 2 times. But now, yeah, I mean, okay, it is always relative. So, for me, it is okay. It is twice that of moon, twice that of Sun. What if I do the same exercise, but now I calculate what Mopia was saying, that what will be the tidal force on moon because of Earth? So the last line of the earlier table. Tidal force on moon because of Earth. If I just put these 3 numbers in this equation and add the value of G here and do the multiplication and division, whatever, solve it, it turns out that it is almost 22 times bigger. Now this is, can I say much more? So the moon is causing a tidal force on Earth, which is twice that because of Sun. But when you calculate the tidal force on moon because of Earth, it is almost 22 times of what the moon is causing on Earth. Okay, this is just for a fact. Like I am sure you will appreciate these numbers if you think about it more. बहुत ज़्यादा है. Remember one more thing. When we say moon का 2 times है sun के, the tidal force due to sun is half that due to moon. When we are talking independently, when we talk only about moon and calculate the force only about sun and tidal, does it happen in real life? They are always there in the sky, sometimes together, sometimes away from each other. So what is happening? We should calculate the resultant of the two. So it is always some form of addition of the two forces due to sun. So the tides are caused by sun and moon, but the major factor is because of moon. Clear? Yes. All right. Now, there is a nice book you should all refer at some point. And there is a picture that if Earth was not accelerating and Earth is in free fall, that is going around. So let's say I keep sun and Earth has water. Will there be tides? You also had a similar question in the questionnaire, right? If moon disappears, what happens? So something like this. The minute the Earth starts revolving, you have tides on both the sides. Forget this free fall, etc. Okay. So here, what you are seeing is, I don't know if you can see the blue ellipse. So the blue ellipse is lunar tide. The orange ellipse is solar tide. The moon is moving. So what it tries to tell you is the tidal force because of moon, the tidal force because of sun, and the resultant tidal force. Okay, so this is a composite again. How the forces act together at different points when the moon is at different points in its orbit. How we see the forces and what is the resultant of the tidal. Okay, it nicely shows you that as the moon goes, there is a tidal force. You see the blue ellipse. It rotates with the moon, right? And the resultant you can see always. All right. This brings us to the fact that there are different types of tides. Somebody said here, spring and neap tides. So what will happen when both moon and sun are together in the sky? When I say together in the sky,
On one side, same side.
on the same side in the sky. Okay. What is this phase? Which phase? New moon. So new moon, both the moon and the sun are in the same direction, and we will have very high tides. Okay, these are called as spring tides. But after, let's say, 8 days, the moon would have traveled here. Okay? Or let's say here. So this phase is what? Half moon. Right? Half moon, or we call it Astronomy. So this was Amasya. Moon went like this. This is Astronomy. Here was somewhere Purnima. So at this time, what happens is the moon is pulling this way, the sun is pulling this way. So the low tides are higher than usual.
Neutralized.
Not neutralized. You can't say neutralized because the moon's pull is twice. If it was same, then we could have said neutralized. But that also I will have to think. So these are called as neap tides. Okay, the low tides are slightly higher than usual. So these are the types of tides. So there is another fact, and I will give you some reasons for why it happens. Till now, what we said was moon overhead hai, there will be a tide with the line joining the center of the earth, center of the moon, and the bulge will be on this line. Right? That was what shown here, everywhere. But does that happen? The answer is no. So what happens? The tide precedes the moon. That means the tide will come first, there will be high tide, and after some time the moon will come overhead. Okay, it doesn't happen that moon is overhead and high tide is here. No. The tide will happen first, and then the moon will come. Is that clear? So it is said that the tide precedes the moon. The moon follows the tide. Yeah, we are coming. So this is for a fact. We have to take it for a fact that the moon follows the tide. Now why does this happen? There are some reasons listed here. So if I was on a slowly rotating planet which had no continents, just water, the tide would be highest along the line joining the centers. I mean, let's say the Earth had no continents and just water. And moon is exactly over it, tide will be exactly below the moon. But since we have continents, there is friction happening with the water, friction of the land and water. So big, and the Earth is of course rotating. So these are the reasons why you get this lag of around 12 minutes. Or tide happens 12 minutes before the moon comes over. Okay, so these are some of the reasons.
A large number.
Just 12 minutes.
Because of continents.
Because of continents, because of rotation, there is friction happening between water. The water is going to, bang over the shores and it's sloshing around. And hence, these things will happen.
See, usually friction slows you down. Why is it pushing you ahead? It's another thing that you should think about.
Earth's rotation is pushing the water ahead.
It is not that simple. It's a very, very complex phenomena.
Can you talk a bit about it? Can you talk a little bit about it?
I don't know.
No. So, I think part of it must be because of the rotation of the Earth. See, when the Earth is rotating, the friction causes these things to move together. Right? So, it's not like the Earth and the water, they don't have like a frictionless kind of a surface. Right? So, the rapid rotation of the Earth means that it is also taking the tides along with it. And I think that must be the reason why this is happening. Yeah. So that is my understanding. I may be wrong because we also started to think about this just recently. But I think.
But we'll definitely come up with a good write-up and explanation for all these things in a simpler way.
And see, it's not like it is not like a large amount of lag. It's just a 12-minute lag. So 12 minutes in the sky, the moon is not going to move a lot.
Right.
It moves by a bit, but not.
Okay. Okay, we saw tides. We saw types of tides. We tried to, I guess.
Is there any connection between rise of water level in night and there is a falling water level in the daytime? Is there any connection between these?
No, so tides happen at different times of the day. Right? Like for instance, on Purnima, I will explain this to you in a bit. The last slide is about this. But I think I will explain it during that time. So there are only a couple of slides, so please bear with me. What are the effects of these tidal forces? What are the dramatic effects that can happen because of this tide? So one of the effects is, again you have to take it as a fact, this can be proved rigorously, that because of tides, which are basically dissipative forces, there's some dissipation of energy that is happening because of this friction, etc., etc. The moon is moving away from Earth slowly. The rotation of Earth is slowing down. The moon is moving away from Earth. And can you tell me what will happen if the moon moves away? Moon moves like 3.8 centimeters per year. It is written there. There will be no total solar eclipse. We won't see the diamond ring, etc., etc. What we will see is an annular eclipse probably. Because now the moon has moved away from me, so the angular size of the moon that is subtended is smaller as compared to that of sun, and hence I will see an annular eclipse and not a total eclipse. So total eclipse is a temporal phenomena. Eventually, after 2000 years, maybe.
Not 1,000 years. It will take a lot.
Yeah, millions.
Centimeters.
अच्छी बात.
नहीं मतलब हम जिंदा रहेंगे तब तक ना.
Yes. 1000 साल.
No, 1000. It is going to be like 3.8 centimeter times 1000. Right?
Right. That is
3000 centimeters.
3000.
30 meters.
30 meters. That is not going to affect. So million years, maybe millions of years. हम नहीं रहेंगे. आपका पता नहीं मुझे अब नहीं रहेंगे.
I will be able to see the total solar
eclipse. We will be able to see. We are in lucky times. We will be able to see. We are like really lucky. We have a pole star. We will be seeing total solar eclipse. And yeah, you will listen. This is an advertisement for the evening sky shows. We have a pole star, which is right at the axis of rotation of the Earth, in the direction of axis of the Earth. And also, you will see moon today, probably through telescope. So, no filter required for moon. Whoever was saying you should see moon through a telescope for a very small time, because you will realize kya ho raha hai. Okay, the other thing is, because of these tidal forces, imagine that there is a ball, or there is some huge planet, and a small rock or something, like an elongated object, comes very near to it. The force at this side and this side of that object will be so high that it may break the object. The object will fall apart, like break into pieces. This happens at a particular distance called as the Roche limit, okay, which is around, for regular planets, rocky, bound by just gravity, etc. It's around 2.5 times the radius of that planet. Okay, so point is, it might happen in certain special cases that if a body comes very near to another massive body, it may just break into pieces. And it is said that there is a chance that probably, I wrote Saturn, the spelling wrong. This is Saturn, by the way. This is not star. It is Saturn. So Saturn's rings are probably formed this way. This is one of the things.
Then this will be the spelling.
Huh? Then this could be. Okay. So tidal forces, you see how dramatic the effects could be. The more complex the explanation is, the effects are also nice and dramatic. No solar eclipse after New Year. Maybe breaking apart of satellites, etc. All right. Now there are various misconceptions. So we have been talking about only tides in seas, right? But do tides occur in other bodies of water? We'll go to the lower one first. Lakes and rivers. Yes, ma'am.
Friction is more.
We saw now it is depend on the mass and the distance. So the mass of the river and the other water resources is less than the ocean and sea. So quite possible it is not happening.
No, that mass was not mass of the.
No, mass of water. It
That was
a mass of
mass.
body.
You have to show that equation.
Have you seen? Have you observed any tides in rivers ever?
What is rivers of river tide? Flood happened.
Blood is different, right? Tide is different.
Flood is different.
I know.
No, it is because that overall monsoon water is also more.
Is it because the ocean sea water connects with the river water?
See, it is not happening that suddenly the ocean is rising and there is a vacuum created somewhere. Right? Water from some place accumulates at one point and abolishes. So for small bodies, you can't suddenly have a vacuum underneath and something like that. Right? So even if there are tidal forces acting, that will be very small and negligible. But Great Lakes, like very huge lakes, especially the Great Lakes in America, which are huge water bodies and interconnected internally, or I don't know how, but they are interconnected. In such huge lakes, you do see tides. Not in very small single isolated.
Size is still small. I mean, the breeze and the waves cause even more.
The breeze that will cause the waves, okay, those will be much more than the actual height of tides in this.
Even in this Great.
Even in the Great Lakes. I mean, those tides will be not as dramatic as the sea tides.
But I mean, this is the reason why that kind of picture that is usually shown in the textbooks is a bit misleading. You know, when you are only seeing the front portion and the back portion, because you will think that okay, there is always a force which is acting there, right? And you are completely ignoring gravity of the Earth. So Earth is of course going to pull everything down. And that's the reason why it happens only for these large bodies. Otherwise,
it happens.
If it would have been just that for those forces, tidal forces, without the Earth's gravity, then even in small objects you should have seen things bulge up and stuff. But that does not happen. That is because of these tangential forces. You need a big body.
Obviously, small rivers or lakes में नहीं होना चाहिए.
No, it doesn't. Because it's just not even covering enough of the.
वो counter resultant forces बोला है वो होगा ही नहीं.
Exactly, forces, but
there will be forces, but those resultant forces, the tangential forces that we have.
We don't have enough of them.
What happens in human bodies? लोग बोलते हैं human body has a lot of water. Tide आना चाहिए. Blood pressure.
Our body pressure is a greater value than the atmospheric pressure.
Body pressure is
a greater magnitude than the atmospheric pressure.
Body pressure is
you would have exploded, imploded, pushed away. Something would have happened. So this is a myth. Nothing true in this. They're not affected by any of this. There's no tides happening in the body. Suddenly, lot of blood going in my brain, and I am solving all the equation science and solving it. As a new. Okay, now after knowing few things about tides and try to explain, I mean, we try to do justice to it. Now we have a small thing to tell you. See, tides happen because of moon that we establish. I mean, the significant contributing factor is moon. Now, when the moon is overhead, you will see a tide. There will be a lag of 12 minutes. That also we have seen. But how do I predict the time of tide? I want to get into this fort, right? Sindhu fort. Okay. So how do I predict the rate of tide? So there is an empirical observation, empirical way of finding tide. Time of tide. When will the tide occur? And there was a survey done. There was a study done at HBCSE by Professor Aniket Sule and Sai, who is here. And they met various people all across Maharashtra and some people in Ladakh, some people in the coastal areas. Right? They wanted to know what is the traditional astronomy the fishermen or the people staying there, the local people, the native people, the indigenous people, they know. And while we were discussing this, Sai told me that the fishermen, they can predict the height of tide just by knowing one fact, that on Ekadashi, the tide will happen at a particular time. If I know this one fact, I can do it. I've just quietly ignored this first part, but I will come to it.
The Ekadashi is clear, right? To everyone, you know what Ekadashi is.
So I will quickly tell you what Tithi is or Ekadashi is, why I said this. So we have phases of moon. Right? We say Purnima is the full moon. Then the moon decreases in size. There are 15 days. The moon becomes
Zero.
Amavasya. So first day is Ekadashi, second day is Dwadashi, Trayadashi, Chaturdashi, Pratipada, Dvitiya, Tritiya, Chaturthi, Panchami, Shashti. Very sorry. Saptami, Ashtami, Navami, Dashmi, then Ekadashi, Dwadashi, Trayadashi. Basically, Ekadashi is 11th day, 12th day, 13th day, 14th day, and 15th day. Okay, thank you. Very sorry for this confusion. So these are the phases. These are called tithis. You all know that. As soon as I know tithi, I can easily tell you what is the time the tide will occur. Like for instance, let's say today is, what is today? What is the tithi today? Saptami. Tomorrow is Ashtami. Today is Saptami. You will see almost half moon days. So 7 8 are 56. So around 6 p.m. 5:36 p.m. during that time, you should have high tide. Now once I know what is the high tide time, I can calculate what will be the low tide. After some time, after 6 hours, I will have low tide.
And again 6 hours next time.
Next high tide. Okay, so this is one way of calculating. But how do we come to this? How do the fishermen know? They did not calculate this 0.8 over there. This is an empirical number that we get. How do the fishermen know? They say that, okay, they remember one fact. On Ekadashi, that is 11th day, the tide will occur around 9 p.m. Right?
Every time.
Or 9 a.m. Every Ekadashi. Now, tomorrow you will learn from, I mean, you already know, but maybe I will teach you tomorrow the phases of moon. So every day, the moon rises 50 minutes late. So if today is Ekadashi, okay, the tide will happen at 9 p.m. Tomorrow is Dwadashi, the tide will happen after 50 minutes.
What about the
So on.
12-minute delay where it is?
The 12-minute delay, that it doesn't matter actually in this calculation, because I just want approximate time of the day. Is it 3 p.m. or is it 5 p.m. or is it 7 p.m.? When will I have high tide? That is all I need. So for this purpose, I can as well assume that the moon is overhead when the tide is happening. Okay. So tell me, so if I may ask, when will the tide occur on let's say Purnima?
12.
12 noon? When does the moon rise on the day of Purnima?
12-20.
Okay, when does the moon rise on the day of Purnima?
It's around 8.
What is the phase on Purnima?
Full
moon. Right? Full moon. Come on. What are you? So full moon. So where is sun? If I am Earth, where is sun? On one side. Let's say here is sun. Where is moon? Here. Right? And I am Earth. I am rotating like this. Can't do that fully. Maybe after a few million years. But here is moon. So the moon rises when the sun is setting, right? And then the moon comes overhead when the sun is below. Say, no. I am here. The moon is here. This is Purnima time, correct? And let's say for me the sun is setting. This nose is an observer. There is a man standing here. He sees here sun is setting. He sees here the moon is rising. So when should the high tide happen?
At the sunset time.
At the
Sunset time.
The moon is on the horizon at the sunset. When the sun is setting, the moon is on the eastern horizon rising. Correct? It has to come overhead, and then this person will have height.
So how much time will it take?
6 hours.
6 hours. So let's say the sunset happens at 6 p.m. 6 घंटे बाद I will have. Now is that thing clear, man? The night tides are high and the day tides are low. The thing which you had asked. So after Purnima, the moon will rise 50 minutes late. Let's say around 7 p.m. and the high tide will be around 1 a.m. And this goes on. The delay goes on every day. And we complete a full cycle. So I could finally manage to get into Sindhudur, calculating what is the time of tide today. Actually, I should leave now because it is 7th, right? 7th Tithi. Saptami hai. So 7 8 is 56. So 5:30 baje अगर tide होगा, I have just 2 hours left. I should quickly run. So what did we see in this? We tried to see what tides are. The periodic changes in the water levels in the sea arise because of gravitational force which is distance dependent. Here the tidal force is d cube dependent, not d square, and hence the moon's effect is more than that of sun. High tides are on diametrically opposite side. It doesn't happen only on one side, there is high tide on the other side, and we saw the reason. We tried to explain you why this is happening and how the diagrams in the textbooks generally can mislead you and what you should be careful about. Tidal forces are dissipative forces. I mean, because of the tidal forces, you have moon moving away and no eclipses. We tried to calculate. We also saw that because of tidal forces, there can be breaking up of bodies, and probably you will get rings of Saturn because of tidal forces. We try to see how the moon is not exactly overhead, but there's a difference of 12 minutes. So tide precedes the moon. Tide aane ke baad, 12 minutes ke baad, moon will be overhead. And then, lastly, we saw how I will calculate the time when tide will occur just by knowing what tithi it is. Tithi is basically what phase of moon. So it is the number of days since the new moon. New moon is considered 0, 1, 2, 3, 4. The age of as it is called. Okay, so I think with that I will stop, and there are some questions we'll all try to answer them, or we can discuss this. There was a question with comment.
I don't know whether I have missed it. The tidal force of Earth on Moon, you say. Okay, and that time we did not explore that thing much. Was it explored?
I tried to, but maybe I quickly pass through that. So if I try to calculate the tidal force due to moon on Earth, I have this value. But remember, the Earth is much more massive. And now, if I calculate there is a factor, right? The IUCAA factor. If I calculate what is the tidal force on moon due to Earth and calculate that value using this formula, I get there is a factor of 22. So tidal force on Earth because of moon is 22 times less, or tidal force on moon because of Earth is 22 times more than that on Earth because of. So that's it. I mean, the formula just gives me.
I mean, what is that impact? What is its impact on moon?
There is, yeah, I mean, from what I know, and I should have said this before, tidal forces do affect the surface of Earth. The surface of Earth is also slightly lifted because of tidal forces, very slightly. The effect is not as dramatic as that on water bodies. As far as I know about the moon, I don't know if it has a molten core or anything.
No, you don't need a molten core. Even the shape of the moon is actually distorted.
Because of this.
Yes. And because it has a slightly elongated, I mean, it becomes slightly elongated because of exactly this reason, because of these tidal forces. And these tidal forces are the reason why, as we were enacting, the face of the moon that you see from the Earth is always the same. So it was not always the case that the moon was also rotating quite fast, but because of the effects of these tidal forces and this elongation, now it is tidally locked, which means that the rotation period and the revolution period has become the same. So it is because of tidal forces, so just like the Saturn rings you found and so on, even the tidal forces are responsible for making sure that you only see one face of it. And this is not only true in in the case of our moon, even on other planets. I think Jupiter's.
There are certain Jupiter moons which are tidally locked. So you will read this word tidally locked. So that is what it means.
Yeah. So
one more thing.
Yes.
So tidal force is something that we are evaluating on basis of that centrifugal force and the gravitational force evaluation, right? So it is impact of gravitational force and revolutionary motion.
Yes.
So actually it is impact of gravitational force only.
Yes.
But still it is called tidal force because of its varying nature.
It is the difference between the force at the center
and at the periphery,
and at this location or at any other location. So that's why it's because you have to equate how fast is this thing accelerating, right? How fast is this thing accelerating? That gives basically what the centrifugal force will be. That is what is the centripetal force required to keep it in circular motion. There's another way to look at it. And the gravitational force at this point. That is what causes the fight.
So it means
balance.
For the gaseous planets, I mean those who are not in rocky.
Right.
So for them this must be.
Yeah. So that causes this kind of bulging around. Yes.
So
see, the reason why the Earth goes around with the same acceleration, this point and this point, all of them are going with the same acceleration. But when you are a gas, then it can become complicated. So because
there are actually
there will be but there will be still forces which will hold this whole thing together, right? So the Earth is held together by all these electromagnetic forces that exist, which are much stronger than ground.
So that means the gaseous planets, are they changing the shapes when the tides are there?
To some extent.
Yes, they should be. Yes. Yeah. The gaseous things, they will have this kind of tidal effects. Yes.
There are actually stars which can have, in binary, two stars going around each other. So there will be tides. Right? They can have ellipsoid. So sometimes you will see a smaller star, sometimes you will see an ellipse. So all these funny things happen.
Okay, so there's one more question.
Is there any connection with this?
It has to do with the rotation of Earth. So that's why you have this flattening at the poles and bulging at the equator. That is what you are asking, right?
So there was another interesting question that Asmita asked me. So then, does the size of the tide depend upon the latitude or not? Right? Because you saw like how the things were bunched, right, in a different manner. So what do you think? I think we should ask, right? So, in the spirit of asking, what do you think? Will it be dependent upon the latitude or not? Is it a complicated problem? How can we think about it?
It will depend.
It will, no? Equator, it will be more, right?
Equator, it will be more.
Nearby. Nearby.
Okay, remember what is the plane of the rotation of moon?
So
is it along the equator?
No,
No.
no. 5 degrees.
It is 5 degree tilted along what? Along the equator?
Along the plane of rotation.
Along the
Along the plane
orbital
of Earth's
rotation.
Earth's revolution around the sun. Right? So it will be a complicated function of the latitude because the Earth keeps on moving. And once in a while, this 5 degree, I mean, there is a 23 degree tilt to the axis and then a 5 degree tilt to this. So it's not.
You have sun Earth plane, then you have tilt of Earth, and then you have a moon going around, which is tilted to this plane at an angle of 5 degrees. So you have to take all these factors into consideration one by one.
Yeah.
And then try to.
But I mean, this is good because you know what, we face these kind of complicated problems as astrophysicists all the time. But what you have to learn is you have to break down the problem into smaller and smaller and smaller chunks that you can think about. And then solve these smaller problems. And then automatically you will build up to the understanding of the bigger problem. And this is every time we have to do this. That you have to start from small things that you understand and then think about it.
I also answer this question observation. Records of tide height.
There are records of tide.
I mean, there are also other problems. I mean, here we consider that the Earth is like really smooth and no continents and so on. There are places where these tides can get even more complicated. Like it won't be exactly like when the moon is overhead and so on, because of the specific geographic features. So that is another thing that you have to be a little bit.
Okay, so I think Raj is here, and the main thing is that we have to leave. So thank you so much. And if you have questions, etc., you can and then they can share, and then we will discuss. And probably through these questions, we will form some Olympiad problems. Okay, thank you. Thanks a lot. I hope we could do some justice to this.
You are the in charge for Astronomy Olympiads.
No, I am one of the members. Professor Sule is the in charge of Astronomy Olympiad in India. He's the academic coordinator of that. I work with him. Thank you. Thanks a lot.
Okay, when is sick?
So you won't be there in group photo?
No. Unfortunately no.
So before he goes, can we have?
Can we just take one photo?
Exactly.
Can you take one photo just from here so that Saeed is also here? Here you take one because otherwise it will take time to. She's here tomorrow. Yeah.
Mention one back.
Make sure
we had a nice problem on height of tide. A problem in which students used to calculate what time will the tides be using graphs, etc. You can look at the astronomy Olympiad papers. They are all on our website. Couple of years ago, I think 2019. The website is Homi Baba Center for Science Education, HBCSE. Okay, just search for HBCSE TIFR and E.
Homi Baba Center for Science Education, HBCSE.
And if you just search for Olympiads, you will find all these nice, interesting problems which you can ask students to do.
Okay, can we just quickly go outside? We'll take a photo and then come in again. Is that okay? No, but tea break is there. But quickly, okay, because we don't have time. Please. Just picture. Okay, quickly, okay.
Hey, Jiten, you can do a photo now. Can you come? हाँ वो सेम जगह बाहर वो तो enough coming for photo. That's okay, but you are a country, so like everyone else.
Sure.
So are you interested in doing?
फक्त plan बघायचे चालू आहे की नाही आपण. इथं इथे झाले पाच करतो. तिथे काम करायचं. हमारा टाइम नहीं मेरे को शौक लगा त्याच्यामधून पाईपांचा वायर उठताली न्यूट्रलला मेन आहे तिथं बेस न्यूट्रल उठताना ठीक आहे नाही तर वरनं एक पट्टी मारायची आतमधनं आणि बॅकडोर एक मारून केबल वायर आता संध्याकाळी तर उद्या सकाळी तिथे या सकाळी
And what I thought, like I have the rice with them, the rice with the curd and everything. Very different. I'm feeling the other color. Later, I came to make it a honey cake. Yeah, because it's a Bollywood. Food.
Okay, while we're taking seats, I'll give you some form. So for those of you who have taken some auto, bus, taxi today in Pune, you can fill this form. Also, so give it to us tomorrow along with the receipts. So they need receipts and these things filled.
Ma'am, outside? Ma'am, we can.
Yeah, you give. So yeah, we have said that we can give up to 200 per person.
Ma'am, we can show you the screenshot. Screenshots.
Very complicated.
Ma'am, screenshot is okay because I sent the screen.
We can from the Tamil. Different. Yeah.
May I just have one? But I'll be able to give you the screenshot.
Screenshot. I don't know if that will work. This is in GPay you did for the auto and stuff, right?
Take a print of that. Print like
that. You just take some because these administrative people.
Just tomorrow, what will we do then? Today I can take the printout, but 2 days, no? Multiplied by 2. See. So one time come, it's okay, coming, going.
Right. If you need printout today, I can do a printout for you. If you email me.
I have sent you the.
Oh, that
for
thing, WhatsApp. No, okay, send me an email because.
Email, I'll mail you both the. Okay, today while going, so it will be 2 days. No?
Sorry, so.
Then should I take the form?
Regarding the reimbursement, what they do is whatever you use today and tomorrow's receipts, and then, today's morning, evening, and then tomorrow morning's receipts you give. The last they will just reimburse based on the average or something.
Okay.
Okay, yeah.
So then I'll be sending you all on the
On
email.
Same form we'll be using for tomorrow.
Same form. Okay. Same form.
Hello.
Okay, so next we will hear about the solar system. We will hear about different things like planets and so on in the solar system. Prasad Adekar is a scientific officer here and works at IUCAA and works in public outreach and education.
Yes. Okay, so yeah, good afternoon, everyone. Yeah. So I'm circulating a few kind of on worksheet, you can say. But what I would suggest is that don't keep on just going solving, because it is not intended that we're intending to think about the students. Okay, because as a teachers you will be able to solve it. We will go step by step with this. Idea here is not to talk about the planets, all the planets, this, and this. Okay, because that information is available. What we are going to talk is basically about some of the things, survey which has been conducted, and what are the things we have found, shortcomings which we have found out, and we'll try to address that. Okay, in that way we are going to understand this, because we have 30 minutes, and obviously talking about planets, their features, all these things. As such, it is there in either in textbooks or it is available on the internet. So, also if you really want to talk, you cannot have a 30 minutes lecture for that. Okay, so I hope everyone gets this. Okay, so we'll go step by step. I always struggle with handling this stuff. Okay, please do not go and solve that worksheet.
Not to solve.
Not to solve it right now. Okay, we'll go step by step. Okay, so let me see if this is working properly.
There are a few here.
Is there anyone who did not get a cake?
They're fine. Okay.
Okay, fine. I guess I have to use this. Fine. Ready, everyone? I think you're filling up something.
No, fill your DA form later. And you can have it at home. Yes.
Both are on both things later.
Yes. You can take your time and fill up that, because there is enough information to fill in here.
One more one. Later, tomorrow.
No, you want one?
One more one. Ah.
We'll have enough time to follow this.
Yeah.
So the TA form is not required by you guys, I guess. Yes. Right. Yeah. Okay. Okay. Yeah. Fine. Ready, everyone? Now.
Yes.
Perfect. Great. Okay. So, what we are thinking here. See now here you can see there are few things here, and we are obviously talking about the solar system. This is something. Even this is just technical use. Oh. Okay. Fine. Right now. Okay. Yeah, fine. So, so what I'm doing this you can see the first question. As such, first question is just to write the solar system objects in one single line. Okay, I hope you can write it down. Till then, also you can think about the next question. So, next question is basically you have to figure out what are the other objects, given that you have these two things. Okay. So these are the two things you are given. You have to figure out what are the other objects in the solar system. Everything is there to scale. I will tell you why we are doing this as we go ahead. It might look a bit simple for you, but yes, we'll try it out. Okay, so fine. You can write it down there, think about it, and then tell me the answer also. Yeah. Okay, everything is there to scale. Okay, this is Earth and Moon. What are the remaining planets you can figure out here? Yeah, it is second question. Yeah.
Any guesses?
Yes.
That one might be the Jupiter.
Which one? This one? You're saying? Okay, just a second.
Earth is it.
This one is Jupiter?
No.
It is not possible, right? Jupiter is
Venus.
Yeah. This is, you are saying Venus. Okay, fine. How many are Venus?
Mars.
Which one? This one?
Venus.
Okay, this one you're fixed on Venus? Okay, then Mars?
Mercury.
This is Mercury, okay? You're seeing, okay, fine. So let us check this. Okay, this is Venus, correct? Because why do we know it is Venus? Exactly, almost same size as Earth, fine. And by giving this idea, we know that other two planets which are smaller planets as such. So fine. So we have, okay, this is Mars and this is Mercury. Exactly. Okay, great. Fine. So we have found this one. Fine. So let us go for this next question. Is working? Yeah, now it is working. Okay, so right now you have these things, and obviously you can see the third question. What you have to figure out is this. So now again, remember everything is there to scale up. So yeah, and you have options also right now. First one is Sun, you are saying, okay, this one is Sun. Fine. Are you sure with this?
Last one? No.
Last one is Pluto. Yeah. Okay. Okay, fine.
There's no sun.
The sun is not possible.
Okay. So if you see, I think the simple idea can go is that if you say this is Sun, then you have to find out a planet which is just huge, almost like Sun. If you see, it's very close, right? Yeah.
This is Earth only first. First one is Earth.
Okay, some are still fixed.
First one is Earth. No, it's Earth.
Okay, fine.
First one is Earth.
I think
Next.
I think we have cancelled out Sun now because
So he's confusing you. Look at the number of circles. Then look at the number of options you have.
Okay. You have 6 options and you have 5 circles.
Earth.
Okay.
Array about science
Okay. I guess
Last one is split.
fine. Okay, it's low. It is sounding like a class, literally a class now. Okay, hang on. Okay. So how many are saying? See, firstly, I think we have gone a step ahead from this sun, but still, how many of you are still saying this is sun?
No.
Just raise your hand.
No.
Okay. Still there are enough. Okay. And how many of you are saying this is Earth? Okay, this is Earth. You are saying others. Okay. No opinions today. Evening. Okay, fine. So why are you saying this is Earth?
Because the other options available are smaller than other planets are smaller than Earth.
Planet. Sun is a star.
Okay.
It's not different between the figures.
Okay, no difference between any other idea?
All the other 4 planets are smaller than Earth.
They are smaller than Earth.
Yeah.
Okay, fine. So yes. Anything else? Why have you eliminated this sun in case? I'm just asking the question a different way now.
There's no Jupiter.
I mean, there is no Jupiter. Obviously, it is not because there is no option.
Consider that as sun. The next proportion is down.
Even figures are
Yeah,
figures only.
correct. See, if you consider this as sun, okay, you can see there is another huge thing here. Okay, so there is. I mean, this cannot be one Jupiter now. Okay, because I mean this looks huge. So this is now, let's say, another thing which could be Earth now. Okay, fine. This is Earth. Then
the next big is Mars.
this is Mars. Okay, then
Then Moon, Mercury, Moon, and Pluto.
okay. What you have eliminated now? You have eliminated Earth and Mars. Fine. Then
Mercury, Moon, Pluto.
which is Mercury in this?
First one.
Second one is Mercury.
Then Moon, and then Pluto.
And Pluto. Okay. Let's see. I hope if this starts. Oh, this has also started working. Okay. So this is Mercury, Earth, Mars, Moon, and Pluto. Okay, great. See, what I was trying to do is that these were simple things as such. Okay, we know about the planets from so long. Okay, we have studied about it, but still you can see there is a bit confusion. Fine. So what happened? Okay, then next. Okay, so now this was used as a part of survey. So you can see arrange the objects below from smallest to large. I think it went in the morning thing also. Okay, but still. We have to see something else though.
Sun, Jupiter, Earth, Moon.
Smallest to largest.
Moon, Earth, Jupiter, Sun.
Then Moon, then Earth, Jupiter and Sun. Okay. So if this is given to the students, what do you think? How many of, let's say there are 100 students. Okay, you will be teaching a lot of students as such. If there are 100 students, how many of you think will give this answer as correct? You are teaching those students, right? So how many of you think out of 100 will give this answer as correct? 90% it should be.
Yes.
90 other might make some mistake, some other mistake, but what we have seen. Yeah. See? Okay, so this is a nationwide survey as such. So you can see.
This absent-minded.
There are too many people to say absent-minded, right? Okay, because 64%, remaining a large chunk as such, right? Okay.
See, I mean, many of these were also Pune-based schools. Okay, so it's not like we have done. Many of these schools are Pune-based, rural areas, urban areas, different boards. We have tried to do this in different kinds of contexts. This is what we do.
Okay.
On average, this is the, and I think it is consistent among the states as well.
Which grade students are these? Which grade students are these?
Ninth grade.
It's a class 9 students. May I present a point?
Yes, sure.
During the pandemic, students have lost their patience to read.
That is true. That is true. Yeah.
They do not read it carefully. They do not read it carefully. They are always hurrying, jumping towards the solution.
And astronomy is not in their curriculum regular.
So for Cambridge,
it just happens.
This is general knowledge.
This
is basic GK.
Something like this which is always it depends upon which grade, etc. And I agree, pandemic could have played a role. We cannot discuss.
So this have you built it only
few months ago. So this year.
Okay, so you can see this is the thing because see the previous question was at least slightly difficult, I guess. Okay, but I made it for you people. But this was a bit easier one. Okay, so this is the same. So what we have to, I think, the idea is to present that you all have to think what could be done in these cases. Okay, because you can see there is just 65% people have, almost 65% people have only given it correct. So let us go ahead a bit and then. Okay, so now what happens at times, we can see this system, this picture. Sometimes on internet or in the textbook, we have such kind of picture. So what do you think is a mistake? See, okay, fine. What do you think is a mistake in this? Okay, one argument is always that, you know, you want to present it to the students. Okay, but still, let us try to find out what could be a mistake in this. I mean, you have seen now.
So the sizes and distance are not realistic.
Yeah, distance it will be difficult to really scale down, but you can see the sizes, right? At least the size, you can see the Mercury here.
Big.
Okay, and see the Mars.
Oh.
Okay, see, huge. Again, a difference is there. Fine. Moon, Pluto is huge in this. Okay, so these are the things. Okay, sometimes in textbook we cannot change few things because we cannot write it. Okay, but at least from our side we can at least show them the correct picture. Fine. So next, this is from the our CBSE board text. You can see also here. Okay, what could be your argument here? Is this a thing, proper thing to show to the students? Some part of it.
Uranus is huge.
The Mercury and Venus is almost in the same order.
No, they're not actually, but yeah, looks like, you know, at first glance it looks like. Okay, Sun is tiny again. Okay, yeah, it is difficult to scale everything with the Sun though, but still. Okay, so now this is one of the things. Okay, so now if you actually scale them, things become difficult because you can see it's gone. So we have to also think like what picture to show to the students because it should not be so tiny that we are not able to even find out things. Okay, because then it will be difficult. So I think this could be slightly better than that. Okay, a picture slightly better than that. So if we cannot change the textbook, at least we can show something. You know, we have these digital boards, so we can at least show this, and we can take the things ahead. You can make some worksheet like this to test them. Okay, so next we'll go for. Okay, fine. This question you have here. Okay, I hope it is asked also, right? You can just write it down. This you are taking worksheet. You are taking.
This they did today.
Yes. Okay. Did in the morning. Okay. So fine. But still, the question would be: how many of you think this should be like answered correctly by the students? Like again, let us take 100.
50.
50%.
Even less than.
Less than 50. Is this answer based on your previous like the previous graph?
No.
No. Okay. Like. Okay. What others think? How many of you, like out of 100, how many students should give this answer as correct?
100%.
100%, okay. That 100% not realistic in any case because you know even sometimes easy questions students make mistakes.
They will confuse between Neptune and.
They will confuse between Neptune and
Sun.
Oh, they will confuse Neptune and Sun.
Moon.
Can they confuse stars and sun? Star and sun?
No. Sun is the closest star. They know this.
Okay.
They know this.
They will forget to read from the.
From the
yeah. That does happen in exam, you
They
know.
will write sun and all that in a sequence. They will not write according to her.
Yeah, exam situation we can say that they can you know really miss it.
No, but yeah, it's good that you are thinking about these things. That's exactly what we have to think about when we see the answer.
We want to know from you guys what
How
might
is
be
it
the
possible?
reasons.
Nowadays the situation is bad.
For them, it is always easy to arrange from sun.
From sun to outwards. Okay.
It is always because we also teach in that way.
So let's see. What were the results?
Okay. So yeah, fine. So results were okay.
That's the reason.
Okay, so look at that, right? They have not thought that they were starting from the sun. If they would have thought You're starting from the sun, the first answer would be sun.
You started.
That is not the case.
You can see nowhere there is sun in the beginning.
Your options only were, this was choose the option, right?
Yeah, there were many other options.
You have to.
So this one, just write your own answer. No, it's not a multiple choice question. So there are many other combinations. We are showing the top 4.
Okay.
You can see, you can add this up and it will not go to 100, so you can see. Okay, so they have to just, and you can see it is, this is really pretty bad. Yes. Okay. But okay, let's see here. Okay, so let us see what does this thing show. Okay, school which is resource rich. Okay, so maybe they may have a lot of facilities. Let's say digital board and everything, other things. Okay, so a resource rich and resource poor school. We can see the difference in the performance again. This is again 49. Do you think it is still good, right? Is it still good?
No.
No, I think it is not still not good, right? 49 and this is so, I think. See, we have to work on this because we have showing basically what we are, the survey is showing us. It can be from anywhere now, okay? So here, and again, slightly interesting here, male and female students. You can see for the males. Why could this be the case? Any idea?
They have a top. They have a peer pressure. All the opponents is reflecting in the
Male have peer pressure to
no,
perform.
peer pressure in the sense they have a top at least.
Okay, so yours.
They don't have that much exposure in the field and.
Okay, what other thing is?
When was the survey done?
Survey
A few months ago.
A few months ago.
Yeah.
Very recent.
This is pretty recent. I think pandemic was quite over, right?
Yeah. This year only.
It's difficult.
So total
to
data
know
is 1,000 students?
Or
The whole data set is 2,000 students. Slightly more than 2,000.
How many?
No, we went.
There was a significant number. It was roughly equal. In fact, females were
Females are a bit more. About 1,200 females, 800 males kind of. We went to each school, gave them paper copies. We stood there. They needed. They took it. No, it's not online.
no, there's not, they.
So another thing that, I mean, so let's look at these figures, right? If you take the top, can you go back once, right? Let's forget about this. Let's go here, right? So if you look, Moon, Sun, and Neptune, they know the order between these three. Because the top 4, M, S, and N, they always fall in the same place. Look at what stars. They don't really understand where stars are.
Yeah. The stars are in 4th place, 3rd place, 2nd place, 1st place.
So this is the thing that you have to think about, right? As to what is going on. Like one of my theories is they always hear that Neptune is the farthest planet.
Exactly. And stars we can
and that just keeps getting stuck.
And stars we can see in the night sky.
So I don't know whether that is the only reason. You can see all of that some Neptune you cannot see.
And stars, that's what I'm saying.
Yeah. Stars practically they can see regularly, so they think that okay, they are near.
Yeah, that is possible.
Yeah.
But see, these are the kind of problems that are there.
We need to address.
Planet around them.
Yeah, so that's true. So they are thinking that it is the farthest, right? So that's fine. Okay, but I think stars we can see. I think Moon also, and Moon and stars we can see. So I think they will maybe this and this option will be there, right?
But at least Moon they have chosen.
You want to say something?
No, I will just say that in the books there is definition of light year, right?
Yes.
So it seems like they are not understanding that stars are light years away and light year is how big, how far, etc. This they are not really comprehending very well.
The tendency to watch that moon immediately is seen, and then suns, and then
Study reflects all the.
and we talk about
Well, of
planets
course.
close by in a system.
It's not
and we always
it's not
tell
one
that
person
sun is
doing
very
something.
far.
It's a cumulative.
So you know that
So that's why we
Neptune
wanted to
sun is
present it to you, just so that you know what is going on.
They are not able to guess those two distances.
Neptune and Sun, but they have done Neptune and Sun correctly everywhere. See, they first put Sun, then put Neptune.
Okay. It's the location of stars which is always confusing. Many of them.
We will work on this.
You know what you have to really talk about with the students. Right. So, okay, fine. So let us, we'll try to, one exercise what we can do is, which is on the next page now. Okay, we'll try to make a scaled model. Okay, I think with some data. I know. I know surely will be doing that part also, but right now I'm just talking with the numbers. That's fine. Okay. Okay, fine. So what we will do is right now we will do both the things. We'll try to scale the sizes of it and the distance of it, and we can, if we can find out if we can fit it on one page, because whenever we are with the students, okay, with least amount of resources, if you could really do the activity, it becomes easier, because you might have the idea that if you tell students to bring something next day, okay, even if you have a good class, out of 40, okay, as per CBSE, out of 40, at least 5 people will not bring, even if you are a very good class. Okay, and if you tell them too many things, then you can see what would happen. So one paper can be helpful. So right now here you can see distance is given astronomical units in astronomical units. So you can see how much is 1 astronomical units here. One more thing which students really, what I have seen is that if you give them big numbers, okay, they tend to many of them tend to not touch that topic then. Okay, so that also happens most of the times in gravitation chapter. Because that constant is big and say like, okay, thank you, not to do this calculation now. So yeah, so here you can see what can you do? You have to do round off. See what we have to do. We don't want very exact. See, few are 10 kilometers here and there does not matter here, because distances are huge. Okay, and then what you do is you can scale the distance in centimeters. So you can see what you can think about if you want to fit this on one page. A4 page. Yes, one A4 page. Okay, I will be giving you. You can do this. Okay.
Yeah, this is maybe some kind of a homework. Okay.
You can see it is written there, homework. So just pretend to be students.
We love that.
Okay, your A4 size paper is by length it is close to 30 centimeters. Okay.
How you are giving this?
I mean, I was just saying the length. So yes.
Oh, we will do it in the next session.
We'll be collecting this homework tomorrow, by the way. So it's not that.
She's saying that she will do it in the next session.
No, not precisely. They homework, but how to show it to the kids,
How to show it to the kids.
Yeah.
These are just black papers. Just black. Just pass it.
Okay, so what have you decided? Like, how would you scale it?
1 centimeter equal to 180.
Okay, 1 centimeter is a 180, fine. Okay, then you can scale everything, right? So, what is the maximum value you can get?
30.
30. Okay, so you just round it off to 30, right? 30 centimeter, right? So, can this be fit on one single page? A4 size? Closely. Fine, now you can. See, this is what you have to do with the students, because students will do it. Okay, only thing is that we have to just concise it. Has everyone done this? Okay. So your minimum distance will be around 0.4 mm, 0.4 centimeter. Sorry, 0.4 centimeter. Okay, and your maximum is 30 centimeter. You can see there is some information given there about the closest star to us. Center, Proxima Centauri, which is the closest star, and if you try to scale it, you can see the numbers there. Okay, how much it is? If you really want to scale it,
3 into 10 is 7.
yes, 3 into 10 raised to 7 centimeters. So you can understand how far it is. Okay, so well, so and next activity is this. Next activity in the sense you have to do both the things and then you have to try to scale this. Okay, so yeah. So now while doing it with the students, you may not show these numbers because you know what happens with when you show them bigger numbers, they get a bit edgy there. So yeah, or you can just try to round up this also. Simpler looking numbers, you can do that. As I told you, a few 100 kilometers here and there will not matter. Because these are huge distances as such. Okay, so try to scale this. This is diameter, by the way. So you can see 11x here. Jupiter 11x means it is. You can put 11 Earth across this diameter. Okay, you can take one Earth, 11 Earth, and fit across this diameter. So that is what is Jupiter about. Yeah, and there are a few more information about how much is the sun. See, you can, if you take the sun to try to scale it, it will be difficult, right? Because you can see what is the number for the sun.
Yeah, the Earth is the best reference.
Huh?
The Earth is the best reference for us.
Yes. Okay. If sun, you have to fit almost 110 Earth. Okay. Now, if you try to scale everything with the sun,
110 centimeters.
It will be really difficult, right? So we can always do this simple things. But right now, I want to see what you will take on this side, right? Because see, these are diameters, huh? Like if you have to think about the diameter, and you have to do it on that same page. So what will you do?
1 centimeter. Diameter.
Remember, 1 centimeter if you take as the Earth's diameter now. Okay. What is the maximum you have to go?
11.
11. Okay. So you have to make a big circle of. If you go very small, then it will be very tiny. Okay.
Okay, half a centimeter.
If you do not have the protractor or something, you can use something like this. If you do this 1 centimeter, and then just join this.
1 centimeter.
Okay, somewhat like this. If you do not have a protractor. Okay. Compass. Yeah. If you don't have compass, then you just use a scale, put a cross mark, and make a circle. Yeah. Okay. Fine. So what have you decided? We have to fill it up because once you fill this up, then you might think of going ahead.
Half a centimeter.
Half centimeter. You have scale. This Earth has half centimeter, right? So you are making everything half.
Yes.
So 11 will be 5.5. Okay. Fine. So fill this up now. It will be a bit easier because you can see this is 4x. This will be 2 centimeter. Everything will be 2 centimeter. This will be 4.5. Radius what?
Yeah, with respect to radius only that we are going to do.
Either way, diameter, radius, you can choose. Okay. Fine. What I'm asking is that on that next paper which you are given, would you be able to fit everything? Can you?
No.
Will you try? That you have to try. Please don't say no.
Distance and this both thing together we cannot. Separately.
We have to do it together. See, check. Check if you can do it together. If you take it very huge, I can understand that circle might go on the another orbit also.
Because astronomical unit, if you call it as 1 centimeter.
Oh, I understand. You are saying that you. That's not. What we are trying to do here, we are trying to fit it also, but we are also thinking that the size should be known to the students.
What I suggest.
Size ratio, yeah.
What I suggest is horizontally on one page we show the distance.
Can you give the mic? Then it will.
No issue, sir. Just one item. Horizontally let the distances be and vertically tabulate the sizes so that the two things they are not mixing.
Oh, distance and size is the same.
Cannot on 2 different paper you are saying.
On 2 different.
Okay, no problem.
Otherwise it won't make sense. Just like that picture that you have shown. Just size of a grain and then
in a different way with the distance.
Okay, so at least try to make it with the distance. And sizes you can, approximately match them. It should not look like, just like we had the picture there. Okay, it should not look like, the Mars is small, smaller than Mercury. Okay, that you can do. Okay, so on that paper, please write your name and your school or college name and your which subject you teach, and we'll collect it tomorrow. Okay, I wish obviously we will be collecting it. Already decided, right? Okay. 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 So what should I show this? Should I show this? It's very I will place it before. Right. Okay, fine. That's okay. That's okay. Okay. Fine. Okay. So thank you. Yeah. I hope you.
Yeah.
Yeah, that's
Okay,
it.
so Prasad will be around also here, and if you have more questions, please you can ask. But we will have to run for tea now.
Yeah. And we have staff observation and announcement. Staff observation and announcement.
Staff observation will be later on after the next session. Okay.
Okay. This is our WhatsApp channel. Is there? I will WhatsApp channel. Okay. So I will keep it for some time. You can.
IUCAA Science Popularization WhatsApp channel is there, so you can join us.
You have to scan it with the Google scanner.
Okay, so tea time, please.
अच्छा ये कैमरा है हाँ वहाँ का है
तो स्ट्रीमिंग
Please check if you have all these materials with you. And pack your bags, all your pens, your books, your notebooks.
We don't need
Phones, everything in your bag. So that you get the space to work properly. Pipe is in that bag. बड़ी चाहिए तो बड़ी भी है उसमें बड़ी भी है. No, everyone should have one plastic and one rubber ball. Okay. Right. So one ball should be heavier and the other one should be lighter. You can also use stone. Let's see the activity. Any heavy object. If you have scissors, please share it with these people. Don't look at scissors. दो हाथ में नहीं करेगा एक ही अंदर जा. Please check if you and your partner has a scissor. There's at least one scissor, one sellotape between you and your partner. Please select your partner for this session. Please sit in pairs. Scissor is there. One heavy ball, one light ball. And after the session, please submit the scissors, sellotape, and threads back. All the other material you can take home. Is there any pair who does not have a scissor or a sellotape?
Scissor. Sellotape will take.
Is there any pair where both of you have scissors and sellotape? Please give it back. We have some people who don't have scissors and sellotape. There are two scissors. One. Only one? Yeah. Please use in pairs. One.
You want this? Press button.
There are 48 people. We had 24 scissors, 25 scissors. So having okay, everyone has this sheet individually. Everyone has this sheet individually. Yes.
I have taken the extra.
approach number.
And then
Okay, everyone, please sit down. Keep all your mobiles, your notebooks, pens, whatever you were taking notes with, everything in your bag. You don't need it for the session. Please keep everything inside. All your questionnaires, whatever you've got, your notepads, pens, please keep everything inside your bags because we need the space to work. Yes, so I'll introduce myself. My name is- Am I audible?
Because for long term, we have to talk like.
Hello. My Okay. Okay, so my name is Shivani, and I work in the science center, which is there across the road, and we do some research in science education and mostly in science toys. So many of you must have heard about science toys. How many of you have heard about science toys before? And how many of you have heard about space toys before? Yes, Arvind Gupta. So many of you must have made a lot of toys in your schools, at home, and to teach kids. So how many of you have actually used these toys in your classrooms to connect your chapter or your curriculum with the toys with the kids?
So made up models and used. Some models.
Okay, 3,
Many
4,
times now.
Many times. Good. Okay. So we, with this workshop, we at least feel that all of you will start using these toys or such toys. So whatever material that you just collected, was it very difficult to find, or we've not seen this anywhere? Where can we buy this stuff from? Was any of the materials of this kind? No, right? So everything, whatever we are going to use today, is available easily in the market. So I'll just tell you why we started with this concept. Because whenever kids are told about or kids read about astronomy or astrophysics, the first thought that comes in minds is rockets, spaceships, and that's it. That's all about astronomy or astrophysics. But that is not the case that we all know, right? So we all know that physics or core physics, fundamental physics is also very important for kids when they move forward, and it is a specialized branch, the astrophysics and astronomy thing. So yes, so today we'll talk about the overviews of these toys. Then we'll see how we can make them. Then we'll see how you can actually teach science from or connect it with your curriculum. And we'll see how is it feasible to do it in the classroom, because you have 50 kids in front of you. So giving material to each of the kid and asking them to make it might seem a bit difficult or impractical, but we can do it, and there are a lot of schools in Pune where they do where they do it, and each of the kids in the classroom actually perform experiments right from first standard. So there are some labs in Pune, in schools in Pune, which have labs from first standard to 8th standard. 9, 10, all the schools do have labs. But if we introduce these things through toys to the kids, how the timetable is arranged and everything, we can discuss afterwards if you're interested. But today we'll see how you can connect it with the class. So I feel that when the child is taken away from toys, he and she is detached from science. Why? Because I can see many people above 40 here. So now your experience is very huge with kids. It's not just 2-3 years back. It is at least 10 years. From 10 years, you are connected with kids in classrooms, and you have that much of experience. So you all know that kids don't need an introduction to toys. They are well versed with toys, or they are connected to toys right from their childhood, right? So if we go outside and we have a small kid, for example, 1 or 2 years, we tend to put at least a toy in a purse or a bag and carry it with us, because we'll say when he or she starts disturbing, I'll just give him the toy and he'll play with it. So they are that connected with toys. But when they start going to the school, what we tend to do is this is a time to study and this is the time to play. So we distinguish the time. We tell them that this is not the time to play. Don't play with your toys and study now. So it has become like this, that we have differentiated the two things, but here we want to interdiscipline them again and make them one. And so let's start. So I actually rearranged my PPT sequence sitting at the back, because these were the things connected and I saw what you have gone through for the whole day now. And I thought let's start with that. So sir has given you a sheet of paper and let's start with that only. So you have an A4 size sheet with you, right?
Yes.
So what these toys are intended to do is they are intended to create a wow factor in kids. They should be able to grasp it in that sense. How huge is this solar system, or how far the two planets are, how close the two planets are. We all know the distances in astronomical units. We'll also find them in centimeters. So I'm not going to give you the exact numbers in centimeters, or we are not going to plot the exact solar system right now. That you have to do at home as your homework. But I'll tell you how you can introduce the wow factor in that activity. So let's start. Take a sheet of paper and let's imagine that one side of the paper there is sun, and the second side of the paper there is Neptune. Okay? Let's fold it in half. So what do you think?
White paper I want.
Yeah. You can take white papers, lot of white papers.
You didn't say that.
No, because we had given.
As we have written for the calculation.
No, that was not for the calculation.
No, we did
You're
it.
supposed to plot the solar system.
Yeah, that makes sense.
You did. So if there is sun on this side and Neptune on this side, and I fold the solar system in half. So what is situated here, approximately here? Jupiter
or Mars, close by.
So now we have given you the list, and still everyone thinks that here it is Jupiter. What else? So if there is sun here and Neptune here, approximately in between, what is situated? Jupiter? Saturn? Jupiter, okay. Because Jupiter is in between, in the figure, Mars hai.
Mars is in India.
Now don't look at the numbers because the kids are not exact. Don't exactly know the numbers.
Counting in the center
It's Mars.
Saturn.
इधर बीच में
Mars.
Saturn is
It's
closer.
Uranus.
Uranus is a
Actually,
30
distances.
distances. We are talking about distances. No, here there is sun, and here you have the numbers in front of you. Here there is Neptune, approximately 19. Around 15 into 19. What is there? Jupiter है क्या?
Uranus, correct.
Saturn is there. Yeah, of course I'm talking about numbers. Uranus. Are we convinced?
Yes.
One final answer?
Yes, ma'am.
Now let's make this half. Let's fold in between Sun and Uranus. Fold with me. Keep the number sheets in your bags. Let's see what we think, and then we'll plot when we go home.
Put the side.
Now, what is your Sun, Neptune, Uranus, Earth? Okay, so things here is Earth.
Jupiter.
क्या होगा? Approximately बच्चों में वाव फैक्टर जनरेट करना है. उनको नंबर्स बताएंगे तो वो भाग जाएंगे. सर ने अभी बोला हमें. Saturn. पक्का लॉक किया जाए? Now fold it in half one more time. अब why everyone is saying every time Jupiter only? Sun to Uranus के बीच में भी Jupiter है. Sun और Uranus के बीच में भी Jupiter है. और अभी Sun to Saturn के बीच में भी Jupiter ही है. This time it is Jupiter. Okay. Final. Let's fold between Sun and Jupiter now. Let's see origami कितना अच्छा है सबका. अर्थ का तो भी पता भी नहीं है कहाँ पे फिट करेंगे अर्थ को. Folding between Sun and Jupiter. क्या होगा?
Now it's Mars.
Might be Earth.
Huh? Earth? Now Earth. No? What is there in between now?
Mars.
Mars? 2.5 पे Mars है? 1.5 Mercury है? Asteroid belt है?
Asteroid belt.
अभी उसको और आधा करो. Sun और asteroid बेल्ट के बीच में फोल्ड करो.
अभी Mars.
Now Mars.
अब पक्का? अभी तो पता नहीं कहाँ बिठाएंगे अर्थ को और वीनस को और मर्क्यूरी को.
This is wow.
Now we have folded between Sun and
Mars.
no Sun and the asteroid belt.
And then
now this much. Now it is Mars. Now let's fold between Sun and very difficult. Let's try. Now what is there in between Sun and Mars? Venus. Now see if there is any space remaining for Earth. No space for Earth. Now let's fold between Earth and Venus.
not possible.
Sun and Venus. Sorry, Sun and Venus. Let's fold between Sun and Venus.
No place?
Go place.
Right, done.
You can draw a line.
No space?
Done.
Where are we supposed to fit Mercury now? On the sun?
That.
So did you get the wow factor that we were talking about?
Yes.
Okay. So little space for sun, everything, sun, Mercury, Earth, Venus, Mars, everything is here. You cannot even see. And then this is the scope of our solar system. But what happens because of these pictures is we think Jupiter is here, Earth is here. No, it has no space to fit in to the scale. So we are very near to the sun as compared to Neptune, Uranus, God knows where Pluto is.
So they are called the inner orbital of
Yes, so inner orbit is the planets before us. Okay? So is this difficult to take? Is this activity difficult to conduct in the class for each kid? Alright? You don't need the astronomical units. You don't need to scale them down to centimeters. You don't need anything to do this activity. Once you're done with this activity, introduce them to what astronomical unit is, what numbers actually are, scale them down to centimeters, and then plot it on the page. Okay? So these numbers are approximately close to half. Okay? Uranus is a bit ahead of half. It is not 15, it's 19, but you'll get the idea, you'll get the gist. Okay? And then you can show them what it is actually. Okay?
Can you show it again?
You have this list with you.
No, this one is not.
Oh, that is the homework.
Pluto is not mentioned. Pluto is not a planet.
You can see if you find a paper of 59 centimeters and plot accordingly. That's not a problem. We can attach a paper.
Oh, A4, A3 centimeters.
Whatever. You have this list with you. Okay. Let's make another model which was connected to the previous lecture. Okay. So what actually is centripetal and centrifugal force? And why is it that powerful? Have you ever seen any lighter object taking up a heavier object? Can we, do you want to make the car? Okay. So you have a pipe with you. You can start making with the help of this also. So you have a plastic ball connected with thread. What do you mean? Yeah, please check if you have all this material. And secure it with a sellotape. Tie the thread to this ball, secure it with a sellotape, put the thread inside this pipe, and then tie the heavier ball on the other side. Don't take too much thread, just around 1 meter. Share the scissor.
1 meter.
We need to tie this thread, or you can just put it on the ball and tape it. Tape it with a sellotape. Once you take one of the ball, put the thread inside the pipe. Once you're done with this, tape the other heavier ball. No, you don't need 2 plastic balls. You need one lighter ball and one heavier ball.
People are playing with the ball. Yeah.
We have heavier balls here. Yes, show it. So what?
Show that how to.
Just put the thread on the ball and tape it. Your model should look like this.
Open
And how can you pull this heavier ball up with the help of this lighter ball? Yes. When you do this, the heavier ball will come up. Keep your thread a little smaller, just around 1 meter. If it is too long, if the thread is too long, it will start rotating and getting accumulated on the pipe. So make sure, yeah, it is too long. It is too long.
The edge is not smooth, that's why it gets immediately tucked back in. Pipe it's not smooth, so that's why it gets.
No, we don't have to rotate there. When we hold it like this and rotate and get some space, you can stand and check. Yeah. Don't be afraid, even if the ball hits you, it is not going to harm you that much.
Someone else.
Yeah, ma'am, here the thread is too long.
Can I make it still smaller?
This much
It takes some, but it's happening.
it will happen, but the thread starts standing to the pipe.
Video when you are playing with this.
Once you are able to make the toys and make them more, then you can do it in front of the kids. What? No, it doesn't work. Just rotate it. Done.
I'll take it.
And this can be your Earth satellite model.
Fantastic.
This will be your Earth. This will be your satellite. What if the velocity reduce? And what if the velocity is very high?
It doesn't hurt you much, madam.
Don't be afraid.
Just hold it above your head. That's it.
Yes. Okay. Try to do it the other way around. Try to keep the heavier ball up. See what happens. Try to do it the other way around. What happens?
Couldn't make a round. Could not make a round.
It's accumulated
It will
there.
fall down.
And this is up.
It needs more speed.
It will need more speed.
Mom, it does come.
Yeah, but it will need more spin.
We need to do this. Once this and then this. That's fine.
Okay, now what all can you teach from this toy, with this toy? Centrifugal force, anything else?
Which is acting along the radius outstretched.
Acting along the radius, outward, in the outward direction, anything else?
Weightless
Tangential
object.
force.
Weightless object around the weight object.
Okay, heavier, lightweight object going around the heavier object. Anything else?
Other way around is not possible.
Yes. Anything else? Can you tell me precisely where in your textbooks you can use this? Which lesson, which chapter? But I don't think centrifugal force is introduced before 11th standard.
No, it is introduced in 7th standard.
Okay, maybe it is some other board, ICSE.
But students, do they understand centripetal and centrifugal?
But exactly with diagram, this activity is given in 10th standard book, first chapter. 10th standard, first chapter. No, state board.
State board, like in that chapter, the centripetal force is given, not centripetal.
What is given?
Centripetal force.
Centrifugal, they do not.
But wherever there is centripetal.
But that term gets confused. Students.
That is what I am saying. In 10th standard, they have introduced centripetal force, but not centrifugal force.
Yes.
But of course, they have to be introduced together because they are connected.
Even in Cambridge board, they are not using centrifugal in 11th, 12th as well.
11th, it is there.
They have
circular motion.
Cambridge board doesn't use it.
Okay, Cambridge board doesn't have. But it's okay. See, Cambridge board, state board, centripetal and centrifugal forces won't change. In some board it will be introduced in 7th standard. Some boards it will be introduced in 11th standard.
It's shown in Mangalyaan.
Yeah.
Yes.
Yes. This is the same activity. Okay. So introducing these two things, you can use this. Or orbit of the satellites and the Earth, or any artificial satellite around any other planet, that can also be done. Okay. Next. So where are comets introduced in textbooks?
No. Comets?
Comets.
First of
State board.
First of all, geography, maybe only one chapter is there. Not such things.
Comets is there in textbooks. I have screenshots.
Which class?
I have that also.
Ma'am, speculation, 8th standard it was there, but that lesson is limited now.
8th standard, 17th chapter.
Yeah, for example, deleted now from the question. Now the last CBSE exactly the
State board, again the same thing. Even it is any board, comments अगर पढ़ाना है तो same चीज ही पढ़ाए. We will teach the same thing even if it is SSC board, state board, CBSE board, whichever board it is. When we want to teach comments, we will have to teach the same things. So exactly. So do you want to make a toy comet?
Yes.
What all things are there in a comet?
Head and a tail, that's it.
Tail? Okay, head and a tail, that's it. Okay. Two tails.
Right?
Two tails? Sometimes two
Tail
tails.
is
Okay.
made of light.
And of what are these tails made up of?
What gases?
The water molecules,
Hot gases.
dust particles, and what is the main property of this tail?
Moving away from this.
Moving away.
The direction
It goes in
of
other
travel.
direction of the motion.
It is going in the opposite direction of the comet.
Right.
Anything else? But why is it going away from the head of the?
Conservation of momentum.
Okay. Anything else? Why is it happening in the first place? Why is the tail
Not
forming
dense.
in the first place?
Not
The
dense.
sunlight that is that's what it is.
Okay, and
gravitational force.
of
Counterbalancing gravitation
what? Gravitational force of what?
towards the
Towards the
sun or Earth.
sun or earth. But there are a lot of comets everywhere. We don't need a sun or earth for every comet.
Probably the lighter objects gets attracted because of the gravity of own mass of the comet.
No, I did not understand what you
Can you say it again?
Probably because of the mass of the comet itself, the lighter objects around it get attracted.
attracted
To
to
the
what?
comet. So these are not from the comet, something else.
Oh, something else is coming.
It is sweeping out.
Something out is getting attracted to the comet because of its gravitational force. Okay. Okay, so what all you can use in your material to make the IC core and what you can use to make the tail?
Then what is the right concept? I mean, I did not get it. Why
What
is
is the correct answer?
Yeah,
Correct
no.
answer is
That we will see when we make the toy. It will be clear when we make the toy. What? No, I did not
That is the
understand.
same question I wanted to ask, that why that tail part is going away.
That is only we will see.
Okay.
It is made up of ice. Okay. Okay. So what can you use to make the IC core? Tissue and the tail?
Newspaper.
Strips of the
Thread.
Okay, so we will use the newspaper to make the core and the tissue paper to make the tail.
Oh.
So let's start cutting. So we have to make the tail with this tissue paper. We want small strips of these paper. So you can fold your tissue paper like this and cut small pieces. So when you open it, you will get one strip of paper. If you don't have tissue paper, yes.
Yeah, I think I know.
The answer is here.
See, here we don't have one.
Okay. Anyone has more scissors, please give it to them. We have to cut it like this so that when we open it, we get one long. As many as you want, 10, 15. Folded the paper like this, so when you cut a strip and open it, you will get
a bigger tail, strip of tail. Okay, I'll show you how to fold a paper. It is easy. Just fold it like this. Like this. But if you fold it perpendicular, you will get chips of paper.
This is okay.
One second. That is. So you have a square. When you fold it like this, don't fold it like this again. Fold it like this.
With the tail may be small.
Tail. If you want small tail, that is fine.
We cannot assign length of a tail.
That's fine. Once you're done with all, just combine them and put a sellotape.
End to end combine करना है. End to end combine.
10, 12. End to end combine. Combine all the tails and put a sellotape around.
So sensitive, right? So sensitive.
Very light and weight.
Enjoy. Learning the sister in classroom is highly dangerous.
Class.
And we can ask them to here like this.
Yeah, it is very easy to.
They will enjoy it.
But my point is,
Yeah, this is what we want. It is like you can imagine how kids will do it in the classroom. Will they like it? And when you start making these toys in the class, you will not be required to repeat some things. Don't talk, look at me, keep quiet, nothing new. Yeah, that is also one plus point. So look, you have to make 2 more.
How to stick it one on one?
Sellotape.
All
Not
together.
make a bunch kind of thing.
Like this, no?
Make 5, 6 also if you have done.
that's enough.
That's enough. Yeah. Okay, once we're done with this, we'll make the icy core. Dust, ice, what else? You have this newspaper, make a bow kind of thing of this newspaper. And stick the tail here so that when we make the core, it will not come out.
Compared to the argument.
He is saying it is difficult to find the origin of the sellotape. It is difficult than finding the origin of the universe.
So better to join as a scientist.
No, you found it.
So motor skills.
Our forgotten things are also.
Ma'am, you just have to take it in the center like this. Is it like this?
No, it is join this.
This and this. Okay. Just by crumpling it like this, no?
Yes. Enough. And then we have to make the comet where you have to be sure not to crumble the tail in.
Showing all the angles towards the teacher.
Put all your anger in it.
There will be more listening of the teacher.
Making all the comments made up of all the
A high support.
theory behind the comments. Making dies. It will be a perfect spherical.
That is also not. May not be a perfectly spherical.
Now what? This we have to crumple around.
See like this.
So this everything.
Might be
Yes.
any shape.
Any shape. And this is also a thing you can explain. Are the comments always spherical?
I think many more questions. Right? I'm a good fit. Good student.
Now, why beginning? Why human beginning is lost?
You want this?
Almost done. And then you can attach a thread to it to see where the tail goes. If you want, it's not compulsory. And what will happen when this comet will approach the sun?
Tissue paper will burn.
This comet will burn. There are a lot of such bits given in the textbooks also, where they have given some common superstitions also. So I've included that part also. Then and there you can clarify some things like this, that comets are messengers of disaster, such as war, floods. But these are all myths and superstitions. No need to be afraid of it.
We interrupt the events and the appearance.
Sorry?
We interrupt the events as well as an appearance. That is a problem.
Yeah, we don't have any statistics to be afraid of.
But Since there is a statistics, there is an they have a lot of statistics. Appearance of comet and disaster.
Appearance of comets and disasters. He's saying there are a lot of statistics.
Now, human being, we interrupt the events with respect to the person. That's all.
That is altogether different topic. Let's not go into it.
Done, then what?
Yeah. Let's shift the view. So now you can see what all you can teach about comets, how they go around the sun and why the tail is away from the sun.
Why stay away from the sun? With the heat it goes.
The solar flares, the icy core or the water vapors or the ice in the core melts and it is left behind as the comet moves forward. Hence the comet leaves a tail behind it and not all around it. Okay. Now moon phases tomorrow you will take, no? Tomorrow you will take. Well, I'll just take the activity today then.
What the comet is entirely composed of?
What the comet is entirely composed of? Dust, rocks, ice, mostly ice.
And where's the origin of the comet? Where it comes from?
I don't know. Sir, they are asking, Surup sir, they are asking the origin of comets.
So where it comes from?
Yeah, so I think in the scales of the universe, you saw that as you go further and further out, there is a reservoir of things called the Oort cloud. Okay? So it is like way beyond Uranus and Neptune and so on, about 2,000 times the distance between the Earth and the Sun. Okay? So once you go to that kind of distance, there is this cloud of dust and particles called the Oort cloud, and it is like a leftover from the formation of the Sun. So these comets, they get dislodged from this high distance, and then they come close to the Sun, and then they pass again. So they have this highly elliptical orbit that you see.
So they come from Oort, we can see that.
Roughly, the Oort cloud is where these things get dislodged from. So there will be some small disturbances which cause these things to get launched towards the Sun.
So how many years it takes?
So, okay,
Run towards.
very good. So do you know something called Kepler's law?
Yes.
Yes.
Okay. And so it all depends upon how far you start from. Okay. So if you know Kepler's law and you know that Earth is at whatever 1 AU, 1 astronomical unit, that's the distance between the Earth and Sun. It takes 1 year to do 1 AU, right?
T square proportional to
So
Q.
then you do T square is proportional to AQ. You know what is the semi-major, roughly 2000 AU, so you can calculate.
That R is a semi-major value or average radius?
Semi-major axis. Yes.
Half the same.
Okay. So in principle, depending upon where you start, then you can decide, because that distance is far away compared to the location where it goes near the Sun.
There is Kepler's belt right after Neptune. Kepler's belt.
Kuiper belt.
Cooper belt.
Cooper belt.
Yeah.
Halley's comet.
Yeah. So there are some comets which come from nearer places. There are many of them which come from the.
Comets are self-made. Comets are self-made elements.
Self-made, well, I mean, there it depends upon how they actually coagulate together and what is happening in the wood clouds, what kind of fluctuations are there. Then these fluctuations get together and then they get dislodged.
Gravitational force of like bigger planets like Jupiter could fall in place.
Yeah. So some of these disturbances will come either from the neighboring planets, or there are other kind of processes.
Black holes,
No, not black holes.
A supernova.
I mean, they are not so close. Supernova explosions also happen like really far away.
Okay, so tomorrow you will have a session on moon phases, but today we'll make a very nice small toy where you can see on each day how the moon looks. Okay, it's like on new moon, how will it look after 2 days, after 5 days, on 7th day, 10th day. Okay, so for that you need to cut these 2 circles and cut out the window on this part of the circle. And there's a press button given to you. So we are going to connect both of these circles with that press button. So both the circles, yeah. So these 2 will go on top of each other and you will see only the moon from this window when you rotate. Ice cream stick, you will have to stick like this. Yeah, with sellotape. On both the circles so that it becomes like a handle. Put the press button in both the sheets and secure it from the other side. It's okay.
Can you show just once? We have to cut this.
Like this. You have to secure it in between with a press button. There's a small.
This she has to cut, no? That round.
Yeah, this you have to cut.
No, they are asking. You have to cut.
See, we have to cut this circle also to see the actual moon picture. We have to cut this slit to see which day it is, and we have to cut the inner circle, not the outer circle, in the middle to fit the press button. Yeah, the final product would look something like this.
Oh, that's so nice. It's actually wow factor.
All these toys are meant for creating the wow factor and curiosity. Okay, so now I don't have much of time. I've already exceeded 15 minutes. we'll just see what all we can make. So this is a balloon rocket in which you just need a thread, a piece of.
We will share the.
Can you just can you just show that biggest size?
We'll share all this. I'm able to see it here, but sir, I'm able to see the video here, but it is not visible there.
It updates. You have not shared this thing. You have to share this. You share.
How they fix that thing?
So you just need what? You just need a thread. Put a small piece of straw in the thread like this. Attach a balloon.
Straw is there?
No, I will not do all the things now. I'm just showing you the videos so that you can go home or go in the classroom and do it. Because now we don't have that much time. You've done it in the classroom. That's nice. So what all? Sorry.
We are going to stay at the skywatch.
Then we can do a lot of things.
So there is time.
No. Then we stick. If someone of you are interested, you are welcome to visit the science center and try out these activities there.
Where is it?
Across the road.
We will actually go there for stargazing.
So when you leave the balloon, it will go like this. What all you can teach?
Newton's law.
Second and third law. Newton's first, second, and third law.
For rocketary launching.
Madam.
And this activity is exactly given in the textbooks as an activity also. So you just need thread, balloons, sellotapes to do this activity. So it is actually given as an activity in the textbook also. So this is a textbook screenshot. This is also a nice activity where you can make rockets from papers and an actual launcher, a rocket launcher with the help of a bottle. So here you can actually take a bottle and make a hole inside the cap of the bottle and attach a straw to it. You need a thick straw. You can use a paper paper straw and glue it with a glue gun or any MCL can do, or a Fevibond will do, but it should be airtight. So the air should not leak from the cap. And you need to make such rockets. The diameter of the rocket, the pipe of the rocket should be slightly more than the diameter of the straw. Otherwise, it will not be nicely launched. The diameter of the rocket, the paper rocket that we make, should be slightly bigger than the launcher pipe, or you can use PVC pipe also, or the straw. So that when you press the bottle, it will be nicely launched. And you have to seal the top end of the pipe. Then you can decorate the. Sorry?
You can blow over.
Yeah, that can also be done. Just the pipe, and you can make a small paper rocket and put it in the pipe and just blow it. That can also be done. Yeah, it can. Yeah, just make a small cone, paper cone kind of a thing. Like this, and put it in a pipe and cut it till small paper cone like this, and then when you put it in the pipe, just cut it till so you can make it launch, and you can actually teach projectile motion with this. So actually see how it goes.
Yes, without any fan.
And this you can launch. So when you press the bottle, the rocket will be launched. These kind of bottles are also okay. And you have a pipe here, and when you press the bottle,
and the rocket is easy. This little bottles get pressed easily.
Yeah, these bottles get pressed. So it goes in a height and then it will fall down. So it's just pressing the bottle. Did you see the rocket launch?
There are the things at the mid and the upper part. The distance the cover changes, through which we can explain the students why we are adding the pins at the bottom.
Okay, yes. The aerodynamic thing. The tip should be pointed enough.
Pointed, and the pins have to be attached at the
below.
It means you will have if the center was that
the distance will be less. This is also a nice activity. When you take a bottle of water and you pierce a hole in the bottle, what will happen?
It will start flowing.
The water will start falling. If you leave this bottle from an height, as it starts falling down, will the water still be coming out of the hole?
No.
Why?
Inertia.
The air pressure.
Atmospheric pressure holds it.
What?
Pressure holds it.
What air pressure? Air pressure. Which air pressure?
Atmospheric pressure. Atmospheric pressure.
Atmospheric pressure. What about atmospheric pressure?
Force exerted by the aerosol, 1 square meter area. That's called as atmospheric.
So because of, so there was no atmospheric pressure when the bottle was in my hand and the water was coming out of the hole.
Yes, it is.
So then why did the water from the hole stop coming out of the hole when we drop the bottle? You want to,
Due to
do you
inertia.
think it will come out of, it will stop?
It will stop.
Inertia.
Free fall.
It's inertia, no?
All the particles will go with the acceleration due to gravity.
So when you ask, is there gravity in space?
Yes, it is.
What do you think the kids will answer?
There's no gravity.
No.
There is no gravity in space.
Oh, you
So
play
is
it?
it true?
No, just play it.
There is very less.
Oh, there is no gravity in space. Okay, right.
Very less, she is saying.
On the big
Gravity is there, but
So the kids actually have the notion that the astronauts in the spaceship or the rocket, they fly because there is no gravity in space. But if, yeah, so but if, so how is Earth going around the sun? How is the moon going around the Earth?
The gravity.
Gravity is there. The gravity
It is there, but
it's not that gravity is not there. Of course
It is different.
Gravity is G, open
What is different between the gravity of
There is constant.
value of G is small there.
There is constant.
value of G is small there.
There is constant free fall. There is everything is in a state of free fall, and that is why
Yes.
it is felt as
Yes. So what will happen? Can you imagine a scenario where you are standing on a weighing machine? Yes, you will see some weight. Now you jump from a cliff. Don't do this at home, please. Just a thought experiment. Let's do a thought experiment. We'll jump from a cliff or a building with the weighing machine. So now what will be the weight?
Zero.
On the weighing machine. Why?
Because
Because
not
weight
putting
is
it in
not-
a
There is a concept called apparent weight loss and apparent
Value of
weight
G
gain.
is zero.
So weight is lost?
No.
Value of G is zero.
Value of
G is zero.
Both of them.
No, G cannot be zero.
Both the weighing machine and the person is falling down.
That's called free fall.
Both of them are accelerating with the same speed.
Yes, yes.
Okay, so is everyone understanding, following this, what is happening? No, sir. Maybe not. Right?
Relative force.
Okay, so
Maybe, okay, yeah, maybe I will. So, have you ever been in a lift and when the lift starts to move up,
Apparent weight gain.
do you feel that you are heavier?
Yes.
You feel that someone is pushing you down
Yes.
towards the floor, right? Yeah. And then when it is accelerating to slow down, what do you feel?
You gain.
Lighter.
You feel a little bit lighter, right? Okay. Have you experienced? Has everyone experienced this?
Yes, sir.
Who has not experienced this? That is also okay. I mean, please say yes. Please say no if you have not experienced. It's okay. Yeah? I can give another example. It's not a problem. Yeah?
So give another example.
So, okay, good. let's take another example.
In a swing.
So,
Swing.
no. Well, swing is okay. But another example is the one that we studied for tides. If you are in a car and the car is going round and round, what happens? You get thrown, right, to some other side. So all of these are pseudo forces, right? And what did we learn? What do we have to do with these pseudo forces? You have to balance with some other force, right? Now, if you are standing on a weighing machine, so every time you go into an accelerated frame, so anything which is accelerating, in that frame you have to apply this pseudo. Okay. So let's look at, you are standing on Earth. This is the weighing machine, and this is the person. Right? What is this person doing? There is gravity acting from the Earth on this person, right? So that's the reason why his weight is being put on this particular weighing machine. Now, both of them are falling together. The ground is here. Okay. So what happens is, as soon as this moves, these feet are also moving at the same time. So it's as if they are just in contact. Okay. There is no pressure which is being put. Okay. So let's try to understand what is happening for this particular machine, right? In principle, this is this is falling down with some g, right? Some acceleration here, okay? And then this man is also falling down with some other acceleration, I mean the same acceleration. Right? And that's the reason why they are just like touching and there is no pressure whatsoever which is being. On the other hand, for this person here, there is a pressure which is being put on top of this on top of this weighing machine.
So actually,
so this is why you see some weight on this weighing machine, while here you are not.
And
Now let's go to another thing, which is, let's suppose you are in a lift. Okay? So rather than this, the lift is easier. So there is a lift. There is a person here. Right? Okay? So this person is in an accelerated frame, right? Okay, maybe even the lift you can forget about. So this person, there is gravity acting on this person. Yeah. But you are in the frame of that person, right? So you can try to see what is happening to this person. This person is accelerating, and so you have to apply this pseudo force, so that you will see that nothing is happening to this person in its own frame, in his own frame. Right? Okay. So if you are just considering that person, it is as if he is just free falling. So he does not experience anything different happening. So if he throws a ball, he will just see that it is going in a straight line. You won't see that it is doing that kind of a thing that we were showing. You know, for the bottle. Like if I make a hole in the bottle, the water just falls down, right? But if it is in a free fall, then nothing happens. I think you had a.
You can actually see, you can actually take a slow motion video with the camera and see the water stops coming out of the hole. There is a hole in the bottle, but the water will not come out. You can make lot of 5-7 holes also to the bottle, but when you leave the bottle from your hand, at that instance, the water will stop coming out of the bottle, and you will see that the water which was already coming is falling on its own now. It has lost contact with the bottle. Can you see? So the hole still exists in the bottle, but now the water is not coming out because now water is also falling down with the bottle. It has no other reason to come out of the hole separately to fall down.
Right.
It is already falling with the bottle. Okay, so these are some very nice activities that you can do in the classroom, and kids definitely love to use smartphones, and if you give them.
There is a formula behind R is equal to mg plus ma. R is equal to mg minus ma. R is equal to mg minus a. If g is equal to a, R is equal to 0.
Yeah. So it is not actually magnitude wise 0. Okay, thank you, and I hope you will start using these toys and activities in the classroom. And if you do so, please take pictures, videos of the activities in the classroom and tag IUCAA on Instagram or Facebook for it. Thank you.
Yeah, so yes. So for sky watching session, how many of you are going to be able to stay? Okay, maybe how many of you are not going to be able to stay? Then we can get some count at least.
Okay.
15 or so people. Okay.
So is it there?
Yeah, it's going to be there. We'll do it.
15 of them.
I'll take it. When I conduct this exam. Come with one of the Fridays. Comment.
Just one session is there for half an hour. Please return. Half an hour session is still remaining, and just you have to return the scissors and sellotapes. So you don't need to do anything, just watch. So, is it okay? Can I talk in Hindi? Okay, this is a very short session. We call it as a demonstration session, and whatever you have just made, 2 or 3 toys. So this is the set of toys. We just demonstrate in between 1 and 2 hours. So in 1 to 2 hours, we demonstrate near about 25 to 30 toys with explanation, with demonstration. And mostly we do within a local language so that children can understand, teachers can understand. So I just picked one section in just like a. No. That's not a problem. That's not a problem. No. That's not a problem. See, this part is called as outreach part. So mostly in outreach, we select the local language, and you know why. Okay, that's why I first asked, is it comfortable that all can understand? If it is not, then it is good. Okay, so English is also good, but just I confirm from you. Okay, so the topic which I selected is based on the light. Okay, so everyone familiar with light, and this is the demonstration part. Okay, so whatever you have learned today and you have made today, we call it as a teaching aid. You teachers can use as a teaching aid, and for children it is a toy. They generally call it as a science toy, not a science experiment, because experiment is a boring.
I'm scared of the word experiment.
So they think about that. I have to go to school, then do the experiment, then take the reading, then show it to my teachers, and then he will give a marks. Then suddenly fear comes up. Okay, so if you take a name or pronounce the name a toy, then there is no fear. Okay, that's why these toys are made, and the motto behind to rename it is this one. Okay, so some of you have already tried, and you know now to just instead of just looking it, it looks very simple, but while doing it, so there are other toys. I will show you roughly other than light, but I will not going to explain it here because it takes time. So if I don't explain in a proper manner or with a flow, with some interesting facts, like I will attach a story, I will attach a song, or whatever you have your skill while teaching, then it will become just a toy or just a material. As you can see that this all material is like a kachra. Yes. So you have to make it a good science exhibit, or you can say that you are teaching it. But that is depend on you, that how you are explaining it, or you are teaching or so. Okay. So we have a set of, I think 40 to 50 experiment in one box you can fit, and it takes 3.5 hours to explain that one box in detail. Okay, so I will start. So before that, apart from light, I will show you some random toys. Okay, and the general way of doing this is I will call some of you or from some children, okay, and they will come here and do that, and then what they feel, I will ask them, they just tell. So in this session, I don't need a textbook definition of any scientific concept. Just what they feel, they have to tell in their words. Okay. So we don't have time. That's why I am only doing it. So we have the two pipes. Okay. You know what this pipe is called? This is basin pipe or something. Okay. So you just have to what?
Rotate.
Rotate. Now I am rotating it fast. Again fast. Again fast. Okay. And slow down. Slowly. Okay. So you have to do it slowly. You have to increase speed slowly and decrease again slowly. That is another set of observation. Just we don't have to listen to sound that something is coming out, but how it is coming out, that you have to. So you have to observe by two ways, eyes and ears. Okay. Now this is another pipe, and you can see the difference between these two. Length is same, but what is different? Width is different. Okay. So again, I am rotating this one. So is the sound was same? Now the question arises how the sound is produced in this pipe again. Okay, how this sound is produced. Second question is why there is a change in the sound between these two pipes. Okay, these are the set of questions. Or someone can produce some other questions, but these are the two basic questions. Okay, so the topic is sound simply. So first of all, can you, some of you, tell me that what is meant by sound? Now these are the words coming from textbook. Whatever we have here.
Sense of feeling.
Sense of feeling. Okay. In simple word, 1 and 2 word.
Energy.
Something that we hear.
Okay. So what happens? The thing is that we generally ask this question in teachers workshop, in students workshop, and hardly 30 to 40% can give the correct answer. The correct answer, your all answers are correct, but I need a proper 2 words. I need a full complete definition. Okay. So how many of you have feel that sound is nothing but vibration?
Vibration.
Okay. So how you can prove?
When you talk, you just touch your vocal cords.
Yes. So that is our first experiment. Okay. So you don't need any kind of material for that. Just you have to put your hand here. You can do it with me. Put your hand here. Okay. And with my hand, if my hand raised, your voice should be raised. Okay. You have to increase your voice. I am going here. Okay. Here. Zero sound. Okay, here middle and here is high, and you have to just go like this. Okay, ready? Start. So you are not observing by eyes. My hand is zero. So these are the things, funny things naturally comes out, and see, 80% of you are laughing now, and that is the main thing. Your each and every session should start with smile. And then it automatically goes in your mind. Okay. So now we start. Okay. Slowly increase. I know your voice is very good. Okay. Now children do this in a very beautiful way. If it is more than 500 children in front of you, the sound becomes
horrible.
Okay. So why you are doing this one? This activity? They know that there is a vibration in their throat. Okay. So they get confirm about that sound is nothing but vibration. But what is this one?
increasing it.
So how, what they want to tell, or what I am want to tell?
More vibrations, more sound.
Yes. So for increasing sound, what I am using? My energy. So there is a second sentence in H. Handel book. Sound is a form of energy. That can also prove by this way. So tell student to do this kind of sound till 1 hour. They just smile like you. That this is not possible. Why? Because that much amount of energy we don't have. We need very high energy. So they get confirmed that sound is a form of energy. That's it. How much cost needed for this experiment? That's it. So it is depend on you that how you start your session. Now see, I am starting the sound session and there is sound in my class. Okay. Now you compare with your previous lectures of sound. There is a big title of sound. Then there is a definition. Everyone write that definition. Teacher goes, student goes. There is no sound. That's why they didn't tell later on in. They just write once a time in the exam, but later on they forget what is sound. Okay. So while sound, you should produce sound. While light, you can show actual light. If there is a lecture of motion, gravity, you can try such experiment, role play that includes some gravity, that particular concept's effect. Okay. I am not saying that each and every concept has a simple experiment, but you can try for a role play. You can try for one good kind of a story. Okay, like that. So you have to make your session interesting. And if anything is interesting, then you don't need to tell people that do this. You should do this. Okay? Just think of going to movie in a theater. Everyone likes it. Why? It is interesting. First thing, it is interesting. There is a sound, there is a light, there is a scene, there is a hero, heroine, villain. Everyone likes it. And that's why you don't need to tell each and everyone that go to movie, do the study. They automatically do the study of hero, heroine, everything. All movie in just one show, they know very well. Okay, but this doesn't happen in a studies because studies we made boring. The process of study is totally boring. What we do normally, just take a book, mug up, and just write in the exam. So if such a kinds of things, just activities, hands-on things, or if it is not possible for hands-on sessions, then you can do such kind of things. Okay. Apart from this, there are various types of toys available in the market. I got this one. Now you have seen in that experiment, I just changed the width of the pipe, then my sound goes changes. Okay. And what changes? You know that the frequency, wavelength. Okay. And this is also one toy. This changes the length of the pipe. So there is a piston-like thing inside this bassary. Okay. Flute. And you can change the length of the pipe. Okay. So what happens? So I am changing the length. So while I am changing the length, there is a change in the sound. Means there is a change in the frequency. Okay, you just do this in front of your frequency measuring apps are there in your mobile, Android mobile, and you can take the readings of that particular frequency also. So I'm keeping it here. Just blow into front of mobile, then you will get that particular frequency. Now you can measure this distance also, and you can draw a graph of distance versus frequency. Okay, so if it is not available, this is another one. This is just a simple PVC pipe. There is one balloon. You have to put water and just press little bit and do like this. Okay, so I will show you. So these are the random toys just that I am showing you. My actual theme is different. I will start. Okay, you have to just fill this balloon and start doing this. Okay, So every time what I'm doing, I'm just pressing that balloon little bit. So my water level will rise. Okay, so the length of the empty pipe becomes decreases. So there is a decrease in the wavelength. Okay, and there that's why you are hearing different sound. So this syllabus in this standard we call it as resonance and nodes, antinodes.
Can you show it one more time?
Yes, you can do like this. Someone don't like that sare no upper. You can do this also. Okay, so you all know that sound waves are the which kind of waves?
Longitudinal.
Longitudinal. Okay, and sound is a form of energy. So how sound propagate from one point to another point? We can show this by using this simple model. Because normally our sound travels through the air medium. Okay, and air we can't see. So children doesn't actually understand that how sound travel. Okay, so I will just show you. You have to just take lot of straws, 50 to 100 straws, and just one sellotape is needed. And you have to just, sound is nothing but
Longitudinal form of
Vibration.
vibration. First thing is vibration. Okay, so I am giving just little bit vibration. You can see that the vibration is going. Okay, if I give lot of energy, then I can see the changes in the vibration. If I give this kind of, I can show actually. Okay, now I will rotate this. So these are the your waveforms. Transverse wave we can also show by using this. And there's a formula that frequency is inversely proportional with
wavelength.
Wavelength. Now you can check that this is only one wave. Okay, this is one wave, and the length of this wave is called as wavelength. Okay, and between this distance, how many waves are there? One. So frequency is one. Now I am increasing the number of waves. That is, I am increasing the frequency. So what is happening with wavelength? It is length of one wave. It is decreases. So you can prove the actual formula by using just a straw wave model. Okay, and you can see by saying you can understand that how it is simple to make. Okay, so. We also know that light is a form. Light also have form of wave. Okay, so you can explain the properties like amplitude, frequency, and wavelength by using that straw wave model. Okay, now we generally start our light session with this toy. So normally I will not tell student that I am starting the light session. I just directly show this model. So you know what is the material. Very fancy material. Okay. And first I will do this. Okay. And then I will do this.
Oh my God.
Now you just have to tell me what I am doing. Just like you, children also able to answer this. That is, this is a concave and convex mirror or lens. That is convergence and divergence you are telling us. And 50% student can able to answer without telling them that I am starting a light session. So this is the effect of, you can say, a chappal or this model. Okay. So this is a very favorite model. Whoever visits here in IUCAA, that scientist visits here, they first recognize and tells about this chappal. Okay. So this is a chappal ray model. Okay.
Oh my God.
Chappal ray model. If you don't like chappal, just put a rubber foam sheet. But what? Generally, we show this one, and this is the now you can see this is broken also. So this is we are showing for almost 10 years. Okay, so this colors comes not by using it, just showing it. Okay, so why we are using that? Because we demonstrate this kind of experiment in rural areas also. So there is no option of rubber foam. So children can understand that I can use my chappal and do this because I have a chappal. I don't have a rubber Okay. So from this we can understand that this is a concave shape, and if it is a mirror, surface, then we call it as a convergence of light rays. Okay. And this kind of mirror is called as a concave mirror. This one is a convex mirror. So light diverges in a convex mirror. Okay. If it is a lens, then what happens? We generally teach mirrors and lens separately. Okay, in school. And that is the problem. That's why they confuse in while drawing the diagrams. Now see, consider this as a lens. If it is a convex lens, light rays are coming. If it is converges, which kind of lens it is?
Convex.
Convex. Already told. Okay. And if it is diverges, then that lens is a concave. So my question is, if I want to collect light, which mirror I have to use and which lens I have to use?
Concave mirror and convex lens.
Here you just have seen here. Okay. And if you get confused, you just need a that's it. So now light band cutter. Light. So to understand light, we have to shut down the light. Pura band karo. So if you do completely dark, first sentence from the children's mouth is wow. Something going to happen now. Okay. So
Wow.
yes, wow. Okay, what is the first property of light?
Linear propagation. Linear propagation.
Linear propagation. That light always travels in a
straight line.
So we can show them like this. Now it is not clearly seen. I am doing again one thing, but it is also considered in the properties of light. Okay. So I am just spreading the talcum powder, their favorite talcum powder. Okay.
So even
now you can see clearly. Chalk powder, talcum powder, you can do it. But chalk powder, student doesn't like the smell of it. That's why. And this is a favorite one. Okay.
Excellent.
So light always travels in a straight line. I'm not showing some what special thing. This is a very simple one. Now, if I want to hold this light and bend it down, is it possible?
Yes.
For me, it is not possible, but some of you can try. You have to just hold this and bend it down.
Using glass, plastic.
Is it possible?
Yes.
Okay, you have to check first. Okay, it is not possible. Okay, so I got some material. I just kept this one on this and just bent it. So you have to tell me what is in my hand.
Optic
fiber.
Okay, so if I change the property of light, I should get Nobel Prize. But still, no one gives me. Okay. See, I can change I can hold the light, I can, wherever I want to. Okay. So this is the optical fiber. So what happens in the optical fiber? And we know the importance of optical fiber cables in astronomy. Also in, you know the use of this.
The use of this.
Total internal reflection. Okay. So just hold. But the total internal reflection starts from other basic properties of light. After the rectilinear propagation, the next property is
reflection.
Which one?
Reflection and refraction.
Don't able to see anything. No. Okay, just so reflection. Okay, the another one is a refraction. Then
Total into the reflection.
Other properties, but I will start. I will showing here only one or two. Okay. So we know the reflection. What is reflection? In simple words,
Bouncing
back of light. Okay. And you generally show this kind of reflection and its laws of reflection and the types of reflection on board while driving the incident ray, then reflected ray, then normal, then you tell about the three laws, that incident ray and reflected ray on opposite sides, the angle are will be same, and then both of three of them are in a plane. Okay, but you are actually drawing on a plane. Your notebook page is a plane. Yes. Your blackboard is a plane. So you are drawing in a plane surface. That's why it is in a plane. Okay. You understand what I am saying?
Yes, yes.
You are actually doing that. You change it. You are changing that. Okay. So instead of showing just a diagram, this is more correct way. You just need a mirror and one wood laser. Now this laser is recommended for teachers only, not for a student, because this is an astronomical laser having a high intensity. Yeah. Okay. So you can see here, if I just spread some Prasad, if I spread some dust, then you can clearly able to see it, the incident ray, okay, and the reflected ray. Now, if I consider some normal here, and if I change the incident ray, reflected ray will be changed, their angle will be changed. Now this is actually happening. I am not drawing it. I am not forcing it to. See, in drawing, someone can take incident angle 40 and they can draw incident reflected angle 50 also. So that can be happen in drawing, but not here. So this is the more correct.
Sir, one more time.
Yes. Yes. Okay. So this is incident reflected. You can change this and tell student that how it actually happens, and is it looks beautiful? Our main target is to make science attractive and interesting. Okay. Now the second part, the next property. Which one? Refraction. And see, you can see here the what kind of material I am using here. Okay. So there is a tungsten bulb. I will show you. See, this is a tungsten bulb. In that tungsten bulb, I have poured water, almost about half. Then I will put some 1 or 2 drops of Dettol, or you can put 1 or 2 drops of milk also. So just sign in 1 drop. And then I need to smoke up upper part so that you can clearly observe the laser light. Okay. So inside water, I just put some Dettol drops, and then on the remaining upper part, I will put some. Okay, so you can see here refraction. Okay, so what is refraction? In simple words, again,
Deviation in the path.
Bending of light. Okay, bending of light. So now this refraction happens from water to air, because I am putting a laser light from that direction. Now you can show it by air to water also. So you can tell about the refractive index from air to water, water to air. See, okay. Now you just have to change some angle. See, now this is called as a critical angle. Okay. This is called a critical angle. So at particular critical angle, you can see total internal reflection. Okay. Now the same water I will put in a test tube. Okay, simple test tube. And now you can show the actual total internal reflection.
Oh,
And
wow.
this is happens in a optical fiber.
This is amazing.
Okay.
This is
Now you can see that every time light reflects, it goes in, and that's why no one gives me a Nobel Prize. Okay. Yeah, you can add 1 or 2 drops of Dettol or milk. Okay.
Just to make it visible.
And this is again one interesting fact that why should I have to add this? Okay.
So just a minute.
Yeah, can you explain that कि ये कैसे हो रहा है? तो ये तो glass है ना, तो वो reflect कैसे कर रहा है?
अरे, across the boundary.
So I am putting this in a critical angle mode. Okay. If I put like this.
He's maintaining the angle.
Yeah.
And as it is round, you can send the.
Okay. Now this again looks beautiful. And that's why you are taking photos.
But we are not able to catch it. The beauty is there.
Okay. Now the next part. All of you have a prism in your lab. Now see this one. Prasad, careful.
That red one.
Yeah, you should have to be careful while using this laser. So you can see. Now this is a green light. That's why the dispersion thing kind of thing is not happen. But I am telling about the
red color that is seen.
Now if I change the angle, what happens you can take. Now this is again internal reflection in a transparent glass. We can show it from prism also.
Can we use that powder again? We can see.
No,
It is visible.
This is visible. Okay, and then if you change the angle again, you can show it by using the prism. But prism is again costly thing. And what we have used in this experiment? No. This one, just a simple bulb. Water is available, bulb is available, smoke is available. Just you need a simple laser, which is having a cost. You can get in the market also or any kind of shop. Simple laser. You can do it from that laser also. Okay. But you have to, if you want to show in front of large audience, then you need strong laser so that everyone can see. Okay. Then the next part. Now you have seen the properties of light, that is refraction and reflection, and so firstly we already have Chappell ray model, okay, backup as a backup. But if you have that mirrors, that concave and convex mirrors, you can show the actual ray diagram also. Okay, so I'm producing. I have 2 mirrors. Okay, one is a convex, another one is a concave. Okay, so this is a convex mirror. This is a concave mirror. Okay, so which one is a concave and convex? Now you have to tell me by just watching the ray diagram. So I am putting 2 parallel light rays on single mirror. Okay. So tell me the name of that mirror.
This is convex.
This is a convex because light rays are divergent. Okay. Now I will put here.
Concave mirror.
This is a concave mirror. So light rays are convergent. Okay. Now again you can say you can show same thing by using the lenses also. So we just need a lens holder. We made this lens holder by using the simple foam shape. Okay, that is not a ready-made one. Okay, that can be also prepared. So tell me the name of the lens.
This is convex lens.
This is a convex lens.
Focal point.
Okay, and second one will be This will be concave. Okay, because slightly raise our diversion. Okay. Now we have one model made from this simple concave mirror that we normally have in our labs. Small concave mirror. Okay, small one. So this is a simple reflecting telescope made from plastic water bottle. Okay, so you can say that what is the purpose of this? So there are two types of designs of telescopes, and the telescopes from which today's sky watching will be happen, that will be a reflecting kind of telescope. That means it contains mirror. So obviously, which kind of mirror? Concave, because that collects light. We need to collect light. Then and then we can see the object's detail. Okay. So how the ray diagrams happen in that telescope? How light from the distant object comes inside the telescope and then get processed and towards your eyes. I can show from this one. Just I made again a little bit smoke. So this toy you can use to show how the ray diagrams happen or how the telescopes works actually. And this is actual telescope. You can see moon from this telescope also. Okay, it is not just a model, it is actually working model. So you can actually show the design, how telescopes are designed. I will show later on when lights will on. So normally this reflecting kind of telescope contains two kinds of mirror. You can see here the complete ray diagram. Okay. So the first mirror here is a primary mirror, which one is a concave. Okay. So the light from the object. So if your object is here, consider moon is here. So light from the moon will enter in this telescope by this direction, then fall on first primary mirror. Then there is a secondary mirror, which is a plain one, but inclined at a 45-degree angle. And then that reflects the light towards your eyepiece. So you have to, if your object is here, you have to look like this. Okay. So how the ray diagram will be? Okay, now you can see the light is going upwards. Okay. So you can show the ray diagram also by using this simple telescope. So this is about light. Light चालू करता हूँ. Yes. Okay. Yes. Almost. So we will stop here. There are a lot of things that we can show, but time is very little. And I think at 7 o'clock or 7:15. At 7:15 we will start the sky watching session on the science center.
Yeah, I will take it. So those of you who need to leave, that is perfectly fine. I think there are people asking me at any point of time. It is okay. We are not going to keep you captive or anything. So at any point of time, if you need to leave, that's fine.
Thank you so much.
And so we have want to take extra some paper for that activity. They can take because we have used it for the folding one. So I have kept it here.
Okay, so there are also these books that we wanted to distribute, but we will do it tomorrow because then everyone will be here. It will be simpler to do it. Okay, who wanted to understand the three-body diagram?
Of course, we should have been careful. We just got lost in the discussion.
We will take it. So those who have to leave, they can leave, but those who want to stay, just stay for some time, okay? Because it's still not that dark outside. So we'll need to wait. So pre-body diagram. Yeah, if you want to. Yes. We'll see you at 9 tomorrow. 9 o'clock. It is earlier. No, you guys might be late. 20 minutes. Pre-body diagram. Yes.
He's not satisfied with the explanation. He's doing it again.
I'm so grateful to have you.
I could have totally guessed that. You were like that.
Okay, yeah. So
yes.
no, come here. It will be easy.
Oh, sure.
Let's suppose we'll go to the execution and we'll also now let's consider this surface. One thing is now
Can we just
when you get
पहिलं लक्षात ठेवलं नाही लावलं तर तास आहे होत असेल तर आयटम तेव्हा ती सुरू आहे फक्त हे लावून हे चालू आणि पुन्हा थोडे उद्या किती वाजता पहिला
Okay, so people, let's move to the TLC so that we can go for the stargazing. So just we try to do like whatever time you guys will be around. It's fine. Maybe half an hour to 1 hour. There is some.
Okay. I haven't got my compass. What to do now?
I have the idea how to do it.
I see.
Government in place, or how many times?
See this one.
Because we need to write.
Sorry about that. Do it tomorrow. Definitely.